Jetzt? Jetzt. Welcome. So, since we meet in Bonn, I thought I should show you something Bonn-related. And our little publishing house has a series of very small architectural guides on single buildings in Bonn. And I do these with context. The lower row are the older ones. They are still produced with InDesign, and the upper row are these I did with context. Yeah, it's a bit embarrassing to have an introductory page as this is the only one here, but there's some interesting stories hidden here. My two colleagues, my co-founders of the publishing house, studied German literature in Bonn. I had no connections to Bonn at all. We didn't meet in Bonn, but in Bishkek, in the capital of Kyrgyzstan, where our wives worked in development aid. And I met Benedikt Viertelhaus there, and we decided to make an architectural guide about the very interesting buildings in Bishkek, mostly Soviet modernism. So we learned we can work together and we can make books together. So we decided to found a publishing house. And we took over 3 projects from their university times. That is the magazine on German literature, Kritische Ausgabe, Critical Edition. That's the latest issue. The architectural guides and a book series on German literature. So these little guides are not written by us, but by a group of mostly historians from Bonn University. They started in 2014 when there was an action group that tried to preserve Beethovenhalle, the big concert hall, from being teared down. And that's also the reason for some of the other architectural guides, that some of the buildings were endangered, and they wrote against tearing down everything that didn't look like the city government wanted to. So some of the architectural guides are founded by action groups, and building culture workshop is also giving guided tours and doing exhibitions and some things like that. The first architectural guides were made by Constanze Falke, who had to stop when she became a mother, and then I took over and remade the very simple layout in context. The single issues are very different from each other. Most volumes are on single buildings, for example, the City Hall of Bad Godesberg, but some are on settlements like Didinkirika or the Highcock settlements. That might be interesting because they were built for the employees of the US forces after the Second World War. Highcock is the abbreviation for High Commissioner of Germany. And there are some issues that are about collections of buildings, like the buildings of the university. So the structure is different. Also, some of the issues were written by single authors, others by working groups, with articles about different aspects of the buildings. For example, in a church guide, we have someone writing about the bells and about the organ and so on. But most are written by only one author. But it means that the structure and the table of contents is a bit different for every issue. No? Next one. Doesn't work. No. While, yeah, the architectural guides are mostly historically oriented. So all the cover images are black and white, even if the contents are often colorful pictures. I always try to find an image that goes over back and front, but you need to find a landscape image that has the important part on the right side, and that's not always possible. And I have to glue something together, like here or there. My setup only takes one image for the cover. I could have made it different, but it's like it is. We have a limited variation of image placement. I have here double spread images. I have one full page images, and I have kind of half page images. And that's it. It makes the layout quite simple. But all the images are going to the borders of the page. That means they need bleed, they need to go over the border a bit, so that they don't get white stripes after cutting. We have also maps. That's an interesting issue. I use OpenStreetMap data, and I started to work like this for the Bishkek guide. That has a lot of maps that show the locations of all the images, of all the buildings where we have descriptions. And for the Bonn guides, we have city maps where the buildings, the location of the buildings are marked. And I made one very big, I think A2 map of all the buildings that are mentioned in the guides. And you have the number of the guide where the building appears. The 11th, for example, are all buildings of the university. One is missing, the one around the corner here, the big one. We are here. You see some buildings nearby that I could look at, and this is a newer building that a part of the university, including Thomas, only moved in a few months ago. We didn't yet print the big map. We wanted to have it as a giveaway, as an advertisement for all the little guides. Well, I'm using OpenStreetMap data, but if you export it from the website or use Mapnik or like that, then you don't have vector data, or you can't use your own styles. So the only viable option was to use Maperative. It is written in .NET. And I'm working on a Mac, so I run it on Mono. And it's horribly slow. It's severely underdocumented, but it works. I could make my own style sheet with very subdued colors, nearly no colors. And what I wanted to say, it exports SVG. I post-process the SVG with Inkscape. For example, I need to delete some of the double street labels and then export to PDF. Nowadays, Context is able to use SVG natively via a metapost conversion that's built in. But since I have to do some post-processing, it doesn't make sense for me to use the SVG directly. I could try. And you might have also read in the tugboat that there is a context module to use OpenStreetMap data. Yes, it works. OpenStreetMap rendering via Metapost but it's more like a proof of concept. It's very limited. For example, if you have a street, it has a filling and it has an outline. Or for example, for a railway line, you need a thick white line and a dashed black line on it. But the OpenStreetMap renderer of context can only render each path once. So I can't do the different line colorings. And another limitation is it can't do labels yet. So a city map without street names doesn't make sense. It would be fixable, but my programming skills are not up to that. Yeah. The setup for the architectural guide is very simple. The latest issue I made in 2019, and then during the pandemics, we couldn't do anything because also the city archive was closed. It's a very crowded place, as you can imagine. It had a lot of reason to close the archive. So, well, our authors couldn't work, but we are planning to publish 2 guides within this year and another 2 next year. But in this time, a lot happened. Not only the pandemics, but also context moved to a new engine. My code is really old, and I can do better now. So I modularized my setup and try to make it better. That means I didn't get ready in time, and I don't have a working setup at the moment. The setup for the page layout is very simple. I show you this because many of you may probably never saw some context code. First, I set up the paper size, and if you set up a layout, then you always start with backspace. That's the binding gutter on the left-hand side of a right side. And then you define the width of the text area, and then the top space above the header, and the height is the height including header and footer. We don't have a header in this layout, but just a simple footer that only contains the page number. And to get the page number at the outer side of the pages, we need to activate the double-sided layout, and that's hidden in the setup for the page numbering. Then I told you about the bleed. You can see it here. There are the cut marks, trim marks for the print shop. The green border is the actual paper size after trimming, and the blue one is the bleed box. In PDF, the trim box and the bleed box. We need to define it. I defined bleed and trim as dimensions, measures in context. I could have used new dim. More about that in my article about calculating covers that will appear in the next tugboat. And then I activate the stuff for the print shop. The marking means the cut marks, and the location middle moves the final page from the left top edge to the middle. If you would look at a PDF that is text like this, you wouldn't be able to find the trim box and cut box and bleed box, because you need to activate it with this a bit obscure option. Setup interaction screen is meant for PDF viewer settings, and the width and height options activate definition of the trim box and the bleed box in the PDF. Yeah, but it wouldn't work because we only defined a simple paper size. But we need also to define the sheet size. That's the second option of setup paper size. The keyword oversized adds 7.5 millimeters. I could have made this explicitly, but I know that oversize adds this value. And so we actually get a PDF paper, a page size like the black box here. Then if I would send this to my authors or editors, they would be a bit confused how big the images actually are, the pages, and they maybe don't understand the crop marks. So I define two different modes, print mode and not print mode, actually just one mode. If I don't activate, oops, wrong one. If I don't activate the print mode, then I have the simple paper size. I set a lower resolution. I will come back to that. And I activate the interaction, that means the linking of the table of contents. We hardly have other references in the guides at all, but yeah, it's like I usually work. And I also activate a conversion to a lower resolution for the images to decrease the size of the PDFs. And in print mode, we have the bigger, the sheet size defined, a higher resolution. 200 dpi is good enough for printing, even if everyone tells you need 300. And I don't want any links in the PDF because it's forbidden in PDFX and print shops don't like it. And the downsampling of the images is done with a Lua function that I won't show you because I'm refactoring it. There's a very similar mechanism built in context to make grayscale images. You can automatically convert everything in a context document to grayscale, but the downsampling is not yet in the core. I hope, my calculations will become right. We will get it into the core. For the images, I need a lot of dimensions to calculate verb. For example, the half-page images like this are actually floats, but I don't want them to start in the type area, but they need to start in the bleed. So I move them up and outward. This is the top offset that I need for moving the floats. Then I use layers to place the images on. In LaTeX I now layers only from ticks. In context, you can just define them with the measures and where they start, and then you define them as a background. You can have several layers, you can stack them, make a list for the background setting. You can set them as a background for every page or only for areas like the header, the footer, the margin, or whatever. That's also how I did the skyline. On the title, I use another layer for the black title bar. The image just goes below the bar, and I have the definition of the layer, and I also set layer framed, put something in the layer. And I actually put nothing but the strut in there because that's in the setup, and the title can change, and I need to adapt it for different needs. For example, in this issue, there's a second line of text that lists the names of the churches, so I didn't include it in the setup. Image placement. For the whole page images, I made my own macro, and I am using postponing. That's a mechanism to put a whole page content on a special on a defined page. What does the macro do? It starts a makeup. That's a special layout page without headers, footers, and so on. You usually use it for titling. And yeah, the placement code defines if the width or the height is the leading dimension for scaling. And it also places the caption within the image. I will show you an example of that later. The double page looks the same. It splits the image in the left and the right half and puts the half of the image on the left or right page. The half page images, the macro looks the same, but the implementation is completely different because this one uses floats. The full page or double page images don't use floats. I have a defined width, the whole paper width plus the bleed. But since I'm working in grid mode, it means all the lines are on the same line grid on all the pages. Also, the images must sit on the grid lines. And then I have a discrete set of possible height options. And I need to calculate this for the Lua function because, well, I have the top offset and then a number of lines, and it's a bit complicated. I will skip it now, otherwise my time runs out. That's a part of the implementation. Start place figure, bleed figure is just a custom float. It has a location, it has a reference, the title is the caption. The offset command moves it, the clip command trims the borders. Well, these are I have captions within the images, and they get a background shadow to make them more readable. It's very subtle in the clip from the image. The background is just Metapost graphics. I think it's just the same mechanism as what was used in Beamer. I use a transparent color and put 10 or whatever boxes with slightly differing sizes on each other. But as you can see here, it's not really beautiful because it's always a box. And it would be better to have a background just behind the type. And I just found out only last week how to do this. The function is in context in 2021, so I couldn't have done it in 2019. Okay, that's the shadow with rounded edges and so on, around corners. Okay, this works now, and it looks better, and the code is even simpler. It's just the LMT outline function is part of MetaFun that works only with Lua Metatech. It just produces the outline of a font, and then I do the same. I put several outlines in a transparent color on each other. This time 10 layers, and yeah, the color is a bit irregular because in some places there are several layers from different letters that overlap, but I think it's still better than the previous solution. And finally, I put the text in white on top because it wouldn't work otherwise. Yeah, and then I can use a simple macro like this. By the way, start text definition is a fancy kind to say def or define. You can also use name parameters with that. Yeah, that's it. That's the end is also an application of the LMT outline function filled with an LMT Poisson pattern. Yeah, we were playing around with the possibilities on the mailing list last week. Are there questions?
Thank you. Getting good typography for small booklets is a hard task, and so yours is very nice. Any questions or remarks from? Yes.
I was just wondering, compared to the sort of InDesign type process, once you've got all this set up, how long is it taking you to actually produce the book? With the,
I didn't understand.
Once you have it all set up, how long does this take you to actually produce the book?
Is it better or worse than InDesign in time?
The question is about
I'm hard of hearing, so
no. The question is about: is it longer to get this type of setting with context or within design?
Hard to tell. You spend the time on in different places. If you do something with tech, the basic typesetting is very quick, but you need hours if you want to place a float in a special place. In InDesign, you can place an image, but you need hours to correct the typesetting. Sometimes. This was made in InDesign, and it wouldn't be possible in tech because it's too individual. I think I'm after some of the guides, I got quite quick. But if you only make one publication, the setup needs a lot of time.
Thank you. Any other question? So, if not, we can thank our speaker again.
Thank you. Guides, I have some.
That's. Oh, thank you. Okay. Our next speaker is Thomas Schmitz from Bonn University, who will talk about producing different forms of output from XML via context.
Very much. Good morning, everybody. I will be showing my today's work. Can I use the microphone?
You need to switch it on, I guess. Okay. Oh, yes. No.
Okay, thank you. Let's see if I get it. Yeah, that sounds better. Okay, so what I'm going to be showing you today is the actual workflow that I use every week during our teaching terms.
I teach ancient Greek at Bonn University. My department, Robin has just mentioned, is just across the street, the modernist building you can see when you step outside here. And I have to give, and I enjoy very much giving, a lecture course of about 90 minutes every week of the term. And the lecture course this year, let's see if I can, this works. Nope. Oh yeah, there it is. So the lecture course this term, which ended just yesterday, was on the Athenian poet Aeschylus. I've been teaching in Bonn now for 20 years. You can see I'm not that young anymore, and over the time I have changed and adapted my workflow for this lecture course. About 18 years ago, I began using TUG for various tasks. I switched from LaTeX to context a couple of years ago. At first, I used context to produce my own lecture notes, then I used it to produce the slides, and then I discovered that I found it extremely helpful to have the text of the slides and my own notes in the same source document, and I looked for ways to produce all the materials from one and only one source document. I experimented with different formats, and in the end I settled for XML as a source. Why? I don't want to become dogmatic or generalizing here. I just want to point out that for my purpose, XML presents a number of important advantages. It is easy to reuse in other programs. If, for example, I want to take a part of my lecture for an article or a book, that's easier in XML than it would be in a TUG document. And as we will see, it allows output in different formats because of the way it is processed in context. Maybe it's best if I just show you what I mean when I say different formats. First and foremost, of course, it's the slides that I show in my lectures. That is something I want to produce from my source document. They should help students understand and master the subject, and they contain different forms of material, such as pictures. Here you see a beautiful picture of a papyrus fragment, an ancient papyrus. Or they contain tables. This is one table that shows the content and the dates of individual classes for the entire term. And of course, most of my slides contain texts and translations. I teach a philology after all, so this is the basic setup. You see text translation with markings and so on. The slides themselves have been produced with the context module Simple Slides that Aditya Mahajan and myself wrote a couple of years ago. Aditya, I should say, contributed most of the clever code. I applied it and thought of different appealing visual styles that I believe would good look for presentations. Of course, the code for this module, the several different styles, everything is publicly available. You can download it from contextgarden.net. It is absolutely not as powerful and versatile as the famous LaTeX Beamer class, but it offers a number of, as I find, interesting and nice styles for slides and makes it easy to produce such presentations. I'd always made these slides available to my students simply by uploading them to my departmental website, and then a couple of years ago the students asked me to provide the slides in a format that was easier for them to handle and to reuse. So that is the format that I produce on an A4 sheet. The left side has a very simplified and scaled down version of the slides, minus all the decorations, the backgrounds, the fancy effects, but still keeping all the important elements, the text, the table, the images, and so on and so forth. The right column is blank, so students can take notes on these sheets that relate directly to the slides, that help them to relate the material or their notes to what they've been seeing in the course. This wasn't my idea, I should say. It was the students themselves who came up with this format, and I find it excellent. It's a very efficient use. Finally, I also generate handouts from my XML source when I give an individual lecture at a conference or as an invited speaker. These handouts are the way they usually look in the humanities, which means you have text passages, you have translations, and in the end you have a bibliography. For a lecture course, it's only the bibliography, as you see here. And as you may be able to see, it's a bit small, I know. I'm a huge fan of numbered bibliographical styles because they make it so much easier and faster to refer to items on a list during my talk or during my lecture. Saying this is book number 77 is of course much faster than describing this appeared in 1989 and so on. So this is, if you want, the client-facing side of my business. But of course, as important is the material that I produce for myself, that is the notes for my lectures. This is a no-nonsense, very basic format for my manuscript. The locations where I have to change slides are simply indicated by red numbers that you can see here in brackets. The slides themselves are not rendered, so I just know now I have to change slide because this is where slide 6 and 7 is coming up. This format is very readable on a small device, such as a tablet or even a huge phone, and it has the benefit that the amount of text on these index cards is pretty standardized, so I know exactly how many pages I will need to fill a 45-minute presentation. I know I need about 20 to 22 of these index cards that will exactly fill a 45-minute presentation, so it helps me preparing. In general, however, I prefer to have a manuscript with the slides on my tablet when I give a lecture in exactly the form, the slides in exactly the form that the students see on the big screen, which of course is behind me as it is here. So I have this format that has the slide on top and then the text of the lecture below that. All these different formats and outputs are produced from one common source file. Let's call it lecture.xml. This file is then compiled with context. There won't be time today to go into all the details, but I want to just point out a few features of how to process XML with context. Like most things in context, you just saw some examples in Raban's talk. This is done via setups. You collect all of these setups in an environment file. You see here the beginning of such an environment file, just a few remarks. The setups are collected in start-stop pairs. That's what you see in line 1 and line 5, start-stop. Line 2 is important. It means drop everything. Do not typeset any element unless it is explicitly mentioned in the following list and has its proper setup. If this line is not there, context will use some heuristics to typeset at least the text of every XML element, but I wanted to drop everything unless I tell it to produce something from it. And then follows a list of elements hierarchical from the root of the XML file down to all the other elements. After collecting these elements that you want processed, you create setups for every single individual one. They all live in the XML namespace. And just to give you an idea of what these setups look like, I show here some examples, some very silly and easy examples for an element presentation. The easiest command is in line 2, XML flush. It takes the content of the current element, in this case the element presentation, and puts this content into the text stream, where the text will be typeset, sub-elements will be processed according to their own proper rules that we define, and so on and so forth. After every element that's in line 3, you see, context will insert a paragraph break. Of course, you can apply all the usual context commands to the content of the element. In line 7, we flush the content of the element inside a command that will apply the color red to all text, and it inserts at the end a page break at the end of these elements. No, I shouldn't. These are choices. You have to choose between them. You can't have them all in your own file, of course. You're right, yes, they shouldn't. So in this case, presentation would put a page break and it would typeset everything in red. If the element presentation has an attribute title, this attribute can be retrieved and typeset with the command XML at, that's in line 12. And then we use this attribute title to produce a section with a title. We flush the content within this section and we're done with it. If you want to process individual elements via Lua, you know that context now has the full power of Lua at its disposal, and as we will see, some things are easier to do in Lua than they are in TUG. You need to create a setup in which this is made explicit, as you see here in the upper part of the slide. So you say you have an XML setup that says XML function, which means you just hand this content to a Lua function. This function takes as its argument the content T of the current element and passes it on to Lua in the form of a Lua table. That's why we call it T. This allows us certain shortcuts, as we will see. We then define this Lua function sml.functions.framed in this case. Within this Lua function, we have access to both all Lua commands and to context commands, and this makes some tasks somewhat easier. I show, again, a very silly example just to give you an idea. In real life, of course, everything is messier and more complex. First, we define a numerical value scale factor that depends on the context mode that we're in. If we're in mode print, where slides are typeset with reduced width, you just saw an example, this value will be set to 0.5. In all other modes, it will be set to 1, as you can see in lines 2 to 6. We then use this value, this scale value in line 9. We multiply the value of the attribute width of our XML element framed. This is what the shortcut t.add.width refers to. First with a scale factor, and then with the dimension text width. The result will be that this frame will be spread across the entire page. It will have the text width in other modes, and in print mode, it will be multiplied by 0.5, so it will spread across half the page. Within this frame, we then flush the content of our element. Line 10 shows one difficulty or one little thing that you have to do from time to time. Some context commands need to be finished before the typesetting can begin, and this is why we need this somewhat clunky function and then end here in line 10, which doesn't look very nice, but from time to time you will need it. If you want to learn more about these details, you can look at the manual CLD, which is part of the context distribution. This then, in short, is the way context produces XML. Let us now look at the setups that I use to derive different forms of output from my XML source. And I begin with a schematic representation of my workflow. In order to compile the XML file, we need a context style file, style.tag, which is coupled with a Lua file, style.lua, where the Lua commands are defined, as we've just seen. Some things are easier, at least I find them easier, when you have the power of a programming language such as Lua, rather than doing everything in pure TUG, even though I know that some TUG wizard would be absolutely capable of doing everything in TUG. Over the years, the code has become rather complex, so I won't try to show you the details, but only some main lines. And I hope you will see why I've chosen this workflow and what advantages it offers. Let us begin by having a brief look at the main structure of my XML file. The text for the entire lecture course is in this one XML file, which will grow to around 30,000 lines over the course of a term. The structure is very simple. We have a root element, lecture, which consists of a number of individual presentations. Each one of them, as you can see in lines 2, 9, and 16, has a title and has content. And the content consists of the text, this is my own notes, and the slides that will be shown on the screen, as you see here. When I compile, it's obviously efficient to have all chapters, all the presentations in one single document, because it makes it easy to create cross-references, makes it easy to create a bibliography with consistent numbering that will not change over the course of these lectures. However, when I want to compile slides for an individual lecture, I don't want all slides included in the resulting PDF file, which would be huge, including all the images and so on. I just want the slides for my current lecture. That's why every individual lecture has a date tag, as you see here. I have used or abused something that Robin has already mentioned, which is a feature of context called modes. It provides a means for conditional typesetting. With modes, you can exclude or include parts of your source during the typesetting process. This is where the date tag of the individual lectures comes in handy. When you want to process XML with context, you define in your style rules for every single XML element. We've seen that. In our case, that would be the element with the name presentation. This is what line 1 does. And then we set a mode. The following code will only be seen by context when it is in mode presentation. Inside this mode, we nest another mode. This time, the mode is set from the date tag of the presentation. That means context will only typeset a presentation element if its date tag is equal to the mode value that we pass to it. How do we achieve this? You pass these modes to context on the command line when you compile your document. So this is what mode presentation, we want to be in presentation mode, and then 230516 does. Context will now only produce or will only look at the XML code of the presentation with the date tag 230516 when it's in presentation mode. In other modes, for example, to produce my lecture notes as index cards or to produce a handout, it will process the entire presentations, everything in the document. Let's have another look at this conditional processing. Here's the context code that will process the element slide. Here it is. When we're processing in presentation mode, which we do from line 2 on, context will pass the entire content of this element to a Lua function presentation slide, where we take care of the elements, we include pictures, we typeset tables and text and so on. However, when we're in the mode cards and want to produce our index cards, something else happens, and that is what happens in lines 5 to 8. Context in this case will, whenever it sees a slide, only increase a special counter for the slides by 1 and typeset the result on its own line. We've seen this, the result, a couple of minutes ago. This way, I will never have to worry about forgetting a slide in my manuscript, something we've all seen happening. The presenter is talking about the next slide, and the older slide is sitting there, and he doesn't realize, or she doesn't realize. In my case, I always have these red numbers that remind me you have to change the slide. When we're in combined mode, the content of the element is passed on to a Lua function that is defined in style.lua. We have seen the general outlines of how such Lua functions work. Here we find another example of things that I find easier to do in Lua than in TUG. As we've seen, context transforms every XML element into a Lua table, and we pass this table T as an object to the Lua function combined slide. That is number 4, line number 4 here. We retrieve the current tag, which is the date of the current presentation. That's what we do in line 6. We know that the presentation is the grandparent of the slide. Remember, the structure was presentation, content, and then slide. So we have to go 2 levels. We have to move 2 levels up to find this tag. This information will be used in line 12. The slides for every individual presentation are stored as PDFs in a subdirectory presentations and are named after the current date. So the slides for today's presentation would be in a document called 230715.pdf. Line 12 constructs this file name and retrieves it as an object of the context macro external figure. Line 13 retrieves from this PDF file the page, one page, only page I from this PDF file, and since the counter of I will be increased every time this function is called, that's what we do in line 1, it will retrieve all pages in ascending order every time this macro is called. Before the current slide, context inserts a page break. That's what line 8 does. This way, the current slide will always be on top of a new page above the text that explains this slide. And since it retrieves the slide from the actual presentation that is shown on the screen, it will look exactly the same as what the students see on the screen. This then is the general mechanism to produce different forms of output from a single XML file. We use context modes to apply different setups to XML elements. Depending on which mode we're in, the slides or text for notes will be typeset. The slides may increase a counter, or they may be included as images. I could show more examples of code, but I think the general principle is clear now. I want to conclude with 2 special use cases that have been useful to me over the years. The first is, I've come to like XML as an input format. I know many people hate it with a passion, but I think it's a very, very readable and nice input format. If the input file is valid XML, it should compile in context, so you don't have to worry about forgetting some brace or whatever it is. In the beginning, this can be quite tedious, I agree. For everything you want to include in your presentation, you have to come up first with a proper XML representation, and you have to find a way to process this XML in context And if something goes wrong, which never happens, of course, but in theory it might happen, there are always two layers to debug, the XML and the TEG. One disadvantage was that some things are really easier in TEG than in XML. For example, producing metapose graphics. In theory, you could come up with a way to write XML code that would then be translated to metapose code and typeset and displayed on your slides, but this would be really, really painful. Wouldn't it be wonderful, I thought, to have some way of writing metapose code or even any other TEG code and have it processed when context reads my XML file? This is something that hadn't been possible from the start, but Hans Hagen, of course, is always very gentle and nice with his users. So when I asked on the list, could you do this for me, he implemented it. We now have a command get buffer that will process included TEG code, and here's how it works. Whenever my XML file is processed, context looks for a file called presentation buffers. This is what we do in lines 5 to 7. If presentation buffers exist, it inputs it into the stream, line 5 to 7. And this file contains, you may have guessed it, several buffers with text code that I just retrieved during in my XML processing. I then define an XML element get buffer, which takes this buffer, processes it as TEG, and includes the result in my slides. As an example, I show you a few lines of metapose code that I have used for this presentation today. It would be possible to do all this in XML, as I said, but I save myself lots of typing by just keeping this in a separate TEG file. Another area where this comes in pretty handy is something that I had to learn the hard way, verbatim code. When you process XML, cat codes have to be changed, and this appears to be problematic for including verbatim code. In particular, I had problems having XML code within the XML processed verbatim. So I cheat and include it in a TEG buffer, and this approach appears to work very well. Finally, a very easy way of simplifying processing these XML slides. Typing all these context, environment, mode calls all over again was getting pretty old after a while. So I wrote myself a little make file. It defines targets for the different output formats. It uses a variable day, which is then passed on as a context mode. It runs context once. It copies the resulting file to a new file that has this date as a name. It's nothing fancy, of course. It's just a way to save some typing in the terminal when I produce my slides. So this concludes my talk about processing XML with context in order to produce different output formats. I couldn't go into details here, as I said. I've been using this system for a number of years now, and it has become pretty complex, but it's also very easy to reuse part of an older lecture in a new one, because I just have to copy and paste individual parts, and they will always fit in because they're all valid XML. Thank you all for listening. I hope there has been some interest in using context to process XML. I think there's a bit of time left, so I will be happy to hear your comments and to answer your questions if there are any. Thank you.
I'd like to give you heads up for the numeric references for bibliography. That in humanities is not so frequent.
That's right.
As I know.
Because it's difficult to produce.
So are there any questions? I guess it was very interesting.
Sorry, I'm being interrupted from behind. So, so a lifetime ago, I wrote an XML parser in tech, but I don't use it. I mean, in my day job, I'm processing XML in multiple forms every day. It's what I agree with you that it's a lovely input format. But what I do, I use XSL, so I can have full, because I'm doing you have lots of different formats, but they're very linear. I mean, you don't suddenly want to print lecture 5 first. Mm-hmm. So I'm reorganizing things a lot more. So, I mean, did you consider using an XML tool such as XSL to generate context or tag, rather than using the tech? Mm-hmm. I mean, how much power do you lose in really reformatting the XML with a query language?
I don't think I lose any power. It's just it may be very tedious because you have to think about translating it. But in fact, anything you can do in context, you can do via XML. So there is no real loss in there. It's just, it may take a little bit of time, but as I know I will reuse this style year after year after year, it's worth the investment. So no, it's not something that I would consider, let's say, facilitating what I do. It wouldn't be easier once you have the process in place, of course.
Any other question? Yes.
In terms of debugging, do you have some kind of pre-processing flow, like an XML schema, or do you just typeset and hope for the best and maybe debug an error?
Well, as you see, I'm not very young anymore, so I use Emacs for XML writing, and Emacs... And Emacs has an XML mode which validates XML on the fly. So that's what I use. I don't have any pre-processing. I could use any number of instruments, but the XML is not very complex. Oh, the Emacs Vim war is going on. So it's not an incredibly complex XML. So Emacs is really sufficient for me. And as I said, if I see in the Emacs line a valid XML, I know that it should process.
Any other question? If not, oh yes.
It's not a question. I just want to see the slide with the workflow inside of it, the flow
Sure.
chart.
Let's see. This one?
Thank you. Yes.
Sure. I mean, all the slides are already on the web page, so you can just download them and look at them. Beautiful, isn't it? That's what context does. Okay.
Okay, thank you. Any other question? So thank you again for the very nice talk. So you are in name of the other speakers. Sorry, because we have all full names here. But I'm just announced you.
No, I'm the one before that. I'm the third one. I'm the third. I'm the third speaker, not the version.
Okay, sorry. Next speaker is Vít Novotný. We talk about Markdown 3, what's new and what's next.
So, thank you, and good morning, everyone. My name is Vít Novotný, and I have traveled here from the neighboring country of the Czech Republic to celebrate with you the third major version of the Markdown package for tech. Whenever I'm asked to explain the Markdown package, I find it useful to focus on the different audiences for who the package is intended. The first and most important audience are the authors. During my undergraduate, graduate, and PhD studies of computer science, I used LaTeX for anything and everything, from note-taking, homework assignments, presentation slides, to short books, journal articles, and ultimately my thesis. However, only the simplest of texts are written in one go. For most texts, the first draft will need to be edited, reread, rethought, restructured, often multiple times, before it is ready for general consumption. Over the years, I have discovered, and others have also remarked, that LaTeX is perhaps easy to write, but difficult to reread and think about. There is a certain bravado in my experience about this subject in the academia, where the authors can be proud about their ability to read LaTeX, but in my experience, a lot of effort is wasted on the extra cognitive load of reading the code, tinkering with the code, instead of focusing on what should be the main focus, which is the text itself. In my graduate years, I started teaching a university course about digital document production, a broad and fascinating subject, as I think we can all agree. And I fell in love with lightweight markup languages, which use punctuation to denote structure and which are easy to both read and write. Markdown was a prominent lightweight markup language, widely used for blogging, instant messaging, online discussion forums, question answering forums, and software documentation. Due to my interest in Markdown, as well as my other interests in LaTeX, compiler design, and too much free time on my hands, I proposed to my university a project that would allow authors to use Markdown instead of LaTeX in their writing. And the project was greenlit, and I received a grant, which allowed me to work on the Markdown package for TUG alongside my studies. Since then, 8 years have passed, and the Markdown package has matured to the point where authors can confidently, hopefully, use Markdown to write complex texts containing tables, figures, lists, footnotes, among other things, and produce beautiful documents using TUG. In this presentation, authors will learn about new types of elements that they can use in their writing. Even in LaTeX, where many authors will switch between the two roles of an author and a programmer, there is often a division of labor, where a publisher will hire a TUG expert to prepare a template according to a design spec, and this template is then used by authors to produce documents for the publisher. For the expert, the Markdown package for TUG is an important tool in their belt, which increases their value on the job market. This is because the Markdown package was designed as a white box, which allows all aspects of Markdown text to be defined in terms of TUG macros, down to the individual elements, such as headings, hyperlinks, or footnotes. Therefore, the expert can produce a template and then add extra code that will make sure that the Markdown text produces output that is consistent with the template. Furthermore, the Markdown package for TUG supports not just LaTeX, but also plain TUG, context, and other formats. This further increases the value of learning the Markdown package for TUG as a common framework, similarly to TIGZ, Expl3, and other frameworks which are available across different TUG formats. In this presentation, the TUG experts will learn how they can style Markdown elements in different TUG formats. Besides authors and TUG experts, there are also software developers who contribute to free open source software projects, such as the Markdown package, to educate and challenge themselves, to collect bounties on outstanding issues, and to take part in the governance and maintenance of the projects. For the developers, the Markdown package for TUG presents a unique challenge, a heterogeneous and layered code base in more than 6 different programming languages that contains lessons in systems architecture, compiler design, and digital typography with multiple interfaces and with bindings to external tools such as Pandoc, GraphViz, and others. The developers can either focus on one of the many different modules that suit their narrow interests, or they can combine their skills and tackle the more difficult challenges that affect a larger part of the heterogeneous whole that is the Markdown package. In this presentation, the developers will learn about the implementation details of the Markdown package and its governance. Furthermore, they will also learn how they can develop syntax extensions that add support for new Markdown elements required by authors and publishers. In the first part of my presentation, I will focus on the new features of the Markdown package that have been developed in the past 2 years. These include the implementation of the Common Mark standard, which will make Markdown documents written for the Markdown package easier to export to different Markdown processors. Then the Markdown elements supported by the Markdown package. Then the external bindings and new TUG formats that we now support. The new TUG and Lua packages that have been separated from the Markdown package because they are generally useful even outside the Markdown package, and also the current governance of the Markdown package. Then in the second part of my presentation, I will focus on the features of the Markdown package for TUG. Not features, on the future of the Markdown package for TUG. Here, I will first focus on the roadmap towards a stable release of version 3.0 of the Markdown package in the next few months. And then I will focus on the planned features and governance past version 3.0. Because, yeah. So first, let's look at some of the new features of the Markdown package, which you can use today. The Markdown language was developed in 2004 by John Gruber as a Perl program that would convert Markdown text to HTML websites. And this program was accompanied by a free-form text description of the language. As the language became more popular, different implementations, including the Markdown package for TUG, were developed, which behaved differently in some corner cases that were not covered by Gruber's description, and that produced confusing results in the original Perl implementation. In order to prevent further fragmentation and to improve interoperability, a standardization effort led by Jeff Atwood and John McFarlane produced the Common Mark standard, which disambiguates the Markdown language. In the bachelor's thesis, my student Andrej Genčur from the Masaryk University in Czech Republic implemented the Common Mark standard to the Markdown package. The implementation is available in the alpha release of Markdown 3.0, which is available for download in the digital repository of the Markdown package. Not on C10 yet, more on that later. This change allows authors to produce Markdown text that can be easily used across different Common Mark implementations or converted to other dialects of Markdown, as well as other markup languages that may be required by the publisher. Although Common Mark provides a strong foundation for writing documents in Markdown, many useful elements, such as tables, footnotes, and citations, are not included. Therefore, the Markdown package for TUG provides syntax extensions that allow the authors to write these elements in their text. Whereas Markdown can be used to write the body text of a document, it is ill-suited for denoting structured metadata, such as the title, the authors, or the abstract of a document. YAML, on the other hand, is a data serialization format that is a superset of JSON, and that provides a way to denote document metadata that is easy to both read and write. Several implementations of Markdown, including the Markdown package, provide support for mixing Markdown with YAML, which allows authors to combine documents, document metadata, and document text in a single source file. Tech experts can define the meaning of the different YAML keys, such as title, authors, and here, in the example here, which allows publishers to specify which metadata should be provided by the authors and how they should be formatted in the produced document. In heavyweight markup languages, such as XML, authors can attach attributes to elements to denote additional information. For example, section identifiers for cross-references, classes that provide different formatting for the same Markdown element or for the same XML element, or key values that specify the dimensions of a figure. Several implementations of Markdown, including the Markdown package, allow authors to attach attributes to elements. Tech experts can define the formatting of different attributes based, again, on the requirements of the publisher and also the authors. In complex documents, authors will often write 90% of the text in Markdown, but they will need to use TeX for the remaining 10%, which include complex tables, figures, and math. Therefore, the Markdown package has always allowed authors to end a block of Markdown text at any point and switch back to TeX. Furthermore, to allow adjustments to hyphenation, spacing, and the typing of text macros inside a paragraph, the Markdown package has always provided the option to enable what we call the hybrid mode, which allows authors to freely combine TeX with Markdown. However, enabling the hybrid mode alters the Markdown language, which makes Markdown documents less interoperable. Nevertheless, the sheer usefulness of the hybrid mode causes it to be enabled by default in many templates, which we think is a problem. In order to phase out the use of the hybrid mode, the Markdown package implements 3 syntax extensions that do not affect interoperability. The first one is the one you can see here. Authors can denote what we call raw code blocks and also raw spans that will be interpreted as TeX code. Another option is to place large blocks of TeX code into a separate file and include it in the Markdown document as an external resource. And for math, authors can also enable a syntax extension that allows them to freely type TeX commands and other characters between $signs or / escaped characters. Several implementations of Markdown, including the Markdown package, also provide support for additional syntax extensions which allow authors to write the following elements in their document: task lists, emphatic line breaks, superscripts and subscripts, and strike-throughs. And for each of these elements, again, TeX experts can define the formatting based on the requirements of the publisher. To make the Markdown package more broadly useful, support for new formats other than plain text, LaTeX, and context has recently been added. The new formats supported by the Markdown package are TeX4HT, which authors can use to produce websites instead of PDF documents for printing, and also OpTeX, which is a minimalist format based on plain text, which still offers to the TeX experts many of the bells and whistles of larger formats, such as built-in font selection, bibliography support, syntax highlighting in code listings, hyperlinks, and more. So if you'd like to try these, there are example files that you can just download and typeset. I have mentioned PenDoc several times. PenDoc is a document conversion tool that can convert between dozens of documents formats, including various formats of text. However, PenDoc produces raw TeX code, which makes it difficult to alter the appearance of individual elements of the text without hand editing the output of PenDoc. In their bachelor's thesis, my student Dominik Rehak has developed a binding between the Markdown package and PenDoc, and this binding allows authors to type their documents in a text processor, such as Microsoft Word, and then typeset their documents through the Markdown package as though they were written in Markdown to begin with, and benefit from the existing templates for the Markdown package. The Markdown package implements many useful functions, and some of these functions are general enough that they can be separated from the Markdown package and provided as a standalone package to the community. As we have already discussed, the Markdown package allows authors to write document metadata using the Markdown package, the markup language of YAML. Previously, the parsing of YAML was provided by an external Lua library called TinyYAML, which was distributed as a part of the Markdown package. However, thanks to the contributor Zeping Lee, TinyYAML is now available as an independent library on C10. Secondly, although the Markdown package uses Lua under the hood, it works seamlessly with other tech engines such as PDF Tech and ZTech. And the ability to execute Lua code with any tech engine is now provided as a part of the LT3 Lua Bridge Expo 3 package, which is also available on C10. So 8 years ago, when I began the development of the Markdown package, I made all the decisions about this direction. Nowadays, a number of authors, tech experts, and developers participate in the development. And previously, all communication took place at GitHub, which favors developers, but is less welcoming to authors. And therefore, we have recently added rooms at the Discord and matrix.org, instant messaging, social platforms, where authors, tech experts, and developers can discuss their issues as well as the future of the Markdown package. Next, let's briefly look at some of the features of the Markdown package that are planned for the near future. At the end of June, we have released the first public alpha of Markdown 3.0, which you can download at GitHub. We plan a stable release of Markdown 3.0 in September, and we plan to release on C10 before the release of TechLive 2024 to ensure that all versions of TechLive 2023, whenever you have taken the snapshot, still contain Markdown 2, which we think is the responsible and sane thing to do, because the changes between Markdown 2 and 3 are substantial. More on that later. So the first reason why the current release of Markdown 3.0 is marked as an alpha release is due to a number of open issues. Namely, the implementation of Common Mark has introduced memory leaks. These have been hotfixed in the alpha, but will need a proper fix before the stable release. Furthermore, the implementation of Common Mark has increased the number of unit tests 6 times, which has caused performance issues with our continuous integration service. In the alpha, we have temporarily reduced the number of tech engines that are automatically tested, but this may have caused us to miss regressions in other tech engines. Therefore, we will need to improve the speed of unit tests, restore the full testing, and then see if any regressions have been introduced in the meantime before the stable release. And lastly, the implementation of attributes in the Markdown package is slightly incompatible with other implementations, such as Pandoc, which we will also fix before the stable release in the next 2 months. Besides open issues, the other reason why the current release of Markdown 3.0 is an alpha release is due to a number of planned features that have not yet been implemented. The first of these features is a syntax extension that would allow authors to write attributes next to not only figures, but also tables, which we think will be quite useful to authors who need to reference their tables from the text. The other feature are what we call tech-like rich paragraphs. As you may recall, the language of Markdown was originally developed as a preprocessor for writing websites in HTML, and in HTML, block-level elements such as lists always end a paragraph. However, a typographer may use a list as a way to typeset a series of items inside a sentence, and clearly such a list should not end a paragraph. And in most tech formats, such as LaTeX, you can write such a list by omitting a blank line after the list. Our syntax extension will empower authors to do the same in Markdown. By omitting a blank line, the authors can indicate that the end of a block-level element, such as list, should not enter the current paragraph, similarly to tech. So if you're going to try the alpha release of Markdown 3, which we encourage, and you are a long-time user of Markdown 2, you should be aware that a number of deprecated features have been removed in Markdown 3. Namely, we have removed the hard line breaks option, which has previously caused all line breaks in Markdown source to produce a line break in the output, which can be useful, for example, when typesetting poetry. In Markdown 3, however, all line breaks in Markdown text produce a soft line break TUG macro, which produces no visible output by default, but which can be redefined by a TUG expert to produce, for example, a line break or something else entirely in the output. Furthermore, we have renamed a number of elements to more clearly indicate their semantics rather than how they are commonly formatted. These include footnotes, which have been renamed just to notes, and horizontal lines, which have been renamed to thematic breaks. If you have an existing template for Markdown 2.0, which uses some of the deprecated features, you can either use TechLive 2023 and earlier with your template, or you can distribute Markdown 2 together with your template, and you can use TechLive 2024 and later. Or you can hire a TUG expert who will be happy to update your template from Markdown 2 to Markdown 3, I'm sure. So after the stable release of Markdown 3, we have a couple more features already in the plans. The authors can look forward to new syntax extensions that will allow them to automatically generate section identifiers for cross-references. Currently, authors can always write multiple paragraphs of text and use block-level elements such as lists and figures. However, this may be undesirable in some situations. For example, a TUG expert may create a template that will use a Markdown document provided by the author to generate the head and foot of a document. And here, it is desirable that the author can only write inline text. Therefore, we are planning an option to control the content level allowed in Markdown text. Furthermore, we are planning to add a mark inline TUG command that would allow authors who still prefer TUG to use inline Markdown text just here and there in the middle of a paragraph to get familiar with the syntax and perhaps to even improve the readability of their document. As previously mentioned, the Markdown package already supports the optech format. However, this support is currently limited, all inside an example document, in addition to the text which is typeset in the example document. And in the future, we would like to move the optech implementation into a separate module, which the authors and TUG expert can just import from their documents. I have also mentioned that my student Dominic Rehag has developed a binding between the Markdown package and Pandoc, which makes it possible to typeset a dozen of document formats through the Markdown package. However, the Markdown, the implementation is just a proof of concept in Lua, and in the future, we would like to add a proper implementation in Haskell directly into the code base of Pandoc, which I have already discussed preliminarily with the lead developer of Pandoc, John McFarlane, as well as others. And yet another thing, although it is best to use the template developed by a TUG expert, the Markdown package provides default formatting definitions for most elements, which the authors can use as a starting point. However, these default definitions are often insufficient, and they also clutter up the code base of the Markdown package. Currently, TUG experts can also use the concept of theme when developing a template for the Markdown package in LaTeX. And in the future, we are planning to bring the concept of themes to all the supported formats in a way that will allow a single theme to have multiple formatting definitions for different TUG formats. And using this new tag, we are planning to create a single default theme that would encompass all the default formatting definitions of the Markdown package. And this theme would then be maintained separately from the Markdown package, so which would allow for a more serious implementation than what we have now, which is a placeholder in absence of a proper template. As previously mentioned, we now use instant messaging social platforms to discuss the future of the Markdown package. However, a lot of tech-related discussions take place at mailing lists, and therefore in the future we would like to create a mailing list for the Markdown package. And if the Markdown package and its user base grows further, we will need to explore some options for more decentralized governance, so that it's not just social platforms and me, but some voting and so on, so that the features are decided in a more transparent way. So in conclusion, in this talk, we have discussed the new and planned features of the Markdown package for tech from the viewpoint of three stakeholders: authors, tech experts, and developers. In the words of Petr Sojka and John Lennon, I would like to say, please, all we are saying is give Markdown a chance. And I hope that you have found the talk interesting, and I will be happy to answer any question that you may have either now or during the coffee break or in the rest of the conference. Thank you.
Thank you. Are you planning to get a conversion from an MD file to a .tex file?
What kind of file? .tex file.
You write a .md file for Markdown, and you can convert it to a printed version using TeX, but can you convert it to a TeX file?
Yes, the Markdown package provides a Lua command line interface, which you can use to take a Markdown file and convert it to this intermediate representation in TeX macros, and you can then use it as you like.
Okay. Are there any questions? One here.
To be honest, I'm a bit skeptical. Do we really need yet another markup language? LaTeX is a well-defined language already, but some people say, oh, that's far too complicated for me. I need a simpler one. But the more features you add to your markup language, the smaller this advantage gets. And when you, for instance, two number signs, are they really more readable than a section command call, for instance? And a host of problems. And the more special characters you define, the more nasty surprises the users will get with old documents, because suddenly a special character has a special meaning rather than to be presented in verbatim mode. So I see a lot of problems with just another markup language, more problems than advantages. So right. It's just more a remark than a question.
Right. I'm not sure what the question exactly was. I will address some of the points that you raised. So in LaTeX, there is even a concept of a document markup language, which LaTeX 2E is one possible markup language, but the LaTeX project assumes that there will be several markup languages which the authors can use and which the backend will be sort of independent on, right? So it will all be LaTeX, but there will be different markup languages that the authors can use. So like the idea of adding another markup language is part of the ethos, I think, of the LaTeX project. You also mentioned special characters which may cause trouble. When we're typesetting the Markdown text, we switch to a special catcode regime, so that should not be a problem. But we switch back whenever you have this raw tech block which you're using, where you're using your own tech macro. So this should not cause any trouble for you as the user.
Any other question?
Not really a question, but just a comment/offer. You have a matrix channel. I would be happy to take that under the TUG matrix space umbrella, so you can just contact me after the session.
Okay, thanks.
Any other question? So, yes.
Oh yeah, I mean, by the time you've added tables and the YAML support, you're quite close to GitHub flavored Markdown, which many people know from GitHub pages and places. I mean, would you have definite, or are you envisaging support for specific flavors of Markdown apart from Common Mark? So GitHub pages in particular is quite common.
Oh, so the question is whether we would be open to supporting other flavors of Markdown other than Common Mark?
Yeah, I mean, the table support is obviously very close to the GitHub table extension, and they also have YAML at the top. So you're already, I guess, pretty close to GitHub.
Right, so I'm not sure I've caught the entire question, but just to answer the point about Common Mark, no, we're currently only, like the plan is to support Common Mark, and if you need to supply documents in the different markup format, including different dialects of Markdown, you first convert to Common Mark. Yeah, so that's the plan.
Okay.
Did you prepare your slides with Markdown or with something else?
No, I'll confess that the slides were produced in Google Slides.
Okay, after this confession, we can thank again our speaker.
Okay, hello.
Our next okay, can you hear me? No? Now it seems to work. Next speaker is Rishi, as in the name, but Rishi Kisan actually. We'll speak in the name of other people, Apu, IC Hantetan, who we thank every day, Jan Vaniek, and we'll talk about Primo. I don't think, is it the correct pronunciation?
Yeah, Primo.
Oh. The new sustainable solution for publishing.
Thank you. Good morning all, and good morning, good afternoon, good evening to all those who are actually watching the streaming. And thanks to TUG for making such arrangement. My colleagues and developers of Primo and everyone are actually watching this. Okay. So today we are introducing a new tool called Primo, an authoring, submission and proofing tool. In the recent past conferences, we introduced Techfolio, Ethel and Neptune. We actually coming from a company that types at academic journals. And STM Software is a company that produces or is developing tools for a company. And normally that company chooses tech conferences for announcing the developments and releasing some new tools. So Primo is designed as a total solution for many of the non-issues in the journal publishing world. Issues, I mean, we are actually typesetters, so we daily faces many issues during typesetting, because these problems mainly comes from the submission process and review and etc. So we are mainly trying to resolve those issues, and the beneficiaries mainly would be, the first beneficiary will be the author, then the publishers, and finally the typesetters. Primo is a cloud-based authoring, submission, and proofing framework. In Primo, author plays a major role in the publishing process. So minimize the post-processing of intervention of the other tools to make the underlying XML valid, speed up the publishing process. So Primo, the underlying thing is actually an XML file. It's a YCWG editor. Primo has a YCWG editor. Authors will be, we are thinking authors will be composing or making their manuscript in Primo. It's actually written as an XML document. Then it combines advantages of XML-based workflow that facilitate controlled authoring and or editing in accordance with the specific DTDs. Finally, PDF rendering with the help of TUG. Even if it's in actually authors are composing their manuscript in the YCWG environment, but they are creating the manuscript and it is written as an XML file. And finally, the article is, I mean, that file is converted to a PDF, and the PDF is actually created by TUG. That is how TUG comes into this picture. And we are trying to provide a better user experience with the help of elegant and modern interfaces. Reduce the end-to-end production effort from authoring to publishing and to target quicker publishing. That's the introduction about Primo. Let's now move on to other details. So other features are a tool from the House of TUG people. So these people already have developed the TUGfolio, a typesetting framework. Then either which is actually used for the typesetting of copyleft articles, that is in the local language, our local language Malayalam. Then they've already developed Neptune, a LaTeX proofing solution, which is currently being used by many of the authors, and introduces the beauty of TUG typesetting to the non-TUG community as well. So the authors are, it is not a requirement to learn TUG for them. They can use the YCWG environment. Then the PDF, they can see the beauty of how TUG typeset their article. It is compatible for both TUG and non-TUG communities, YCWG and non-YCWG mode editing. If TUG authors are there or somebody who wants to use TUG, they can move to the other mode. 3 modules available here, like authoring, submission, and proofing. And collaborative editing is available. 2 or more authors can simultaneously contribute or compile their, compose their manuscript. Journal template-based PDF generation using TUG. Each journal have a different template or design. So the PDF will be created, the YCWG environment or will have a common format, but the PDF generated will have the journal style applied to it. Content profiling of the sources, that is actually a very important thing. The typesetters who are actually here may know about this. During the submission process, authors will be submitting all the materials available in their folder to the submission system, and all these things will come to the typesetters. So the main responsibility, one of the main responsibility of the typesetters is to find out which is the latest file, or find out, avoid the unwanted files, etc. Using the right file is one of the challenges the typesetters are facing. So while since they are using this Primo for authoring, they can only use the right kind of files only, and Primo export the sources and as a zip file, and only the needed file will come to the typesetter. So content profiling will already be done there. overrides the limitations of math rendering in browsers. In math will be, they'll be looking finally at the PDF output, they will be happy. Form mode editing interface for front matter and bibliography. Another challenge that we are facing is while giving the affiliations, the typesetters sometimes will find it difficult to identify the state, the city, etc. So since authors themselves are filling the form in the proper field like city, postcode, organization, etc., it is not at all a challenge for the typesetters. A well-designed proofing environment with all relevant features to help easy proofing. Let's look at it later. Since it's XML based, it's a DTD compliant tool also. Let's move on. So Primo addresses these basic issues. Author's difficulty in understanding the journal's requirement. Solution addresses by providing a plug and play type environment. The beneficiary is authors. See, the thing is, while submitting, we have faced a lot of questions like which template should I use and similar type of questions. Authors will be confused. There's a, the guide for authors is already there. It's a lengthy document. Authors have to go through it meticulously. That's a difficult process for the authors, sometimes we find it. So if authors try to compose their manuscript in Primo, the thing is that they just need to choose the journal only. So according to the journal, the style will be selected by Primo and they can straight away start composing their manuscript without caring the styles, etc. The style will be appropriate according to the journal. Then multiple authors need to work on the same documents. That's really a collaboration. Two or more authors can collaboratively work on the same document. Chances of missing materials during submission process that I already explained before. It's sometimes when authors submit manuscript, they will forget to submit the figures, the supplementary material, or any other input files or style files, etc. Since the Primo will export the right file, right kind of files, there's no chances of missing. When there comes any missing materials, what the typesetters needs to, they have to contact the author. Sometimes authors will be on vacation or somewhere. So it will actually cause delay in the production process. So this type of communication and other problems can be eliminated. Then back and forth querying for problems in the source that I just explained. Author formats a document without knowing the final look and feel of the published article. Journal-based templates is the solution and beneficiary is the authors, typesetters, and publishers. Yeah, I explained it before. That is, they don't need to know how it will look like in the output. They just need to start composing their manuscript as the title, author, affiliation, abstract, etc. And regarding the style, etc., some journals require, there will be certain specification like minimum 5 keywords should be needed, or more than 3 keywords are necessary, or abstract is compulsory, graphical abstract is compulsory, or the biography is needed, etc. These informations are actually available in the guide for authors only. If without reading this, if authors start using this Primo interface, this will, when they choose the journal name, for example, it's end-to-end journal, then as soon as they start typing in, it will, the message will pop up. The keywords, you have given only 5 keywords, 6 keywords are mandatory. You haven't provided the multimedia component, it is mandatory. This type of warning will also come. So others are free without thinking any other thing, they can easily compose this. Difficulty in converting to different journal template when it's rejected is easy formatting. That we heard that sometimes authors will be submitting their article to one journal and it may be rejected due to some non-compliance. So when they are about to submit to a different journal, they have to reformat it according to the specification of that journal. So it's a tedious process. They have to read all the specifications, etc. So here when they come, since it produces output, they can compose it in a standard format. They can just import their XML file to here. That will actually, and they need to select the journal to which they are going to submit. That article will be formatted according to the journal style. They don't need to bother about the style of the journal B or A. Difficulty in identifying the surname, given name, city, state, postcode, etc. These are the form mode editing that helps authors authors see the typesetting is only PDF is not in typesetting. We need to create the XML, etc. So the XML, we need to tag the names properly, like given name, surname, the postcode, city, all those things, etc. So it is sometimes it will be difficult to identify the given name, surnames of different countries for the typesetters or the operators. So since authors are filling their names properly in these fields, typesetter's job is much more easy. So since already these data are filled in the proper field. Problems in the submission process support seeking time and delay. Unnecessary querying is not at all required since all the right kind of files will only be sent into the typesetters. Constraints in the submission system, it's a user-friendly submission process. Very simple interface is provided for authors to submit. Constraints in the HTML proofing system, text generates, it is all about the proofing system. And since text generates PDF, authors can finally look at the PDF and approve their manuscript. Problems with the unformatted PDF generated by the browser, since we have some HTML-based proofing solutions currently available, and sometimes authors are complaining about the formatting. They have to approve their corrections only looking at the way how their article format in the HTML or in the browser. So since tech is generating the PDF of their manuscript in the final format according to the journal style, they only need to, they can look at it and they can understand how it will look like in the final article. Validating corrections, authors can, this is another thing. During the correction stages, authors will be giving high number of corrections or inserting new tables, new figures, etc., which are not allowed in the correction stage after the proofing, in the proofing stage. So when authors are trying to do more number of corrections or inserting a new figure or new tables, etc., after this is just need to remember that this is actually happening after the review process and typesetting. So after the typesetting, during the proofing stages, these are not actually allowed. When they need to insert a new table and a new figure or new content, new paragraphs, etc., that need to be reviewed properly also. So when they try to do this, that will be validated. It will give a warning to the author and they need to get consent. Unavailability of a file manager, so in Primo we have a efficient file manager. Others can do all the process, just like in any systems or operating systems, they can use that file manager. Yeah, user-friendly submission system. So this is the workflow. It's sometimes it will be complicated, but it's so easy. I can explain it clearly. We can just forget about the second part, the neon part. That is solely for creating the PDF only. So the first one is actually the Primo. Authors compose their manuscript in the YCVG XML editor. Then when they need a PDF out of it, they just need to press a button that XML will be converted to a text file and goes to Neon and create a PDF. Similarly, they can, the content profiling will be done in Primo. Then after content profiling, they can, when they are sure all the materials are available there, they can download the file, export their source file and upload to their submission system. And if they need a PDF also, they just need to press the button that will go to the source file, will go to the Neon system and will generate a PDF. So the review process, then if they need a data set or an article to be published earlier than before its copy editing or proofing, etc., they can create a data set also. So copy editing can also be done in Primo. The source is in Primo, so it can be, the process can be continued. The pagination and author proofing, then master copy, that is the correction stage after this author proofing stage, everything can be done in Primo. So this can be done in the WYSIWYG editor or the other mode. So when they need a PDF, they just need to press the button, that XML file will be transferred to the Neon system and PDF will be generated. So I already said Primo has actually three modes. One is the authoring tool. So there's a file manager in Primo, and all the file operations like creating a document, editing, renaming, moving zip, unzip, uploading, downloading, etc. All that you do in a file manager can be done there. Others can prepare a new document in WYSIWYG mode. They can create aesthetically beautiful PDFs using TUG without knowing TUG. They can create a document according to the DTD the publisher uses. So during the proofing stage, there will not be any such queries regarding the content of their manuscript. LaTeX math editing tools available. Those who actually know LaTeX, they can use the LaTeX math editing. Spell checking, word count, etc. done. Hyperlinking, then sharing the document with the others, and collaborative editing is available in the authoring tool. So the submission tool, since the materials created will be according to the journal style, by default no need of referring to the lengthy guide for authors. So this is in the submission system. Usability of checking and usability checking ensures all the contents are available to avoid the missing materials. Download the required files only as a bundle to load them to the publisher's submission system. For submitting the article, they just need to export their source file and upload the same to the submission system. The bundle will contain a manifest XML which will show the proper file type to be selected in the publisher's submission tool. So while uploading the source file to the submission system, there should be some specification like each file should be, some file category should be selected for each file. This will give a help to the author to which file should be selected in which category. This is finally the proofing tool. Typesetters, after typesetting, they load the XML which is included in the data set with the XML version of the manuscript along with the necessary assets like artwork, multimedia, content, etc. to the drive, which will in turn return a unique URL to the document. The typesetters need to send the URL to the author. Using that URL, author can access their proof. They first need to start looking at the track changes. Track changes gives what are the changes the typesetters have actually made to their article. They can approve it or reject it, those changes. A lot of queries will be there regarding the content sometimes. So others need to go through each and every queries and need to resolve. Without resolving all the queries, they cannot submit at all. Continue editing, and the mode of operation is self-explanatory. Others can guide themselves and reach out to the features, functions available for editing without the help of the support. Make changes, ensure the corrections in the code, generate a PDF and confirm the PDF version. If any further corrections are seen, just make it in the editor and again create a PDF. So one more thing, the corrections will be marked definitely in the underlying XML. Corrections can be done or verified simultaneously by multiple authors. Access can be restricted to view only or edit mode while sharing. When in collaboration mode, others, the corresponding author or the first author can restrict other authors' permission, like whether it is only in the read-only mode or it should be in editing mode. Version control is available. If too many changes they have done, if it is too difficult to undo every changes, then they can take the previous version if they already have saved it. So this is still under development that I told before. So the timeline is actually given here. Proofing tool is the first module that they are actually going to develop. That timeline is May 2024, and authoring tool by December 2024, and the submission review tool by 2025 April. These are some slides, I mean the screenshots of the Primo. The first one is the toolbar, second the drive, Primo drive, and third one how to import the document, the menu available, start a new document or a folder or import a document. Then fourth one is you can sort the file listing. This is the main page of Primo. On left hand side, the navigation for navigation purpose, the table of contents. Then in the middle, the main document part. Right hand side, the track changes, comments, queries, etc. This is the math rendering. See, LaTeX authors can edit in the LaTeX code, and just above it, other non-LaTeX users can use the keyboard and edit the math in very civic mode. On the left hand side, this is a form for entering the front matter like author area, author name. Then second is the same thing. You can see the more fields are available according to the DTD. Whatever the DTD allows, all the details are here. They can enter. Affiliation, they can straight away fill in the organization, address, city, state, etc. Then the bibliography is here. This is how it is rendered. These are the figures. The figure details are on the right. So others can see then the resolution or the file size, etc., and choose the right figure. This is how the PDF will look like, which is created by Neon. It is according to a journal standard. Math. So technologies behind Primo. Actually, I'm incapable of explaining all these things. This is too much for me. So if you have any questions, you can straight away direct to the developers. Thank you. Okay, I can take a few questions.
Thank you. Thank you. No. It's on? Yes. Okay, are there any questions? Okay.
Thank you. Will it be possible to use the system on premise?
I'm sorry, can you say again?
What?
Can you say again? I didn't get it.
Okay. Will it be possible to use this system on premise in the house, not only in the cloud? Not really? Locally?
Yeah, actually it is only available in the cloud. You want to install this in your server?
I can put it on my local cloud?
No, that is not available.
Okay.
Any other question? Okay, thank you. Thank you again.
Thank you.
So, I guess we have a coffee break and we'll restart at 11. please. The next talk will be by Ross Moore, that several years ago saved our life with XYPIC, making it possible to do commutative diagrams. And he will talk about tagged PDF, derived HTML, and aspects of accessibility. This will be a pre-made video, and questions and answers will be on the YouTube chat, not in presence.
If we're going to be talking about accessibility of documents, in particular documents created with LaTeX, we really need to have an understanding of what we mean by accessibility. And this is what Google says, a very general definition of what accessibility means, right? The practice of making information available and usable for as many people as possible. Okay. And there's no actual mention here of people with disabilities. Okay. Now, if you take the viewpoint that those of us who are fully sighted and perfectly capable of reading the information don't need any extra ability to access information, then of course the next group of people that, as part of the as many people as possible, will be those with disabilities. Okay, I'm cheating a little bit. If we move up here to what Google really says, or what it says, and what has come to be what most people think of as accessibility, and it's to design things to be usable by people with disabilities. Okay, but the general definition actually means that it's actually more than that. Right? So if you do anything, if you include any feature in your document that makes it easier for anybody to read, then you would expect more people are going to read that document, and so you are enhancing accessibility according to the general definition, okay? And we'll see that kind of thing. Okay. But let's shift on to this particular website, which you'll see is related to the Section 508 of the United States Rehabilitation Act. So what is mandated here is that federal agencies develop, procure, maintain and use ICT, so information, well, basically information technology, in a manner that ensures that federal employees having disabilities have comparable access to and use of information and data comparable relative to other federal employees, okay? And then, unless doing so would impose an undue burden, okay? But it also requires that the agencies ensure that members of the public with disabilities have comparable access to the publicly available information and services. In other words, the electronic documents that they may be producing have comparable access to is really the key phrase here. Okay, so now if we want to have a look at the kinds of things that has been worked out and should be done for people with disabilities, the WAI, that's the Web Accessibility Initiative, and this page, ARIA, standing for Accessible Rich Internet Applications, this is really the place to look. And there's an awful lot of information in here. There's even links to conformance checkers, which we will be using later. Okay. Also with the WAI, there is this page, Web Content Accessibility Guidelines. That's what WCAG stands for. Okay. So these are two very important websites for how to make web applications or documents that are to be accessed via the web, how to make them more accessible to people with different kinds of disabilities. A lot of that is discussed on these pages. Okay, but what we want to do is to have a look at accessibility and in particular navigation through PDF documents and then subsequently HTML documents as well, and see how some of the ideas on these last two pages can actually be put into practice. Let's have a look at some of the navigation features that one has in a PDF document. Okay, so the one that's showing here in Acrobat Pro, it's got 185 pages, so it's quite long, and it's generated with LaTeX. You often can get a set of bookmarks, okay, and we see the bookmarks listed down in this panel on the left-hand side. And there's quite a lot of them, and they represent significant parts of the document, okay, including tables of contents, lists of figures and tables, etc. The main sections, so each of the different fish reports. And here is a introductory section. Some of the technicalities here are discussed and the main results from each of the other sections. Okay. Notice that there's also a slight tree-like structure. You can open out some of the sections into other significant subsections. Okay. That's really, it's just a visual way of moving, of navigating through the document. You need to be able to see the bookmark sections itself, as well as the information in the main window. Okay. Let's compare this briefly with the table of contents. Okay, you have the same kind of thing, but now those tree-like structures have been opened out, and you can see some of the different subsections. The information is not identical, but certainly very similar, and there's hyperlinks on the right-hand side going to where you want to go to, the kind of subsection. And you can use a button up here in order to get back, and so on. So you can see this can be used as a method of navigating the document. Okay, but one big difference between the table of contents and the bookmarks is that when you use a link on the table of contents, you move away from that table of contents to somewhere else, and you need to go back if you want to try and use it for something else. Whereas with the bookmarks panel is there forever unless you want to get rid of it, push it away. Okay. So you can get it back. Okay. List of tables, right? Okay, this is probably more useful for someone involved in the industry itself and wants to locate a particular table. So George's Bank haddock, and we go straight to the table, and it makes for easy navigation and so easy access to that kind of information. Again, it's using hyperlinks. We can regard it as an accessibility feature because it certainly helped a lot of fully sighted people to find where the information they want may be and then get access to it. Okay. Another kind of information is, okay, so let's suppose we go down to say here, and we have a look. So now we're actually reading some of the technical information, and we start to see, oh, okay, NRCC, oh, what's that? Well, it looks like an active link, so you can click on it, and you see that it is an acronym for the Northeast Regional Coordinating Council. Okay, and so then go back, And okay, back and then find your way through. Assessment Oversight Panel, AOP. Oh, well, okay, well, clearly that's the AOP stands for the Assessment Oversight Panel. One could click on the link and verify that in the, right, we're in one of the glossary sections, okay. But if you've got it there, then it's already been told to you. And having seen it once, well, okay, down here, you wouldn't bother to be looking at it again because you've read it and remembered. Let's look at this same document in a different PDF viewer, okay? So this one is now, it's not Acrobat anymore, it's a viewer on the Macintosh. And if we go and have a look at that same place, okay, look what happens when I hover the mouse over the hyperlink for that acronym. It actually gives you a small little version of the page that you would go to if you clicked on it, and you can see the expansion of the acronym up there in the top left-hand corner. Okay, and it also tells you if you click which page number you would go to. Okay, different PDF browsers can handle things in different ways. But again, these pop-up pictures are definitely really only helpful to fully sighted readers using a visual view of the document. But let's return now to Acrobat, and I'll show you another way of doing navigation, this time using the Tags panel. Okay, and here it is opened at least to the highest levels of structure. The Tags panel shows you the structure of the document, the article, and then the highest levels. And you'll note that the names here include ARIA, right? The Accessible Rich Internet Applications. Okay. And so these particular divisions of your document are called landmarks, and we'll get to see that later with HTML. Okay. Most of the information is in here, similar to the bookmarks, except now instead of having the titles of the sections, we now have the structure. So it's section point 1, section point 2, etc. Okay, and all the way through. So our first fish stock is actually going to be this one, Atlantic Wolfish, and you can get to see the actual text. Right, so I can click on this and we can go to the actual text. Section will include the section number. Okay. And so you can actually see how every piece of structure within your text, including divisions of things using certain fonts and other fonts or have special meanings, they're all captured in the structure. There's a sense in which this is similar to bookmarks, but I think it's more like bookmarks on steroids, because you can get to absolutely every little piece of information about within the document. Okay, and in particular each of the pieces of text and what structure they're associated with. Okay, let's return to the beginning of the document again. And I want to show you another kind of navigation based entirely on the keyboard. Well, apart from an initial click to have focus in the right panel, if I hit the Tab key, then I move into part of the document. And if I hit it again, okay, and you can see what's happening. We're moving through all those pieces that are active hyperlinks. And Shift Tag takes you back. But what is this first one? It's the logo, and you can see that by hovering over it, you get a description of the logo, but at the end of it, it says skip to main. So if I click on that, I skip automatically to the very beginning, the beginning of the main section, the one here called aria-main, okay, which I've skipped over all of the complementary information straight into the place where you would like to begin reading. Okay, assistive technology can use this to get yourself to places within the document and then start reading from that point. Okay, On the keyboard, hitting the return key is what takes you to the target of the hyperlink. This is another way of navigating through the document, which is more relevant to people with visual disabilities. Okay, let's have a look at that PDF document in a new format, having been converted into HTML, or we talk about it being derived into HTML. Okay, from this website you can get both to a copy of the PDF and also what the derived HTML page looks like. So if we click on this link, and here we go, and we see that, okay, all the same kind of information is there. It's laid out quite nicely, so it's visually appealing, but it is also potentially more accessible to a person with some kinds of visual impairment. In particular, let's have a look at what happens when the tab key. I just press the tab key, and now it's gone to this link. Okay, so the link to main is definitely there. And if we keep hitting the tab key, then you see this navigation via the tabs, similar to what Acrobat could do in the PDF. Okay, and of course backwards with the Shift tab. But when we have it in this form, then we can actually emulate what the situation, what it might look like to somebody with a visual impairment, such that they're only seeing a small portion of the screen at once. Okay, and so, okay, so we can only see a small portion of the screen. Okay. When you are on an active part of the document, then if you hit the return key, then you will follow that hyperlink, and you see it takes us into the glossary to where that particular acronym is explained. Okay, let's go back. Okay, but it also raises the question of, well, okay, if we're tabbing through a document via these active links, I mean, we come across a hyperlink, right? And so the question is, do we really want to follow that hyperlink? Or can we understand what the information is that we will find at that hyperlink by not having to follow it? Okay? And that's an interesting question, because remember back when we looked at the PDFs and we had it, when we hovered, it popped up with a little window showing us the expansion of an acronym as it was when we first looked at that. Can we do the same kind of thing in HTML? And the answer to that is a definite yes. Yes, indeed, we can. Okay. Right, so the way that's done is to bring up an extra panel on the right-hand side here called the Developer Tools. Okay, and then if you hit this little button here, then it now gives us a view of the document very similar, not exactly the same, but very similar to the tags view in the PDF document. First, these four names here, banner, complementary, main, content, info, they are called landmarks, and they correspond to sections of the document, reasonably large sections, okay? And they can have, at the next level, the landmarks have regions, okay? And they have, so you can see the regions are corresponding to each of the sections in the PDF and other pieces, right, in the complementary. Then, right, so here we go, here's our table of contents, okay? And it starts off, so that paragraph is actually the header there, the table of contents header. Okay, then we go into the list, and you see we have list items in our lists. Okay, and so panel report and the link. Okay, note this has an extra piece of text here. Section 1 starts on page 1. Okay, and then the static text of just the one itself. Okay, to somebody viewing this with full visual view understands that these numbers, these hyperlink numbers, correspond to links to the various pages in what was the PDF document. Okay, if you're limited in what you can actually see, then this text here will tell you, right? So in assistive technology, it's meant to read this text. So a screen reader is meant to read section 1 starting on page 1, or starts on page 1, rather than just the number 1, okay, which gives you far more information than just looking at the page number, okay? It's telling you it's a section. The 2 comes from the label over the left-hand side, all right? So that's where it has been derived from, okay? It's come from there and starts on page 19, okay? Okay, and all of that's been worked out. Okay, so section 6 here starting on page 59. Okay. This kind of extra hint here as to what the link is going to take you to is, it's part of the ARIA, those ARIA recommendations. Okay, it's a ARIA label text, and the idea is that with assistive technology, you are meant to replace the static text with this extra link text, which has more information in it, right? Visually, you only need the 59 because you can see the context in which it's occurring, okay? If you can't see that context, then this extra ARIA label text can be very useful to you. This time the web browser is Firefox. It's a particularly nice plugin which one can use. And you see it gives us all of this extra information over here. Okay. A Inspector stands for Accessibility Inspector. Here is the terminology, the landmarks that we talked about. Here's links and all kinds of things. Right, this is a validation checker. It checks that all of those recommendations in the ARIA specification, have they been met? Okay, V stands for violations. There are no violations of any of the rules or any of the recommendations that are made. There aren't even any warnings that things might not be quite correct, but I'm not quite sure of. MC stands for manual check. So a manual check is required. It can't say definitely that everything's okay. And whereas P stands for pass. Okay? So of the total set of rules that are being checked here, 65 kinds of rules have been checked, and a large number of them are passing, can be algorithmically determined to be passing, and whereas a large number still, well, the claim is that they require manual checks. And so those manual checks, well, you can have a look and see what it's asking for. Okay, so double click and it just takes a little while. Okay. Landmarks must identify content regions. Well, we saw in Google Chrome that they certainly did. Okay, so that test is checked. And of course, the way they've been constructed algorithmically by LaTeX, we know that that this rule is going to be satisfied. So that manual check doesn't actually really need to be looked at. Okay? Whereas there's a whole lot of passes there for all of the other things that are specified under landmarks. Links is another interesting one to look at. Okay. Manual checking, there's a couple of rules that need to be looked at, that are deserving to be looked at. The link text must describe the link target. Link text must describe the link target. Okay, so things like section 1 on page whatever it was, again, that's been algorithmically created by LaTeX, so provided that is being done correctly, again, it doesn't really require manual checking of the result in the HTML, because we know it's just going to work. Okay, and notice that 3,268 A tags, or in other words, hyperlinks, internal and external. Okay, it says to verify all of these. Well, there's no way you're actually going to manually check every single one, and you need to trust that the LaTeX programming has been done correctly. Okay, target focus must be in the content, in the content window. Well, everything's in the content window, right? These documents are being created with, these HTML documents are being created as just sitting inside one single window, the whole thing being in there. So again, the target focus remains in there when you use a hyperlink to skip to somewhere else. So there's no need to do any checking there either. Okay? Well, we can see that basically that all of these things are going to work. You're going to get a very, very good, satisfying all of the ARIA recommendations that are relevant to this document. So we can see that with this tag PDF document derived into HTML, we get very, very good accessibility checking at least according to this accessibility inspector. Okay, returning to Acrobat now on the PDF, we want to see how that extra ARIA information has been stored in the PDF file. Okay, so having picked a structure element, so for a link, for a hyperlink, we want to find out its object properties. We look at the attribute objects, then we see that there are various attributes. Okay, one is what should happen when you export this hyperlink into XML, into an XML document. Another, exporting the hyperlink into HTML, but also with the ARIA attributes. And so here we have, there's actually two attributes here, okay? And you can see the ARIA label, right? So it's Appendix A, starting on page 4, okay, which we can see back in where that's come from, right? It's Appendix A, starting on page 4, okay. And the actual details of that are in section 0.05, which is what Appendix A is. Appendix A is section 0.05. Okay. Okay, here we see another use of an ARIA label. Okay. Here we have a list of the names of the AOP, right? And they've also got footnotes to tell you their affiliations. They're down off the bottom of the page. Okay, but if we have a look at, see, the panelist structure, okay, it has an attribute which tells you, well, two things. It tells you it's an item in a list, okay, because it's a list of various names, and that particular element in the list is the AOP panelist number 2, so the second one that's been listed there, okay? Thus, some very specific information that to someone who's visually fully visually aware, wouldn't need to be told that you've got a list of names here. But if you're using assistive technology and can only see a very small part of the text at any given time, then it is worth having this extra information to tell you exactly why this collection of words and letters is occurring at this point, what purposes it's serving, and what other information is available, right? Over in the structure tree, you can see that structurally, directly after the panelist, or in fact within the panelist structure, so after the name, the actual footnote occurs telling you the affiliation. And that's the kind of thing that also happens in the HTML version.
We thank Ross for this overview of what accessibility means. And I guess we can go to the next speaker, who is Ulrike Fischer, whom we thank for organizing this magnificent conference. And we mustn't forget the Bear assistant, Gert, of course. And Ulrike will talk about automatic tagging of LaTeX document, what is possible today.
Hello? Huh?
You need to switch it on, which is...
Okay. Now? Yes, fine, fine. And the beamer stuff. Okay. Where can I put it? Better? Yes? Okay. Okay. Welcome to my talk. I'm Ulrike Fischer. Everyone knows that, I think. I'm a member of the LaTeX team, and I'm now here to report about the progress that we're making in the TAG PDF project. What is tagging? You just saw this in Ross' talk, so I don't have to explain anything. Tagging adds structure to a PDF. This improves accessibility and the reuse of data of the PDF, because PDF is basically a graphic format and so not really structured. If you want to know details about the implementation or how this actually works and what code is needed to do it, please look up previous talks, articles, or the documentation of the TAG PDF package. But as a short motivation, I would like to show a screenshot of one of my bank statements. Since a few months, this bank statement is tagged. It's a quite simple document. Basically, it's only a large table with 3 columns. The date, a multi-line description, and the amount. If you can see in the screen, there's one transaction here made this year, some sponsorship for Coty in the zoo in Mönchengladbach. And the tagging is quite simple. There's a TR for the row and a TD for the various cells. It's quite similar to what you get in HTML. So that's how such structure is looking. What are the benefits? If you read with a screen reader, like NVDA, an untagged PDF, I had this last year, then the order is simply messy. It will read the date and then a part of the description, then the amount, and then the rest of the description in everything in one go. You can't really know when you hear it what is going on in this table. When it's tagged, the order is correct. It will read first the date, then the description, then the amount. And it will also tell you where you are in the table. It will tell you, I'm now reading row 10 or column 3. So you can also ask which header has this column, so that you really know what is the data. You also, if you copy and paste in a spreadsheet, then if you do this with an untagged PDF, you simply get everything in one column. And the order is messy too. The amount is somewhere in the middle. You have everything in column and it's actually not usable. If you do it with a tagged PDF, the data is correctly split over 3 columns. You can see a screenshot. You can squeeze a screenshot here that the date and the description and the amount has been correctly placed in the screenshot. That means the data is reusable. Scripts can use it if they want it. So we think it's important to get tagging in LaTeX. The goal of the tagged PDF package is at first to make tagging with LaTeX possible at all. That is done. If you really want to tag a PDF, you can do it. There's no manual work, but it works. But naturally, normal users don't want to do complicated code, so it should also be automatic and easy to use. That's part of the tagged PDF project. Before telling you what we are currently able to do in automatic tagging, I will describe a few of the problems that we saw in the last year while working on it. One problem is that PDF viewers actually don't show text. The screenshot was from Acrobat Pro. Ross used Acrobat Pro 2, and that costs money, and it's not something that many users have. So what they don't see, they don't want, or they don't think it's important. There's someone complain that copy and paste doesn't work, but actually they don't know that it's the missing text that are the problem. It's changing a bit. Currently, we found a viewer PDF Exchange actually now show text. There's also a PDF Fix application which actually meant to add text to an untagged document, but can be used too as viewer. So there's some hope that something is changing here, but the best is complain to your PDF viewer. He should show you the text of a tagged document. Without this, it's also difficult for the developers to really you have to look what structure did I produce, and without seeing them, that's not easy. Second problem, I should store here, that appeared during the last year is actually the missing PDF 2.0 support. PDF 2.0 is now more than 6 years old. It has important features for tagging, a better tag set, structured destinations to allow to make a link not to some place on a page, but to a specific structure. It knows associated files to aid additional data to a structure. That's important for mass tagging because you can, for example, add the source or the MassML to the mass formula. And it also knows the MassML namespace, which is important for mass tagging too. We can create PDF 2.0, everything is implemented, but actually no PDF viewer correctly supports this. Not even Acrobat. It isn't able to handle namespaces, and associated files are simply lost, and so on. Here again, we only can hope that to resolve this egg and chicken problem, by producing PDF to 0, complaining that it doesn't work, so that at the end the viewers start to support this correctly. The next problem that appeared was parent-child rules. PDF contains lots of rules which structure is allowed in which structure. You can't do a P in a P, but you can't put a spam in a P. So here's a short extract of such a rule list. At the beginning, the TUG PDF picker, we simply made it manually. We decided this is not, but it didn't work out in the long run. So now there have been implemented automatic tests which really check every time you add a structure if this structure is really allowed here, and gives you lots of warnings. This was quite some work, and then avoiding that you violate the rules is not always trivial, because the PDF model is not quite identical to the LaTeX model of a document. Now let's go to what is possible today. The next milestone that we set to us is the tagging of so-called Leslie Lamport documents. These are documents which more or less follow the descriptions of this book. So what is here described here should be possible to tag automatically. This means use of standard classes, currently article, book, and report, standard commands in environments like lists and so on, only a quite restricted set of packages. One exception is HyperF. HyperF is always kept in sync with tagging, so I always try as soon as add something to ensure that HyperF works too, even if it wasn't described in this book. So what is possible today? With today, just to make sure, I mean a current LaTeX. LaTeX from June, not last year. So the supported engines, really supported engines, are PDF LaTeX and Lua LaTeX. DVI mode is difficult, Xilatisch is difficult. You can try it, but actually there's no guarantee. Recommended is Lua LaTeX. It produces the best tagging. The new code we are currently developing is in a special bundle of the LaTeX repo called LaTeX Lab for laboratory. So it shows you it's in development, and then sometimes experimental, it works, but you should expect that it changes if you find errors. And the code is currently loaded with a test phase key, again to indicate that this is something we are working on. So currently we have a phase 3. This is what I will describe here, mostly in the document. You have to load it before the document class. There's explicit trigger. If you want tagging, you have to tell the document, I want tagging by using this document metadata command. So the first paragraphs and links already worked last year. I described this in a talk I tucked there. That's implemented with the new power hooks, which are quite useful and works fine. The main problem is if you use this, that sometimes you need really to ensure that the tagging is balanced and that you have a similar number of starting paragraphs as end paragraphs, which if you do low-level coding can sometimes fail. But nevertheless, you can, there's not much problem here. Footnotes have been implemented some time ago too. Here, the footmis package can be used. That we are trying to keep in Zinch because Frank is maintaining it. So we have already a replacement. Other footnote packages won't work. Mini-page footnotes have to be handled, are not yet fully handled. So, new is the sectioning. Here, the PDF model actually wants that there's a sect structure around the heading and the body of the section. So you have really to surround everything, something that it's not really natural to LaTeX because we don't have something like start section, stop section. So we have only, so it has to be detected automatically. This works if you don't do too curious stuff, it works quite good. To implement it, various internal LaTeX commands have to be changed, for example, start section and sect. And this means that classes and packages that overwrite these commands again break the tagging. For example, currently the memoir class, the comma classes, but I heard there's some work going on to change this, and the title sec package is also not compatible. Table of contents are now supported too, and similar lists like list of figure or everything that is built on top of start TUG. Here too, the PDF model wants lots of nesting, so if you have a subsection in with entries, there is a new TUG in a TUG and so on, so lots of nesting going on. But again, as long as you don't try to insert special code in the middle of the table of contents, it doesn't break. It changed again a lot of internals of LaTeX. For example, start TUG or at contents line is not an internal, but a correlative command, dotted cut line, and similar. And again, classes that change this command or define them themselves, like the L chapter command is typically a class command, don't work currently, but most changes, if a class wants to get compatible here, it's not really difficult. Display environments and lists. That's a large block because lots of LaTeX environments are built on top of TIFF lists, and so are internally a list. So we have here center, quotation, verbatim, theorems, and so on. From the semantic viewpoint, they are quite different. You don't want to tag a center environment as a list or verbatim environment. So they have to actually to get different tagging receipts here there's a complete new implementation based on X template. So all old list code is gone. Block environments like center and verbatim are actually no longer lists. This means every package that builds or assumes old list code is not compatible, including important packages like enum item or fancy verbatim listings. Naturally, there have to be replacements for this. Yeah, it's clear that this should stay so. Citations and bibliography are supported too. Here the tagging is actually not complicated. Basically, you want a link between the citation and the bib entry, and the bibliography itself is a list. So there is nothing complicated going on. NetBib here is supported as external package. BibLaTeX is supported too, as long as you use hyperref. Without hyperref, there's a hook missing to inject the code, but it should be easy to convince a BibLaTeX maintainer to change this. Graphics are also tagged now. Here is something that cannot be done automatically. If you want to make a graphic accessible, you have to add some alternative text so that someone who cannot see it knows what is in the graphic. Currently we support the include graphics command and we support the picture environment, both now no optional argument and an L key to add this alternative text. Text is not yet supported, but that will change soon. Henry Menke is here, and I think we can convince him to help us. Floats. Floats can also be used currently only in the standard floats, figure and table, but it's not difficult to add support for more floats. A bit surprisingly, when I tested, the caption package seems to work in some cases. I'm not sure if it has so many options, so it's quite possible that somewhere it breaks. But actually, one can try to use a caption package and look what structure you get. The float package on the other side is certainly incompatible because it changes the xfloat command again. That means that currently you can't use H floats, the floats that are not floats, if you want tagging. Margin par is theoretically also a float, or really a float, and that isn't supported yet either. There's a bit of problem because margin par has two code parts depending on which side of the page it wants to appear. That makes the handling, the technical implementation a bit difficult. Mini page and parbox are simply diffs and they're tagged. Simple cases should work quite well. If you start to do very complex stuff with many pages, you probably still will get errors, and then some feedback would be nice so that we can correct this. Mass. There is some implementation for mass, but it's quite experimental, and so currently you have to load it with an additional test fees command. It works by grabbing the whole mass and then processing it. It will, for example, break if you do your own mass commands. If you shortcut and say BA for begin equation, and it will error. And there is still the possibility that it affects a code that isn't meant to be mass. For example, currently URLs are suddenly mass when you load it, which isn't quite what you want to expect. The tagging is quite simple-minded currently due to the missing PDF2.0 support. We actually don't really know what would be good tagging here because the support in the processors is not there. We have also started a first aid module for the test phase, which contains, ich bin gleich fertig, a first aid module for the tagging, which loads small fixes to packages. As soon as I find something, I do it and try to put either to contact the package author or to add a first aid, and you can, if something breaks, you can look if there is some correction in this module. What is missing? Missing is currently saving and reusing of boxes. So you can't use or only very carefully use save box and use box, even more if they contain a structure. Then it's very hard. It's really not trivial. I'm working on it, but this will take some time. What is also missing is I started with an example with tables, and table support is currently missing, mostly because the interface, the tagging itself is not so complicated, but finding a good LaTeX interface to mark headers. Currently our tabulars simply don't tell you where are the headers of a table. We need an interface here. We started a discussion about this in the tagging workshop. Okay, as a summary, you can now already tag quite a large amount of documents. We would be very grateful if you try it and if you report errors. We have open and GitHub just for errors, also errors with external packages, so that we correct and extend, can correct and extend this code. Thank you for your attention.
Thank you, Ulrike. Questions?
Thank you, Ulrike. A question about float package. It provides a very nice functionality of adding floats with new float. If we use it only with this functionality, will it still break tagging? And if yes, how?
Sorry, I don't understand. What did I break?
Okay. The nice thing about float package, which is incompatible, is that you can add new kinds of floats.
Yeah.
If we use only this functionality, will it still break tagging? And if yes, what can we do? Should we provide our own new float mechanism?
We will have to find a replacement for floats. To add new floats, it should be rather easy.
Possibly the new float package.
A new float?
Based on caption, and so it might.
Yeah, we have to look. I mean, we know that people want a new float types, and naturally we will have to support it.
Yeah, but actually, I mean, in the slide it says currently incompatible. Yeah. The intention of the word currently is really to say, yes, it is, I would say, fairly trivial to make the float package be tagging aware. It means working either with the author of the float package, or, which probably in this case means providing an updated float package that supports tagging as well, which we currently can do, for example, with something like Simple 8. We have this wonderful, nice hook mechanism to say if a certain package is loaded, after the package do something. The hook can actually be somewhere, and that allows a lot of overrides to existing packages as a first step. So I think the answer is documents having float package loaded will eventually just work. Eventually means after the phase where we ensure that Lamport documents work, and then a little bit additional.
But nobody should use a uppercase H float, so.
So there are two questions from the internet. One of them is, are those changes going to stay optional, or will they be a mandatory part of the LaTeX kernel eventually?
They will wander in some sense into the LaTeX kernel, yes. The main question is the timeline. So naturally at the end you will always have only to load document metadata and perhaps to say activate tagging. And then that is a plan. Currently you have to say it with test phase key, but it's called test phase to show that it's part of a test phase and not the final phase. Yeah? So.
Okay, and second question, can we expect the text PDF package to work out of the box without normalizing or standardizing these sources?
Subsets?
Sources, yeah. So can we expect the text PDF package to work out of the box without normalizing or standardizing the sources?
So in part. No, I know enough sources to know that some of them are quite wild and will probably never work. Because really you have to if you want something, there's a standard, and then you have to standardize some codes. Some code will have to be corrected. If your code is clean enough, then you will simply have to load the document metadata command, and he already loads the tag PDF package and activates tagging, and normal document should work out of the box. Perhaps you will have to add alternative text to graphics, but then it will work. But wild code, in my opinion, needs to be punished. Yes. So.
One question: I don't understand how you're gonna proceed. Will you have to do all the work as a LaTeX team on your own, or might the class and package maintainers help? You mentioned something to make packages and document classes tagging aware or something like that. Yeah. Could you elaborate a little bit?
Yeah, sure. We need the help of the package and class maintainers. We started, Marai just said she will work on Coma. Every package maintainer who wants to help and wants to know how can I make my package compatible with this code can contact us, and then certainly we can't rewrite all 5,000 packages on Citan, yes? So that will be some we will have to do because the authors are no longer there, but every active maintainer will have to help us. Yeah? Sure. Yes, no.
Another question.
So, but Joseph, okay, 1 minute.
If I'm a package maintainer and I'm interested in supporting tagging in my packages, should I first rewrite my packages in LaTeX 3?
No, no need.
It's not easier to support tagging in LaTeX 3?
Commands are in both, and if you really want a command also perhaps you need a short stuff to make an alias, but you don't need X+3. We are writing in it because it's easier and faster, but there's absolutely no reason why you should be forced if you don't like it. No. You should be able to read it, perhaps, so that you understand our code, but you don't need to write it. Okay? Now, sorry, I have to give.
And our next speaker is Joseph Wright from the LaTeX team, and he will talk about supporting backends in Expo 3.
Right, thank you. So I'm going to talk, as it says, about this is my Expo 3 talk, but some of you will be pleased to hear there's no underscores or colons anywhere on any of the slides. So it's going to be about sort of ideas and what we've been trying to do. Yeah. So we start off with the question about what does TeX not do? So we all know that TeX does very high quality typesetting, but when Knuth designed it, he left some things deliberately and some things because they didn't exist out of the list of things that TeX does. So color is the first one. What does TeX do when it places things? It is saying there is going to be some ink on a page, effectively, some colorant, but it doesn't say what color it is. That's left to other people to decide. So obviously if you want to do color, you need to be putting in additional instructions. Doesn't do image inclusion. TeX doesn't, I mean, classically, always telling people, when you get to something like include graphics, it doesn't really matter. It's just a big letter as far as TeX is concerned, or just a big box if we want to be even more precise. So the actual, how does that image get into the output? TeX doesn't give us stuff about that. Doesn't do hyperlinks. Hyperlinks didn't exist, and certainly don't exist in a physical book if you think about it, but they certainly do in an online version. But again, TeX doesn't need to know about that. PDF constructs, I mean, I'm thinking things like creating color spaces, creating masks, soft masks and things. If you're making PDFs, obviously only PDF specific, but again, definitely not something TeX knows about. And obviously tagging, an important topic as we've just heard, and yeah, TeX doesn't know anything about that, and again, something which postdates TeX being written, but that doesn't matter. Because, as I say, there were things that certainly were there from the word go that TeX didn't do, but Knuth had given us a mechanism to handle that. So if we look at a sort of, I'm going to say, the classical approach, how Knuth would do it essentially. If we take a plain text document and we want to put in some color, what do? Well, if we're a plain user, we're obviously going to write this for exactly the output format we want. So we're going to know all of this stuff, and we're going to hopefully, we're a plain text user, we're also going to know the code we do need to create the colors or tagging or whatever, and we're going to do it all manually. And what's that mechanism? That mechanism is the primitive special. And the primitive special is Knuth's solution to this tech can't possibly do everything problem. You have a single command that takes balanced text, some arbitrary information, which it doesn't know anything about. And it is just going to put that into the output. And here, as I'm thinking about a classical plain situation, that's a DVI file. And it's going to put that, and it's going to say, right, the next thing that looks at this DVI file can do something with this. I don't know what it is. And so then that means, of course, that whatever we put in that argument is going to have to be written for what we know we are going to do next with our DVI file. So what that is going to mean is, and the reason it's called special is that the nature of that text that goes there, that information, is going to be completely dependent on what our toolchain is. And I say, if you're a plain user, that's fine because you're in control of everything and you know exactly what you're doing, and you can adapt it. You know, if you switch your toolchain, you'll go back and just edit this because you'll be knowing what you're up to. But in the LaTeX world, we found that most users asking them to understand the syntax of specials would be completely insane, because asking them to understand the syntax of LaTeX, which is written in a very nice book that Ulrika's just held up, and it's like people don't seem to get that at all. So the idea that, or telling them you've got to change part of your source because you've changed from making a PDF with PDF tech to a PDF with ZTech, I think would be not a good sales pitch. That has been a problem, or something that the LaTeX team have thought about for a long time. And so we go back to certainly the early days of LaTeX 2e. I'm not sure exactly when David wrote this, probably early 90s. We have this file here, drivers.dtx. And I've taken just a little bit of drivers.dtx. And essentially, I'm going to come round full circle to this idea, but there's some subtle differences. So how does this work? The idea is that we have a number of different, what I'm going to call backends, things that take classically the DVI output, or now built into the engine, and we get direct PDF creation in PDF Tech and LuaTeX, and they're going to do something with it. And each of them is going to have its own syntax, but they're going to have commonality. If we want to set a color at a high level, we want it to be green, or we want it to be red, was my example, and the user, in a LaTeX sense, doesn't care what is going to happen. Red is red. So they're going to put color red, and then stuff is going to happen, and we're going to get to a point where we can't anymore ignore what backend we're using. And that's where these files are going to come in. They're going to define the bit of the process that is backend dependent. And if we look back to, say, the early days of LaTeX 2e, that's a long list, and this is not the full list of provide files in drivers.txt. It's as many as would fit on the screen, missing out the first one because I wanted the first one on my list to be DVIPS for reasons we'll see in a second. So if we look at that list, what we'll notice is there's only one of those backends that's still in use, and it is indeed DVIPS. The rest have all disappeared into into history. And so this looks like a good plan in many ways. So why am I having to talk about this, say, coming full circle? Well, what happened is, so that file got written, and then obviously life happened, but things are being developed, particularly PDF Tech initially. So new engines, PDF Tech, ZTech, LuaTeX, PTech and UpTech as well, and so they may impact, and new backends. So we've saw on there we had DVIPS, which we're all familiar with. We had DVI PDF, I think was the one that was on the list, which obviously now we might see as a sort of successor is DVI PDF MX, but it's certainly not the same, and it's got different things going on. And there were ones that were not really thought about at all back in the early 90s. So new backends which need new support, but essentially, drivers.dtx was frozen many years ago because at the time the team didn't have the resources to address that, but also contributing was tricky, and because people wanted sort of, there were lots of people working on different platforms initially, and it wasn't easy to, great, wasn't easy to deal with trying to keep up with all of that for the team. So what happened? People looked at dvips.def, and so it's sort of, in many ways, the standard def file, because, as I say, that's the back end that has stayed around, and it provided a lot of useful features early on. And so people took that file and then added features to it, or added support, edited it to bring in new back-end support. And if we talk about new features, a lot of those were added as the PDF-Tech engine was developed. Lots of stuff got added there. In particular, if you look at PDF-Tech, so we've just seen Knut's solution was this one primitive special, which doesn't know anything about what's going on in the contents of that argument. But PDF-Tech, although you can do some stuff with special, that's not the best way of doing it. And the reason for that is that particularly when you get to things like hyperlinks, you want to know that the engine needs to track things like where the outside of the link is, because of the way that hyperlinks have to be made. And that means that you can't just have a black box. PDF-Tech engine actually tracks stuff about these various primitives so that they work together. So there is a need to do things slightly differently. There's also features added there. So historically, or until we sort of came back into this area, the PDF-Tech.def file was adding new keys to graphics to support features which DVIPS doesn't understand, like multi-page image inclusion. And so that you end up with a sort of divergence of support. So then I sort of came into here to look at, with the plans, the team to try and provide a consistent programmers level interface for all of the primitives that you might want to use. And that means looking back at how you provide those interfaces to the back-end file systems in order to re-abstract them into that sort of model. And so I looked at this and I thought, well, the drivers.dtx plan was a good one. You've got, if you look at making lots of separate def files, we heard yesterday about reusing code and not writing things more than once, and you end up doing exactly that for backends which share similarities. Most obviously, PDF-Tech and Lua-Tech share a lot of similarities in how they approach things, as they both make PDFs directly. There's also quite a lot of overlap there with ZTech because it can do some of that. And so you really don't want to be having all that written out separately. So I went back to the idea of having a single source. The other idea was, if you look at the early 90s files, they cover color and graphics because they were the things that were known to be covered at the time, and then they got frozen and other stuff didn't get added. So how did people add other back-end specific features like hyperlink support or drawing support or tagging? It's all done by having lots of separate little files for each package having to do its own back-end test and then define its own interfaces. And sometimes there's repeats there because it turns out you actually want the same ideas in different areas. So the idea was to go back and say, right, no, we want to sort of cover all of the, or as much as we possibly can of the back ends, and over time to extend rather than to start with a fixed list. There's also an advantage here, far fewer back ends to support. So the days of having different people having different platforms or different commercial tech implementations with their own back ends that had to be handled separately are in the past. So we have essentially a fixed list that we support. There is a little bit of variability when you start thinking about people obviously doing their own engine development, but if you look at end users, they're going to be using backends that are available in TechLive or MikTech essentially, and we can predict that list. So that makes life a lot easier. It also means we can test them because we can run all of that on our automated testing system. Documenting decisions, yeah, so writing back-end code is interesting because you read the documentation for a lot of back-ends is quite sparse, and there's a lot of information that's been collected up about what actually works in various def files with limited comments in them. So particularly ZTech is probably the worst offender, and the reason it is ZTech uses the XDVI PDFMX backend, and it always does. That was originally a separate program derived from DVI PDFMX. Now it's brought back together, but that fact that it was derived and then someone else was writing it meant that it got some support added that was separate from DVI PDFMX, and they then inherit some stuff from DVI PDFM, and then that inherits some stuff from DVI PS, and it's also got some direct PDF production potential as well. And so there's sometimes 4 or 5 ways of doing the same thing, but you need to test them out and work out which one, when you put them together, still produces the result you'd expect. And that means when I say produces the result, it means you actually have to look at the output and check it looks right. So think particularly when you start combining rotation and hyperlinks, that's a place that things can get very hairy. And also, because of this idea of wanting to have a single source and have things brought together, there's also the idea, you know, if you can do stuff the same as PDF Tech, which is now kind of the reference backend, then I'd favor that over some other method. So, but you want to document all of that. Why did Joseph pick this one and not something else? So that's all the idea that we can actually document it. There's now a clearer route for addition. So, yeah, if you go back, you know, if you'd wanted to make a contribution to drivers.dtx 30 years ago, you'd have had to email the team list, and then that had to go into some baroque system via various people to get it into the sources, and then you'd have to wait for it to be distributed, whatever. So now it's a lot easier if people do want to suggest additions. The sources are on GitHub. Obviously, you know, other hosted solutions for distributed version control systems are available. You know, don't want to be tied to any one particular system, but the point is there are lots of those. It's a lot easier for people to see and contribute to the code. So if there are new backends to be developed, that can be done. It doesn't have to be done by the LaTeX team. Obviously, there's a limited number of people who know Expo 3 and the backend detail, but actually, I think people developing any new backends would probably look at one of the existing ones and hopefully stick close to what it does, because going completely off-piste is probably not a great plan. So that takes us to sort of the question of what's supported. So at the moment, if you look at the list that you can load, it's quite short. So there's PDF Tech and LuaTech for making direct PDF output. DVIPS is still there. There is some fun there. You get into, you're abstracting stuff out, and you can't abstract, it drives to some extent what you decide to do. The moment you want to support PostScript, you have to deal with the fact that PostScript, when you do color, doesn't have the concept of stroke and non-stroke color, whereas PDFs do, and PDF Tech and LuaTech have multiple color stacks that can be used to track that, and DVIPS doesn't, so this sort of thing. So the list of backends you support drives where you have to put your abstraction. So particularly, I've also got DVI SVGM there, and so that's not making PDFs, obviously, it's making SVGs, and it turns out there's quite a lot of features that all of the other backends share, apart from DVI SVGM, so that means that rather than have it, so it means that ideally, the backend files would have, you know, only the code that's different. But because you want to support that, you have to, where the difference is, moves around. So here we have DVI PDFMX, and although it's nowadays the same program, there's 1 or 2 subtle differences in the way ZTech can do stuff compared to PDF Tech running in DVI mode, and so you have to have a separate backend file there. And then we can think about the features that we want to include. So you've got color, which I think is one that, you know, we've been around for a long time. Image inclusion, again, quite straightforward. It's got a little bit more straightforward maybe over the years. Box transformations. So the original design of the graphics package was driven again by what the back ends at the time could do. And at the time it made sense that you would try to leave image, scaling, rotation, whatever, to the back end, and you wouldn't try to scale, you couldn't necessarily scale, rotate, whatever, other content. For Expo 3, gone slightly differently. In the image inclusion, it's just image at natural size as it is. And then if you want to do rotation, scaling, whatever, that can be applied to arbitrary content. So those two are separated out. So box transformations, clipping, rotation, scaling, skewing are all separated out. Drawing, so obviously we've got Henry here who looking after PGF. So drawing there, I said lots of PGF type stuff, putting graphical type commands, draw a line, draw a circle, whatever. Now, obviously, not about to compete with PGF because there's the TIX layer particularly on top of that. Does a massive amount of stuff, but at the same time, one of the design aims for Expo 3 is having documented progress interfaces to all of these possible functions. So there is so that means you need back-end support for all of those things, and that code is heavily modeled on the one from PGF, other than one or two places where I slightly rejig things. Hyperlinks, again, as I said, hyperlinks are interesting because when they start, because of the way hyperlinks actually work, you have to worry about their interaction with any changes to the canvas of when you're making a PDF. Then we've got tagging. Now, currently, tagging is partly in the core drivers and back-end files, and partly in some that is in the test phase because that's still got testing going on. But Ulrika and I know that will be, say, that aim of having it all in one place. As we firm up, finalize decisions about the tagging, those tagging parts of the code, the back-end code will move into the same core files as everything else, so you won't be loading multiple files. Be one set of files to load. And then PDF structure, so that's again more complicated. What do I mean by PDF structure? That's stuff, it supports things like color spaces, like the tagging to some extent, and that's things that have to appear once and have to be managed globally, and they are interesting to deal with. And again, that's one that's currently not in the main files, because there's still have to work out exactly how we coordinate management of that with things, other packages which also want to manage these unique structures for PDF creation. But that is what we're doing. The idea is it's in many ways a sort of history going round in circles, that we've come back to the same idea that we had a long time ago. But I think if you look at the work we've done on this over the past 10 years probably, we've shown that we can get all of this stuff in, and now that it's much more responsive to changes and to get improvements, I think that is a good thing. And hopefully, the other thing I didn't say on the slide is there's also testing on this, which is important. Obviously, we can't test the output. You can't test what the output actually looks like. You have to look at it, but you can test that you don't at least mess up the structures that you've created. So if the structures stay the same, then you're confident that, other than viewer fixes or whatever, that it will still look right, or at least you know when you've changed it, which is, again, very important. So the test suite we have runs the tests for all of those different backends to make sure that we are getting what we think we're getting. So that is what is happening with backend support in Expo 3. Thank you very much, everyone.
Thank you, Joseph. Please, before it's too late, ensure that your phones are silenced. Okay. Sorry, Joseph.
That's okay.
Any questions?
I somehow had an impression that you had backend for hint format, but I don't see it in the list.
So no, we don't. So we've looked at, so hint is currently not in Tech Live for a start, so testing it would be very difficult. Or it is, but it's not. The version that's in Tech Live is, because of the way Tech Live works, is a long way behind the development version. So I'd be reluctant to add it into the release code. There are some complicated questions there, particularly about image inclusion, because of the way hint works, images don't have size, and then doing image inclusion is interesting, because a lot of, back with the idea that your level of abstraction is driven by what the common position is, and it means that the common position doesn't work, and then it's not clear to me exactly how to handle all of that. So at the moment, I'd say hint is probably still too much of a moving target to really consider adding to the distribution set. So it's a question of we can talk about things and work out how we might do it, but it's not really at the point where it would be sensible to include.
Any other question? Of course.
I have a question as an engine developer. Wouldn't it be easier if the LaTeX team would say, okay, we have a specification like for image inclusion of a set of primitives, and whoever wants to use LaTeX with images has to conform and just provide that set of primitives.
Well, as I say,
and that would push the responsibility away from maintaining drivers to those who develop engines.
Well, it's...
I think it would also be better for the engine developers if we would have a clear specification. This is what you need to provide, and period.
That's tricky, because if you look at that list of supported backends, only 2 of them use primitives in the first place. The rest is all just special and whatever's inside special, and a lot of that's history. I see what you're getting at. In the end, I mean, so in the end, we can define a backend that simply has lots of no-ops where things aren't covered, and to some extent that's what happens with DVI SVG, because a lot of it just doesn't apply. We haven't. So the reality is that for the past 15 years, 20 years, probably nearly, that list of engines, other than LuaTeX development, which was originally just PDF Tech anyway, and then the split was quite clear because the syntax of the names changed, but the way they worked essentially didn't. We haven't really had to deal with people coming up with new engines that need a spec. I mean, I suppose we've tried to be as flexible as possible. I say the specific issue for hint is the image inclusion. As fundamentally, whether you could come up with a spec that would work doesn't make sense, because if you're going to say the images don't have a natural size that you can query, then that's quite difficult to see how you deal with that.
I think we can deal with the hint problems on a... It's included since TechLife 22, so it's already there. And images that don't specify a size might not have one in hint. That's right.
I guess this has been mentioned, whether we should have a standard set of requirements. It's certainly doable. I mean, it will just be a question of me going through and working out exactly where the abstraction level sits for everything, and what information is absolute. It's probably not primitives, it's a question of what information do we have to be able to access in some way. I see what you're getting at, yeah.
Any other question? If not, I don't see any. We can thank Joseph again. And the next speaker is Frank Mittelbach, who didn't save my life by providing the porting of AMS Tech to LaTeX and making me addict to LaTeX. The title of the presentation is, of course, the LaTeX Companion, 3rd edition, Anecdotes and Lessons Learned.
That's difficult. That's not good. How do you do this? I have the wrong shirt, obviously. Hmm? Yeah, it didn't hold. It's good? Good enough? Okay. Okay, yeah, welcome to my talk just before lunch about a monster, which is not the L3 backend or the L3 language, not context, not something else, it's this. And you probably have seen it a little bit, if not, yeah, here we are. 3.5 kilograms heavy, so anybody who wins one of those two has to see if it fits the luggage. This was the first review we got on Amazon, and I must say I'm mighty pleased, except for seeing a misspelling of my name, but that's actually usual. And the person, I don't know who was he or she, is quite right. It was a really, really heavy task. So this here is the publication data. And you see one thing at the top, both books or parts are in multiples of 16. And that's not just by chance, in contrast to George Orwell. It's actually just because that's a magic number in many publishing processes. You need to have 16 pages, multiples, or if you have one more, then you have 15 empty pages at the end of your book. So this is something to watch out for. And I try to keep 1 or 2 pages empty, and it was good because, as you will see in the end, it turned out that I needed those last-minute corrections. Okay, so the other thing the review said was, I was slacking off, or we. Why does it take, or did take 5 years? So basically, we had a 3-phase project. I worked for maybe roughly a year reading 5,000 package documentations, plus thinking about where this package would fit, or sometimes just thinking, okay, good, next one. But often just cataloging. I had a huge spreadsheet, cataloging where those things fit, how they relate to other packages, whether the next step then was figuring out which of those are worth putting together as a sort of unit which would form the companion, because you don't want to describe 5,000 packages just because they're there. In the end, I ended up with about 500, and yeah, for all of those, there was a lot of work to be done to, in this next phase, to think about examples, make sure everything actually works according to documentation. Seldom does. None of my packages did, because there were additions that were not documented and vice versa. So there's a lot of, in the second phase, which took about 3 years, and then of course people changed the rug under me because they changed their package where I had already done the work to sort of work on documenting it. But that's understandable if it takes so long time. And then there's another one, which is the last year, which is really the time it took to get from finalizing the book through copy editing, indexing, everything to finish off. And the moral of the story is really here, do your maths early and try to do it correctly and have some thinking about what it really means you undertake a project like this, or any project which is more than 5 pages for a conference proceeding. For example, if you have something like 1,600 pages and there are average of 8 copy editing errors in it. Just think about how much time you need to correct and do those things. It adds up to months very easily. So, what's more to say about the book? Many Stack Exchange minimal working examples show you a preamble with 20 packages. Some of them not necessary. The LaTeX companion is much worse in this respect. I have actually 140 packages, or let's say .sty files loaded, and all of them are necessary in one way or the other. And on the plus side, it shows how many packages you can actually put together, and they work with each other if you're careful. On the downside, it's just not normal. That's the way it is. And yeah, another thing about this enormous number of packages, in chapter 10, I really worked through with Adam Twardoch from Poland, who through all the fonts that are now available, even in PDF tag, and figuring out what the quality fonts are. And in the end, I have more than 100 font families being described and shown. And shown means I had to load them all into this document. And that blew actually Standard Tech Live, which is unusual, but that showed where you can still find limits that do not work. So what other packages are there? Yeah, certainly hyperref and bookmark. For main text, I used acro for the acronyms. If you do use this, you have to be a little bit careful about the fact that, or you learn this the bad way, you cannot use include only anymore, because then your text changes. Each time you have a different combination of included chapters. So this is one problem with the package. CS quote, yeah, that's normal to get standard quotation marks in different languages. Varioref actually saved my life, I would say, in some sense, even through I have written it myself. But if you think about having to do layouts and all your floats and example changes from one page to the next, and each time you would need to touch the text to say, that's on the next page. Or take away the reference about the page number because it's on the same page, which is also very odd looking. All these kind of little things. Varioref did this for me. So when I was coming to the layouting process, of course the text changed, but it changed automatically. So I hadn't do much about this. And the other one, which was really, really good for in my opinion, I mean, it's enormous, the fact that we nowadays have the possibility to do the HZ algorithm, and therefore getting slightly extended or compressed fonts gives a much better quality in the paragraph breaking. And I personally like hanging punctuation very much, so I did this as well. So what's not going? Yeah. Yeah, bigger structures. The book is old. I mean, the first version was written in 1993. And so some of the class code is actually from the days when we developed LaTeX 2E. And it hasn't changed much in the class, I mean. So chapters, lists, and so they were all done the way LaTeX core did it back then, and still does it. So I didn't use any extra packages for this. Title talk was added recently to get partial table of contents per chapter. Of course, if you want to do any kind of decent tables in LaTeX, you need to add a little bit of extra support. That's the packages. Overpick is a nice package if you want to annotate some pictures. Yeah, caption is a, I would say, if you want to have decently styled captions, it's a no-brainer. And T-color box is great. We use that for the the boxes where we talk about Unicode Unicode engine specialties, so that it's clearly marked and easy to find. So that was a nice addition as well. Page layout, the same. This is done manually. I would use these days geometry, I guess. Fancy header, that's already an old package, so it's already used for quite a while. Indexes, I come to this later, but I use make index, which gets you only that far, and the rest you have to done by scripting. If you want to get a good index, nothing else works. And BibTeX also is not surprising. BibTeX, because the previous editions used it before, not bib for the citations. What is new this time is that we use bib units, which allows me to have two bibliographies in one run. One for the first part, the first book, and one for the second, because both books were produced as a single run, and then cut in the middle and sent as separate PDFs. Okay. Examples. This is really at the core of the book. We have about 1,500 in the book, and one important part that I learned is they have to be correct. And that's not easy. In the first book we did this wrong, and I know that it always happens again to me if I'm not obeying this kind of sort of basic principle that you actually do the thing, not just talk about doing the thing. So if you have a picture and you explain what you did to produce the picture, guess what? Out of 10, 1 is not exactly linking up. So all examples are produced. So if you see a mistake in the example, then it should show in the source. Or it is a mistake that happened in the package that it is describing, but input and output is identical. Oh, sorry, identical. The output is produced from the source, and that's very important. So what we use for this is fancy verb to get the stuff out into a separate file, adding a preamble and a postamble to it, running the whole thing, producing a PDF, cutting it to the size of what is necessary to load back, and loading that on the next run into the book, and so showing the source and the output side by side. You can still make a mistake because it takes a long time to produce 1,500 examples, so you don't do this all the time. So guess what? Don't change the example without rerunning it. That's still a problem along the way. Okay, those were sort of the important packages used by the book, but there are some sort of things that I classify as support packages. And what is really saving my life in this book is more rights. You may know, TUG has only 16 streams to write to files, and if all these 16 streams are used up, then TUG says, thank you. By end of story. It can't do more. And packages tend to open streams for good or bad reasons, because they want to have that extra lock, for example. And if you load 140, guess what? It needs something like 19 streams. And so this is the answer to this problem. It comes with a cost. Everything goes a little bit slower, but at least it goes. So I'm really grateful for Bruno to having produced this. The other support stuff is color spacing. We have spot colors in the books, one spot color, and that means we have to produce that, and that's not easy. If you have spot colors, you're only supposed to have the spot color and black in your PDF. No CMYK, no RGB, and some packages just hardwire something like RGB values in their code. You have to find this, and then actually patching the stuff. There's no way around those for the book production. To-do notes, I like this. It's not perfect, but it helps a lot if you work on a longish project, because you can put all your remarks, notes, and something directly in the source and keep them around without making the layout going too bad differently. And the other thing, if you're one of those people who never have a problem with what you do, then you don't need it. But otherwise, having some extra structure in the log file is helpful to find out where a problem occurs, because if you load many files, it's not easy to see which file is currently open from which this error is coming from, so that helped. Another one, Lino, I think it's one of the oldest packages, really. It's amazing. I was able to use this package, which is patching the output routine and everything, to produce line numbers for the whole book, with one exception. There was one point where I had to disable it for a certain point. I can't remember why. But basically, it worked throughout without any problem. And this was necessary for doing the indexing, because indexing was done by giving the indexer a line-numbered form of the book, and then he gave me indexes back according to lines. So that was the idea. The other thing, if you have a big project, you need source control, and certainly source control in this case, previously it was SVN, now we used Git, and yeah, it's just important to be able to be on the safe side, to be able to roll back something, to figure out what changed. And what is also quite helpful is the this job thing, mkjob tech mf. You can basically get a full set of all files that are being used in a run and collect them in your own tree. And this is a tree that I put on the source control as well, so I had always, well, regularly information if something changed. Now normally, that is not so important if you keep your tech system maybe more or less stable, but in this case, I certainly wanted always to have the current versions of everything. So it changed quite a lot with what changed outside. Some words on the production workflow, because that is also interesting. This book requires 7 runs of the full book before it's stabilized. It surprised me a bit. I expected something, but I didn't expect 7 runs. There are reasons for it, and if you think about it, what the complexity is, first there are no examples, then the examples are not on the right page, and if they are on a right page or a left page, they look different, therefore you need to track this takes another run, then things change because of varioRef, the text gets longer or shorter, that might change the line breaks, and then 7 runs. The whole thing takes on my iMac half an hour, and if I make the example, it takes another 2.5 hours. So a book production from 0 to everything takes 3 hours on that machine, which is not the slowest one. The bottom part is very, very important. None of this can work without checks, and these checks have to be automatic. Automatic. This is really the point. You have to build yourself checks for everything you can think of, and they need to be automatically tested. Don't expect that you can remember what you need to look for at the right point in time and actually do this. Also, something like the 7 runs, I had scripts which were doing everything. I had scripts which were doing some of it. It's really important that you have a workflow that is stable and you just press a button and wait, and you get errors back and everything. So this is, otherwise, Yeah, I'm not saying nothing is wrong in the book, but otherwise it would look worse. Lessons learned from all the 3 editions. First of all, I already said that. Not just describe something, actually make the stuff when you describe it and use it. Both is necessary. In the first edition, we had a bunch of those cases where we just made floats and described it, and they went out of sync. Something I always preach, never think about pagination, line breaking, and page breaking whatsoever before your text and everything is finished. Well, this time around, I didn't obey myself, and just about at the end of copy editing, more or less, I looked at the stuff and decided, well, actually the typewriter could be half a point smaller in size. Or 0.1, I think it was. Because then it aligns a little bit better with the other stuff and can't do much harm, can it? It took 2 days to get the sources back into, the output back into sync. Yep. The other thing that I learned over the 3 editions is try to keep all the layout code as separate as possible. The very simple suggestion is, instead of saying something like \page break or \clear page, because you want a certain point with an explicit, say something like, I don't know, final clear page, or whatever you come up with as a prefix. Make your own commands that are just aliases for the standard ones. Then you already distinguish between an extra vertical space that you always want, or an extra vertical space that you added to make this page look right. Because next time around, you want to get rid of all the extra spaces you added if you do a next edition or just an update to something. And those that are really meant to be always there, they should stay. So this is very important to separate as best as possible. Yeah, later in the game you need to start, you really need to test for pagination changes. When you start doing your layouting, when the copy editing comes in, you don't want to sort of see something being messed up and you end up with half-empty pages. And we got better in the 3rd edition, we got better in the 2nd edition, but I think this is now okay. And as I said before, automated the testing. I have seen books being sold where the bibliography showed the bib LaTeX label. No joke. I was surprised that it was done with LaTeX, but you could clearly see that it was a bib LaTeX label showing up in the text rather than the actual reference. And I remember that one of the Kopka books were very embarrassing for Edison Wesley, Germany, where everything had question marks instead of page numbers. Yeah, those kind of things should not happen, and they can be prevented by having automatically testing for all these kind of things at the end of your run, and the point is automation. Some statistics. Making a book like this is really manual work. Tech or not tech, the end of the story is if you want to have a good layout, you get 80%, and the last 20% is the hard work to make it doing. So this book has about 60 double spreads where I either went one line up, so one line less, or one line more on the double spread, to avoid a real problem at the end. And the problem with the companion is because of the big examples, they just don't want to break nicely. I mean, they usually end up in the middle of a page break. And so this is not easy. If you do layouting, you have to find a method how to get a whole chapter going. And if you start from the beginning, make everything fine, you end up in the middle of the chapter suddenly, and there's no way to get the next page going without having this amount of empty space. So what I started to do is to go the other way around. I first looked at the whole chapter 5. Yeah, it's okay. Never managed to get through those. But what I did was to look at the whole chapter, then find the problematic spots, put hard page breaks before and after, and try to get this spot working in 1 or 2 solutions, and then started from the beginning to figure out if you can reach those solutions. In other words, global optimization on page breaking done manually. I have, as some of you know, tried to solve that problem programmatically and actually succeeded with a prototype, and I had hoped to have it here for this work, but it's still a prototype. So everything by hand. You see a lot of stuff there. The other thing that I did, just quickly, this spread stuff was done on the outside, so for each chapter I have a file that tells me whether I have a normal page or a long page or a short page, and then that file is being used by the run, and you can easily change your layouting this way. I have also recording the pagination. This is giving me information about the final page simply by boxing and unboxing before ship out. So I get information about how much space there is. This is important for many reasons, one of which is I keep a record of that file and compare it to the previous run, so I see if things changes at the very end. So if I make deliberate changes, I expect changes in a certain area of that file, but if something else completely changes, then I have done something which unexpectedly changes somewhere else in the file, the problems. So the book got too big, so we got into this problem. What do you do if you suddenly need to split a single book into 2? And there are a bunch of questions that then needs to be answered, and it's not easy to answer them. We played around, and I thought about many things. What we ended up with is this. In the book, we restart page numbers per book, because that's otherwise hard to use if you have 1,507 or something as a number. And then we have these other things done that we cross-references from one part to the other by marking the cross-reference especially. We use bibliographies for each part, and we use a combined index for both parts, which means we have these pages twice in each book once. Oops, doesn't work? Does work. Digital version is different. You want a single PDF, and then, of course, you don't want to have 2 indexes in the middle. You don't want to have a front matter in the middle. There's a number of things that you need to do differently, and everything had to be in a single file by the end of the day, so there was some programming involved to get both versions out of the same source. But this is what we came up with. And there are some non-trivial stuff that suddenly, in 2 examples, I have a bibliography used, actually. So the example uses something out of the bibliography. And this is now changing, so I had examples that I had to redo for the digital version. 1 minute, okay? 1 or 2. How to make a good index. That's really something which is non-trivial. I don't know if we make a good index. I hope we do. A couple of things that you can see. First of all, we have the symbols always also showing you actually the symbol, more or less at least. There are differences in the page numbering. If this is blue and bold, that means that this is the main reference where you find the definition or something you really should look up first. You see whether it's coming from part 1 or part 2, or both. What else? If it is an example, it is done in italics, so you know this thing is used in the example as well. Interesting is that the line breaking tends to happen between part 1 and part 2. For example, a line environment. Part 1 is on first line and part 2 started on the second line, but this is not happening if this other would produce 3 lines. So for example, Allegria fonts at the second or third line, that is not starting another row. So that's the way the index was done. Yeah, this is a set of disasters that happened just before going to print. I'm not going to go into those. We solved them. But of course there will be others, and therefore there is an errata file, and it is improvement for everybody, every reader, if we find the error. So I invite everybody who has the book and spot something being wrong to send it to me. So we did in the past time. There's actually a chance to win a prize, but that shouldn't be. The prize is also that it makes the book better for everybody. But there is a real prize, or 5 or 6, depending on how long Pearson is going to do it. So if you find something in the book, you have a chance today by looking through it, even without owning it, please tell me. And with that, off to lunch. This is not meant to be a design show, it's just taking from page 11 of the second book, basically, how to do stuff badly with fonts. Okay, thank you.
Any comment or question?
Is it on? I don't think so. Okay. Now? No? 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 Yes? Yes!
Okay.
One short question. Why the decision to include the examples in the sources of the main file instead of going the other way around, having a folder with all the examples in separate files and only including them would save you one run on every run?
Well, first of all, historical. Second, I want to have the examples next to the source where I describe it. I don't want to have those things open. That just works nicely if you work with the example. Sometimes you have to change the example. I didn't speak about, in the layouting process, for example, one of the tricks was, oh, this example is too big. Well, make it smaller. Or we need some space without filling some space. Why not make an extra line in this example to make it look nicer, this page? Those kind of things. It's very nice if this is all in the right kind of place. So this is an advantage. Taking the stuff out of the source into an extra file as it done is all automatic. And yes, it needs a first run, but practically during the development, the examples were already pre-made, and they stayed pre-made unless I changed an example. So that didn't cost me anything other than in the very, very final run where I always decided to go from scratch and throw away everything that is generated throughout. But otherwise, I find it good to have those things in one place. One chapter per, well, actually, These days it's 500 files or something because it's one file per package, basically. But then everything of that documentation is in one place. Way of working.
You mentioned the structured log package.
Yeah.
But I couldn't find it
On
the CTAN.
Well, it is part of LaTeX core, so you don't find it as a separate package. It's a small addition that is automatically delivered by LaTeX. So, yeah, this is one of those things where we are not very good in the LaTeX core. If it is, there are some packages which we miss TechDoc documentation because they just come out of one of the LaTeX core files that build the format, and structured log is one of those cases. So maybe we should get better. But it was documented in LaTeX news, whatever, recently. So if you do TechDoc LaTeX news, then you find it, definitely. And it's documented over there. Oh, forgot. Yeah, look in the back. Yeah, somewhere, yeah.
Maybe you just need to have the C10 team make it easier to find there.
Yeah. The problem is we always have these little things to improve. And my experience is that they still hasn't got 48 hours. It's a lot falls back, yeah, but I agree, there is something wrong there. Lunchtime?
Last question.
Last
because lunch
question.
is waiting.
Sorry for this trivial last question. You use PDF separate what for? Did you print out all pages separately?
No. Sorry, that was in the examples. When I make the example, it becomes a single file. Typically, this file has 2 pages in it because, well, for various reasons. And one of them I want to take back into as a PDF graphics into the book next to this example source. So this PDF separate is there to get 1 or 2 of the PDF pages into separate graphics. That's all it is. And the other one is crop, where I cut off everything which is white space on the outside to make the example as small as possible, just showing what is necessary.
So thank you, Frank, for the talk and mostly for the book. And of course, we need to thank again Ulrike, who's the co-author, of course.
I had prepared something, I didn't look at it, so I forgot 2/3 of it and said too much about others. First of all, in the audience, there is one person who helped me enormously, and I would like to thank him for, and I hope he's there, Nelson. He actually read through all those pages. He was the first proofreader and copy editor for content, and he marked everything up, and I got them back as marked, handwritten, marked pages, scanned in back, all pages, enormous. And then I also didn't say something about it, but yeah, current authors, nearly everybody is here. Ulrike is part of the author team. She did help me a lot. And Johannes is there, and Joseph is there. And the only person missing, unfortunately, is Javier. But basically, most of the authors are there, so you can bug them as well.
lunch until at 2 o'clock we continue. Lunch is around the corner, you know it, and then for night afternoon session.
to the conference after the lunch break. So I learned there's only one requirement for the chairman this afternoon, because we just have 30 minutes between the scheduled end of the 2 days program and the depart to the banquet. Don't be nice. So obviously there was nobody from Vienna, so they took me. So I ask all the speakers that are coming and all the participants who want to ask questions to please stay on time. Okay. So this afternoon we have several talks that are combined with paths, curves, fonts, MetaPost, and so on. And the first speaker that should appear here in a second, live from his breakfast coffee in Vermont, is Jim Haveron, and he will make the bridge between MetaPost and Asymptote as a different tool for drawing nice curves. So, and now I'm curious if he will appear.
Hello, afternoon. Well, it's afternoon here anyway.
Okay, welcome.
So I want to talk about using Asymptote like MetaPost. And the abstract is that Asymptote is a descriptor vector graphics language for technical drawing that fits well with LaTeX and friends, and I think it deserves to be more widely known. So that's why I'm talking about it. One appealing thing is that it's in part based on the algorithms from Metafont and MetaPost, but it extends those to 3 dimensions. I'm going to discuss a couple of workflow things that a beginner to the system, particularly a beginner who's coming from MetaPost, might like, and the main one is using a single source file to output many related graphics. Okay, so the introduction, again, I don't think that Asymptote is as widely known as it deserves to be. Asymptote is a powerful descriptive vector graphics language. It uses a natural coordinate-based framework for technical drawings, and LaTeX, of course, typesets the text and the equations. To me, one of the appealing things is that it is a good impedance match for what goes on between my ears. When I think about a graphic, I think something like, let's say it's a 3D graphic. I think something like, okay, so draw the axes, and I want to do an orthographic projection. I'm going to be at, 10, 5, 2, and looking at the origin, and I want to put a sphere over here and a box there with a red line between them. All those things are easily said in this system. Of course, there are other systems that also have this capability, but I'm talking about this one at the moment. So basically, what I just tried to say is that it's mathematically oriented. It's not kind of a drag and drop system. It's inspired by MetaPost, but it has a more standard C++-like programming syntax. I don't know, I always found MetaPost very hard to program in. It's IEEE floating points, and it fully generalizes MetaPost's path construction algorithm to 3 dimensions. So it's time for a picture. So let's see if I can work this thing. There we go. Okay, so I'm at the Asymptote web page. So asymptote.sourceforge.io/gallery/3D graphs with a D is capitalized. And I just picked a graphic because I thought it was a reasonable graphic to use for this purpose. Where'd we go? There we go. Okay. And you can see that it does a nice job drawing pictures. I mean, the figure does the kinds of things that I want figures to do. It does a good job drawing the planes in the back, the left side and the bottom. It draws the sphere part very well. You get the letters drawn in LaTeX and the different colors and the arrows, and I don't know, it all looks the way that I want my graphics to look. So that's appealing. A person probably is saying to themselves, well, what does the source code look like? So fair enough. So here's the source code, and to me, without going into it at great length, I'm not going to go into it at great length, it looks like the kind of programming language that I'm using when I'm not using this. That is to say that it looks like a standard programming language. The lines end in semicolons, you declare things, all the things seem pretty routine. So it is something that if I put it down for 2 months and pick it up again because I have some bug and I need to fix the bug, I'm not saying to myself, oh, how do you do that again? It all has the sense of the kinds of things that a person usually does. And just very briefly here, you import the three-dimensional code, you import the math code, you put into the preamble of the tech document that is used to draw to make, for example, the lettering on the diagram you just saw, use package BM kind of thing. There are some parameters, and the current projection is perspective from location 4, 1, 2, looking toward the origin. Then you draw the surfaces, the back, the left, back, and bottom, and etc. You start drawing the figure, and it all does what you'd think it would do. So I find that appealing because, like I say, one of the things that characterizes working in this language is that I don't work with it for months at a time. So the fact that it does what I expect it to do is a big plus for me. Okay, so let's see, back to the discussion that I was having. The second point is that it generates high quality output, high quality PostScript, OpenGL, PDF, SVG, WebGL, V3D, and PRC vector graphics. So alphabet soup, even if you don't know what a lot of those letters mean, I just want to discuss the PRC vector graphics. So if you are making a PostScript, a PDF output file, and you want one of these things where you reach out with your mouse, you're drawing a 3D graphic, you reach out with your mouse and you click on it and you can turn it and look on different sides, pick it up, look underneath kind of stuff, that's PRC. And as well, it does a 3D vector WebGL graphics. I wanted to show that too, so let's see if I can manage to work the system to do that. Here we go. Again, this is from the Asymptote webpage, and I just kind of picked a graphic here, this one here. It's called Gaussian Surface ASY, and it's, that's WebGL. I mean, that's all happening in the webpage. How hard is it to draw? Well, it's not hard at all. It does what you think it would do. You import the 3D graphic drawing, you make the figure be 200 by 200, that's PostScript points. But anyway, your current projection is a perspective from 10.4.8. There is, you recognize the relevant function, and you draw the rectangle underneath it, and it's all pretty straightforward. I mean, of course, the things have to be learned, but it is at least not some kind of crazy stuff. So that's appealing for me because probably most people watching this video know that I'm not the brightest bulb in the box. So it's helpful to me to be able to work with things that are familiar. One of the things that I like about it is that it recognizes a problem that I've had many times. I'm sure everybody watching this video has had. You have some figure and you need to adjust it. You might say want to scale it up to be 1.1 as big as it is now. And when you do that, you go, okay, now it's the right size. It fits where it's supposed to go. But wait, I scaled up the letters too, and I didn't want to do that. So it has some sense that some things are scalable and some things are not scalable. And I think that's a big plus for me. That makes a lot of the jobs that I do a lot easier. And then finally, just something fancy, you can run it in your browser without installing it, the Asymptote web application. So I think that's zippy, so I want to show that. Come on, there we go. And there we go. And you of course type in the Asymptote over here, and the outcome, output appears over there. And, it's nice. So you don't have to, if you want to just try it for 20 minutes, you don't have to install it on your computer. Okay. Okay. So I'm imagining that most of the folks, maybe every person watching this video, is saying to themselves, why don't you just use TIXI? And so I want to address that rather than wait till somebody actually asks the question. So TIXI is very widely used. Asymptote has a much smaller user base. I personally have not used TIXI very much, and I haven't used it lately at all. But when I started my latest project, which is a discouragingly long time ago, anyway, when I started my latest project, I wanted to look around and see what to use for the graphics, and I compared the different things that were available at the time. I found that Asymptote had some relevant technical advantages, including native 3D graphics, and I also found TIXI harder to program. Now that may have changed, and people could say, well, you don't realize that. Maybe. Obviously, your mileage may vary. Another difference between the two, relevant for this conversation, is that the basic paradigm in TIG is that your figures are in your document, generated when the document is generated. In Asymptote, the basic paradigm is that they're generated outside your document. Now, I understand you can absolutely generate standalone graphics in TIG, and absolutely you can include asymptote code in a document, but the basic paradigm is what I said. And we all have experience sometimes if you go against the basic paradigm, it isn't that everything breaks, but it's just that things get to be a little harder, gets to be a lonelier place. So I like it when you have some idea what the system kind of is tuned for. One of the things that for me, I didn't want to use TIG was that in the past I had a bad experience with a book from a long time ago using PS tricks, and then the LaTeX world switched to PDF LaTeX, so it was a long time ago. But it made an impression on me. It left me with a strong preference for a dependence chain that is shorter and broader over one that's taller and thinner. If you have a lot of prerequisites for your document, all these things need to work for your document to come out. I don't know, that makes me nervous, in part because of that past experience. So I wanted to generate the figures independently from the document. Again, your mileage may vary, and if I was generating a 5-page document for calculus class lecture, that's all fine. But anyway, that was my part of my reason. Okay, finally, time to get to the main point. So in MetaPost, I wrote a book many years ago where most of the graphics are in MetaPost for a person who cannot draw, being able to, for instance, tell the computer that you want to put this equidistant from those 2 points instead of dragging it and going, that looks halfway, is a big help. The basic structure in MetaPost is that one file holds many figures. This will output a graphic into a file numbered 1 and another graphic into a file numbered 2, the gray material. So begin fig 1, begin fig 2, figure drawing, commands go in the middle. If you're drawing, for example, figures for your calculus lecture, then you might put at the top of the file something like declare vector thickness equals 0.8 points and use that in lots of the figures. So putting all the sources in the same file is convenient because you could change that parameter and make it do what you need, if you want to make some small change. But having worked with MetaPost, I was aware of some warts. So when I started my latest project, I wasn't sure I wanted to use it. For me, the 2 biggest warts are the lack of any real 3D ability, and that programming in MetaPost can be quirky. I'm sorry, suffix variables? I don't know. Anyway, so when I saw the new Asymptote system, I saw a presentation by John Bowman, one of the Asymptote authors, at the San Francisco tech meeting, and I was just blown away. I was eager to try it, and it has been very good. I'll describe the 2 adjustments that may help a person coming from MetaPost that took me some time to dope out and to fine-tune to make them work the best way I could get them to work. The first one, the main one, adjustment 1, multiple figures per file. The basic paradigm in Asymptote is to have 1 figure per input file, and so here's a skeleton of how to put multiple figures in a file. This will output the file test000.pdf containing a graphic with a diagonal red line, and so just to go through the code, I declare string output underscore fn to be test %03d, and then there's the semicolon that ends the line, so in case the letters are a little small for folks to see. Down here I declare a pic, I declare pic num to be 0, an integer, and the unit size for pic is 1 centimeter. That means that if you make a tick at 1, then it's a centimeter from the tick at 0. And then I draw in that picture a line that goes from 0, 0 to 1, 1, and I'm going to draw it in red. Okay. And then finally, I'll ship out that figure. I've got to take a pic num, which is 0, and put it into the output fn using the format command, and then I'm going to put out the figure. That'll be the name of the figure. Put out the figure, and I'm going to put it in the format PDF. Okay, so I imagine that everybody can guess a lot of what's going on here, at least a lot of what's going on here, maybe everything that's going on here, but I want to make a couple points. The first is that output fn gives all the file names the same structure. So if you have lots of graphics, and my current book has more than 2,000 graphics, then it's easier to work with them. Of course, the string test %03D causes the picture number to be formatted as a 3 decimal place integer. I find that 2 decimal places in the file name is a little bit tight. You could run out. So 3 decimal places, I don't see myself running out. Okay, so that's the first tip. The second tip, I'm gonna scoot back here for a second, I hope that's not annoying. I write pic num equals 0, and when I go to make the next picture, I write pic num equals 1, and when I go to make the next picture, I write pic num equals 2. I write pic num equals 0, pic num equals 1, etc., rather than pic num equals pic num plus 1, because it took me a while to figure this out. When you go back into a file that has 80 pictures, and you're trying to fix a bug in picture number 53, oh man, you really want it to say pic num equals 53. You don't want to be counting with your fingers, you know, 1, 2, 3, 4. No, that's bad. And finally, the last point, because I'm outputting multiple pictures from a single source file, I have to put in this pic command. I have to say where, for example, I'm drawing this particular line, I'm drawing it to the picture called PIC. So that picture will appear with a diagonal line that's in red, and if you leave out the PIC, then it will draw the diagonal line in red to some picture, but not to the picture that you output. That is to say, because it drew it somewhere, there's not an error message, but you go to look at the figure that you think you're drawing, and it doesn't have the diagonal red line in it, and I forgot the pic. So that's you got to put the pic in all of those commands. Okay, so again, the format there is not all that hard, but I basically copy that over and over again for all the pictures that I draw. I want to talk about a second adjustment that is related to the first. With the prior adjustment, the goal was if you have a lot of figures all in the same file, you have picture 1, picture 2, picture 3, picture 4, then you can, for example, have parameters at the top of the file, or maybe you define a function to do a certain thing, and it's convenient to have it all in one file. Even just sometimes you say, oh wait, I want to make this look like figure 53, except so you go up and copy figure 53 down. So it's uniformity that I'm after. You can have some parameters, such as font size, for example, and describe them all just in the one file. But likewise for uniformity, you also want to have a consistency across a set of files. So in my book, for example, I have 5 chapters, and I have an asymptote file for each of the 5 chapters. I have to have a number of asymptotes files for each of the 5 chapters. And I want them all to use the same colors for, let's say, the finite state machines. Okay, so I want to somehow have something like a single file style.asy that gets input into every asymptote source file. Mine's actually called j8.asy because I just named it that way in the first place and wasn't thinking straight, and now I'm pretty locked into it. So here, for example, is part of my style file for the most recent book, just as an example of the kind of stuff that you want in there. So I want, for example, to set the font size that's used to draw all the figures. It's a little bit smaller than regular font size. This is small, LaTeX small. That's why it has all those silly decimal places. And then I want to set the colors. I happen to set the colors using, when I make the pictures, I use highlight color, background color, bold color, light color, very light color kind of stuff. And then I can change those without having to change the name of the colors by setting them, there's a certain amount of abstraction there. But so I'm setting the colors that are used in all the graphics in the whole book. So in principle, I could adjust those. I've never done it, but in principle, I could adjust those. Okay, so I have this one file that works across all of my asymptote input files. So where to put it? So there's 2 cases, simple case and not so simple case. You can bring in a file with import file name, just exactly what you'd think it would do. If that file's in the list of directories searched by the asymptote system, then you're good, you're home free. And again, this is going to work for 99% of the cases. So if you're a beginner, this is what you want to do. For instance, asymptote has a standard file called settings that you often want to bring in. Here we go, import settings. And maybe you want the output format to be PDF. So this will make the output format be PDF for all of the graphics in that file. The place where asymptote searches is just what you think it would be if you're an experienced person. It looks first in the current directory, then it looks in the environment variable asymptote_dir, and then it looks in the directory given by asymptote_home, etc. It's just what you think it would be. So again, if you're a beginner, if you're looking to set up the system, this is just exactly what you're looking to do. However, I have a more complicated case. I provide the files for my book in a Git repository because they're freely available, and I've had bad experience in trying to depend on people knowing how to get it working. So, for example, people seem not to be able to set an environment variable. At least the kind of people who are downloading my book often seem to struggle with things like setting an environment variable, or maybe they're just not reading the instructions, I don't know. When those folks are unable to get it to go, they sometimes write me, and that certainly means time, but it sometimes means a certain amount of aggravation. They sometimes write you an angry email, says, you know, it doesn't work, you know. So if there's a way to import files that doesn't require that, I'd be delighted. So I just wanted to comment that I have a way that does that. I'm more able to depend on people naming the download directory. That is to say, people who download the files always seem to use a limited number of names. Computing, because that's the name that I used for the book. It's on Theory of Computing. At the GitLab, I keep it on GitLab. The GitLab project directory is TOC, so people who clone the material often clone it to TOC. And if they download the zip, then that's called TOC-master, so they often find you often find that the top level directory is TOC master. And this covers like 99% of the cases, maybe 100% of cases, I don't know, but covers almost all the cases. And so I can depend, I think, on people having a directory of one of those three names. So you can see where this is going. I wrote a routine to look through the path of the current file for one of those three strings and then do the searching for my style file based on that. So it's not a very sophisticated file, it's kind of crude, but it will give a person some sense of what one of the things I've been trying to say the whole time, which is that it is a regular programming language, at least regular enough for my purposes. So you get the current directory by issuing the command cd with an empty string. That's just how you do it. And then I do an rfind for computing or TOC or TOC master. And I figure one of those three cases has got it covered. Those turn out to be eight things I have to worry about. And then I write very ugly code to write those 8 things. But it's all the kind of code that I'm used to writing on a daily basis. So I find it relatively easy to work with. Okay, great. So that's all I had to say. Azotope does a great job with drawing technical graphics. It deserves to be better known than it is. I urge people to give it a try. And to me, one of the things that's appealing about it was that adding some meta post-like workflow makes it work even better. Okay, very good, very good.
Okay, thank you very much to Jim. Okay, thank you very much to Jim. Thanks for this impressive talk. Are there any questions?
Yeah.
I understand the idea of having figures outside of your main tag file. It's a great idea and so on, but there is a case for having them inside tag file. If I have a lot of settings like fonts, sizes, and so on in my documents, I want my labels to be with this exactly same preamble. And I can use asymptote, use tag preamble or whatever, but when I change it, it will go out. So is there a way for asymptote files to always have the same preamble as my main tag file? Thanks.
So thanks for the question. The answer is yes. I simply read in a file, which I find in that directory that I illustrated at the end. I simply read in a file that is also read in by the book, that contains fonts, the font sizes, a variety of parameters used in the book. So the same file is shared between the book and the asymptote, but of course I have to find that file, and that was the reason for the shenanigans at the end.
Okay. Any other questions? I don't see anybody. So, thank you, Jim, very much again. Thank you for introducing us to your living room, and enjoy the rest of your day. Okay, goodbye and thank you. Okay. So, the next speaker is Linus Romer. I think he's some kind of a freelance font designer, and but today he will talk about MetaPost using for creating curve comps and harmonized paths. I hope this one works.
Welcome to my talk on curvature comps and harmonized paths in MetaPost. I'm actually a math teacher in Switzerland, not a freelance type designer. Curvature comps and harmonization are two tools that are quite popular in font design software now. You see here a screenshot of FontLab 6. Curvature comps are used to visualize curvature along paths and curves, and harmonization is a way to make paths curvature continuous. And I will present implementation of both in MetaPost, which is a good method to make a reference implementation, because MetaPost has many tools to handle with Bezier curves. Here's how I got into it. I have designed several software implementations in FontForge. I did a harmonize tool and also balance tool. I've written some conversion tools for Metafont to outline fonts, and I also have designed some fonts in Metafont as well as in FontForge. It is crucial to know what curvature means. Curvature is the inverse of the radius of an oscillating circle. So let's say you have this curve given, and we want to determine the curvature at the very left end. Then we construct the oscillating circle, which means that the direction and the change of direction is the same as in the touching point of the curve. Here, let's say the radius is 2.6, so the curvature will be 1 over 2.6, which is 0.38 or something like this. And as we wander along this curve, you might notice that the oscillating circle becomes bigger and bigger. So the curvature becomes less and less. At the end, it's just the other way around. So here, it's the greatest curvature and the smallest radius of the oscillating circle. If we assemble all these red vectors, these curvature vectors, to one picture, we get this picture, which is called a curvature comp. We can even make it more dense, like this. And we can also fill the gaps with color and also change the color depending on the length of the vectors, which would look like this. So I will call this a curvature comp for the rest of this talk. And for the definition of a MetaPost macro, first of all, I need a cross-product macro, because MetaPost supports a dot product macro, but not a cross-product macro. So this is just a missing part. It returns the signed area of the parallelogram that is spanned by two vectors. And the macro for the initial curvature of a curve must look something like this. It begins with var_def curve of an expression p, where p is the path, and then it should return this red curvature vector. And I once thought that it would be a good idea to make curvature at the time t of a path, so that I could calculate the curvature at any time, at any travel time. So let's say in the mid of the curve. But of course, this would be a very bad idea for integer t's, because then it's not clear to take the curvature of the left or of the right part. So here is the math behind. I think many of you are quite mathematical affines. So MetaPost deals with cubic Bezier curves, which are defined like this by 4 points p, q, r, and s, and the travel time that starts with 0 and ends with 1. And if we take the derivative and look at the time t equals 0, we get the derivative 3 times q minus p, which is substituted as v, and the same procedure for the double derivative, which here is called w. If we take a common way to calculate the curvature, which depends on the cross product, so I have already defined it, the cross product of the first and the second derivative divided by the length of the first derivative to the power of 3, and I substitute the things that I have defined before, so here the definitions of v and w, and also introduce a new variable L for the length of the first derivative. I will end up with this formula to the lower right, and what some people call harmonized. So I just took over this term and also call it harmonized. And I've written a macro that works like here. You write harmonize in front of a path, and then it harmonizes it. And often people say, hey, why should I use it, harmonize? I mean, it looks already good, and probably it does, but it never harms to consider it. So to the left is a bowl of a J, and the not harmonized version is not continuous in curvature, and the right version is harmonized. At the first glance, they look very similar. So here's the magnified version, and also the definition, just in case you want to test it yourself. So this is the original, and this is the harmonized. And I have also inked versions of it. This is the original, this is the harmonized. And if I switch back and forth, you see it hardly changes. And here's also the logical difference of this both area. So you see in some parts it differs quite much, in other parts it doesn't differ. Of course, one could say, okay, if these changes are so subtle, why should I change it? I mean, I cannot tell you you have to do it, but maybe you think, oh, well, it could be a good idea. Here's another example of a calligraphic dot, so a dot that is not exactly circular. And to the left, there's the original version, how it was defined in MetaPost. And to the right, it is harmonized, so the curvature is continuous. And you can see that harmonized paths tend to be more rounded. And one could also say they lose a bit of their character. So maybe here it's not a good idea. So it's up to you to say what dot you like more. Again, here is the inked version of the original. Here is the inked version of the harmonized version, and I go back and forth. So here you can see the difference is quite bigger. I will shortly present the method of harmonization because harmonization was a tool that just appeared in closed software, and I couldn't find a proof of how it works, and so I will present to you shortly. The generic case is that you have two segments that join in the point G and 0. And we assume that they have the same direction in their joint and that there are no zero handles, so that there are no collocations of control points, and there's no inflection point in their joint. So we can assume that it looks like this, and the goal is that we move the joining knot in the right place such that the curvature becomes continuous. And for this, we have to calculate the curvature to the left and the curvature to the right. So again, I won't go into detail, but taking the formula from before, we get that the curvature to the left only depends on the height of the point R here and on the x coordinate of the point P here. And the same for the right part. Again, it's just filling in the formula. And if we want to have both curvatures equal, this comes to this equation with the solution for G is either I divided by 2, so it must be in the mid if D and L are equal. And in the other case, it's this special formula, D plus minus square root of DL over D minus L times I. And the nice thing is that the square root of D times L is the geometric mean, so this makes sure that the solution is always in between these control points, so you don't get strange things out of it. Another nice property is that the curvature at the other ends, not the joining ends, but the other ends will not change. So it's very easy to make a global solution, so a global continuous, curvature continuous solution. So if I change back and forth, you might notice that at the very left and the very right end, the curvature was not changed. So how does a global solution work? Like here in the dot, I have also displayed in black the control points and the handles. So this was not the not harmonized version, the original version. And here is the harmonized version. And you see only the joining knots have moved along their tangents. There are some special cases that have to be considered. One special case is if either D or L is 0, so if one handle lands on the tangent line, then the new G becomes 0, so you have the problem of collocation. In type design, this is normally not desirable, and because you will infinitely large curvature. So this should be avoided. And there's another special case where you have a point of inflection as the joint. So then the curvatures must have different signs because this is the definition of a point of inflection. But different sign and equal means that they must be 0. If you want to have them to be curvature continuous. And so we must have these handles to land on the tangent like this. We could also move the other handles additionally and still get a curvature continuous solution and make it area preserving, for example. But there are some problems that come with it. One problem is the rounding problem. So you always have a rounding on a grid, so like a smallest number. And so here you have an original path. So this is a curvature continuous solution. And this would be perfect, but now after rounding, of course, it won't be perfect. And here in this case, it adds an additional inflection point. So it's probably not desirable, and it works different than the solution that I presented before, because the off-curve points are changed and not the on-curve points. If we have inflections, it's better just to make the absolute value of the curvature continuous. So this is just the mirrored solution of before. So this is the easy case, and this is also the way how FontLab handles this problem. So here I define harmonization is the act of setting a new G depending on these coordinates, as I said before. And here is the macro for MetaPost. I iterate through the joining nodes of a path, then I check if the joint is smooth at all, so I only apply the change if it's smooth, then calculate the new position as described before with this formula. I also have to check if the path is cyclic, then the last point equals the first new point, and at the end I return a path that is made of these new joining nodes and the old control points. So this looks like this. Again, if you want to study it in detail, just look at the preprint. And I found out later, after I have developed this formula, that in 1990, Robert L. Roach and John R. Forrest already published an algorithm at the NASA Langley Research Center to make exactly this thing that I wanted to, so to harmonize it, but of course they didn't use this term at that time. And it's equivalent, the algorithm is equivalent, but it works slightly different because it depends on an intersection point D, and this intersection point does not always exist. For example, in this case, you would have the intersection point D in infinity, so this would not work with Robert L. Roach's solution, but it works with the solution that I have presented here. And there are some plugins that use the Roach algorithm. For example, for glyphs, there are two plugins, the SuperTool plugin and the Green Harmony plugin. Both use the Roach algorithm. The SuperTool has it slightly modified. In 2010, the font remix tools have introduced a harmonizer, and they defined this term, but it's closed source, so I cannot say how it works. But I can say that it probably works different in some cases, at least from what I have seen. And in 2017, FontLab 6, and now also FontLab 7 and 8, have a harmonized tool, and it's again closed source, so I cannot say if it's equivalent, but it seems like it works just the way as my algorithm that I've defined here. I have also written a plugin for FontForge, and finally in 2020, I have directly patched it into FontForge. So FontForge now also has a harmonizer. If you use current version of FontForge, you may use it yourself if you're into font design. And still, of course, it has some disadvantages. One disadvantage is that the harmonized path do not longer interpolate the points they were originally meant to. So here, the original point Z1 is not passed anymore. So I once came up with the unfortunate idea that I could make it super smooth, so I would not move the joining knots, but the control points that are off curve. And then I could satisfy even more properties, like not only the curvature will be continuous, but also the change of curvature will be continuous. And I called it super smooth. And it was not a super smooth idea because it has some problems. It could introduce new inflection points, and it was very hard to globalize. So by changing the points for 2 segments, everything changed globally, and the whole situation had to be calculated new. These are the references, and I'm open to questions.
Okay, thank you very much. Are there any questions? Okay, there is one.
Does your technique conserve the total curvature over the entire curve? So is the integral conserved?
No.
Because I think that may be a solution to your problem of the harmonized glyphs losing character if you conserve the total curvature.
There are several properties that could be taken care of. So the total energy, the total curvature, the total change of curvature, the preserving of the area, and actually I didn't think of the total curvature. Maybe I have to consider it, but it's indeed the case that I do not have a satisfying solution for this. So if anybody of you has a good idea, like you, how this could be reached by setting the offset points to get a global curvature continuous solution, I would be very glad to hear your ideas.
Okay, we still have time for questions, if there are any. Yeah.
So thank you for the talk, and I was wondering why you chose to place a new joint point on the tangent line and not on the curve, the G nu.
So you mean it would have been better to wander along the curve and take one of these? Well, the first question would be, on which side would you wander? So would you go, in this case, would you go up, would you go down? So this would be a first problem, that it would not behave symmetrically, I guess. But of course it would be possible to take a point that is near and redefine the other segments. But yeah, it's not symmetrical. This is very unsatisfying, I think.
Okay, if there aren't any more questions, I don't see anyone. So thank you again for your talk. So we stay with the theme of
1 minute until they are here. Go down. I just make an announcement because of the banquet. I got questions. We are kitting at 6:45 in the lobby, sharp. My husband has tickets for the train, so we go together to the train. And if you want to have more details, the program has on the second page a description of what is going on the banquet and also on the excursion. Yes? If there are questions still open, come at the coffee break to me.
Okay, thank you for this short announcement. So the next speaker we have comes back to the topic of MetaPost and MetaFont for creating fonts. It's Rajesh KV from India, and he will present a complex typeface and as you can imagine, it's not a Latin one, but an index script. Okay, thank you.
Right. I'm here presenting about a complex script typeface that we developed recently in collaboration with two of my co-authors. So I'm presenting this on behalf of them. And in the spirit of better? Okay. So in the spirit of Ben Davis, I reserve the right to redirect questions to more appropriate persons. And we collaborate on an open source organization which develops typefaces, fonts for our language and script called Malayalam. It's spoken only by 35 million people, I suppose, but the useful number of fonts typically maybe a dozen fonts. That's one of the reasons that we develop and open source it. Let me figure out. Is it the left one or
I
this
think
one?
it's to the left, yeah.
Yeah. I did press it. This one. Okay. Thanks. Right. I'll give a brief overview about the script, Malayalam script itself, used to write both Malayalam as well as Sanskrit text, which has a lot of interesting properties. First thing is that it evolved through Brahmi and then the Grantha script, which is prevalent in the South Asia. A lot of scripts follow or evolved from Grantha script. And almost 120 characters are already encoded in Unicode, which are the base character set, so to speak. But that's not the entire character set in the script, because we have the ligating properties. Consonants may join together, and the vowel signs again join with the base character, whether it's a single character or multiple characters. These do not need to be encoded separately in the Unicode, because they form from a sequence of already encoded basic characters. That also means that when certain characters are together, they form a completely different shape, which means we need support of complex text shaping from the software, like Harfbus in Linux operating system and even browsers, or DirectWrite in Windows, or Cortext in Mac. Right. I'll show you some examples of the complications. So the first one is the syllable crew. I've also written the Latin or Romanization on the left side, so you can have an appreciation of it. You can see that ka, ra and the u vowel symbol join together into a single glyph in the font. Now this follows something called the traditional orthography, which was written in the past and evolved over centuries. But in 1971, there was an effort to minimize the number of characters in the script, and it's called the reformed script. Now almost all the commercial fonts follow this simplified character set, but we want to follow the traditional character set, preserving the entire character set used in the past, so that we can represent those documents faithfully. In addition to that, these are much more aesthetic, and we prefer that. Now the vowel signs are part of another complex story, because even a single vowel, the u vowel, has 4 different forms depending on the character it conjoins to. I'll show you some examples. First one is ku itself. That takes a small shape at the right end. And another one is chu, where the vowel symbol goes beneath the base character. And the next one is thu, which forms like a sitting a chair. And another one is nu. The aspirated version of it, the u vowel symbol, again has 4 different shapes like this one. Right. Naturally, this requires complex text shaping support, which is thanks to HarfBus. It's now in CTEC, LuaTech, in browsers, graphical toolkits like GTK or Qt, and even in browsers like Chrome and Edge. Right. So now, in the past, we have released a number of fonts which were all designed either using FontForge or FontLab and graphical design softwares such as those. So why did we want to go to Metafont and Metapose? A couple of reasons. First one is, of course, we wanted to learn Metafont. The second is only a few of us are really designers. Most of us have some programming background alone, and in that sense, Metafont is a natural fit. So we decided to go ahead with Metafont, and the first challenge was to learn Metafont. So we referred the Metafont book and started learning it. And it also, later on we realized that it brings a number of advantages. First thing is that we could reuse the components of a shape itself because they are code fragments. The second thing is that because Metafont enables us parametric font design, we can have an entire family of the typeface from a single source, such as the thin, regular, bold, semi-bold, even slanted versions from a single source. And very fine adjustments to the glyph shapes and curvatures are much easier because it's just some values that you can adjust rather than trying to adjust in the graphical software tools. Plus, the source is plain text, which means that we can have distributed and collaborated development, and we use Git for the version tracking. And we also found Metapost as a superset of Metafont that gives us a lot more additional functionality, plus ability to produce vector graphics, because ultimately we wanted to produce open type fonts or outline font formats. So Metapost gives us that for free, and we generate SVG for each glyph. Right. So the first thing, or the first part of the research was to identify different components of the glyphs that frequently occur, so that we could design them first and then use those to assemble into a specific character or a glyph. This uses the reference font called Rachana, which has been developed in the late 90s, and K.H. Hussain, who was the original author, also did this research work in identifying different components of a glyph. So an example, I'll show you 2 or 3 examples. An example here is the character, the right part of the character, which repeats in a number of glyphs. Another example is R, that repeats, the right side repeats in a number of what is called as chiller characters in Malayalam. These are like pure consonants without the inherent vowel sign. And another example is the left side of the consonant ta that is repeated in a number of glyphs. Now this is not an exhaustive list, of course. And an astute reader could immediately see that the Chilu letter Il, that is the second character on the second row, is a combination of the third component and the second component. And nearly 100 more components were identified, but I don't think we had to use that much because many of those components occurred in 1 or 2 characters, so we just define them along with the character. So we didn't, they were not reusable, so we didn't develop them that much. Now I'm going to show you how we use it, and apologies for the very small labels. I realized the mistake, of course, only after submitting the slides, which was noticed by both Barbara and Carlberry. So we're going to create a letter called Na, which I have shown you earlier, which has 2 components, the left component and the right component. These components are developed as macros and put into a single file called the ml-shape-lib, and we import that in when you want to define a new character. And each character is defined into a separate file so that we could generate individual SVGs for the characters. So you input the library and you of course say the begin fig and an identifier, and the characters or the shapes are defined using the coordinates that you have to specify, and then we use pen stroke. Before using pen stroke, you have to specify the width and angle of the pen, which is again defined in the macro p stroke, which defines sets the stroke width and the angle of the pen, and then does the pen stroke connecting the coordinates which were defined earlier. So you will get a component like this, and you define the next coordinates and the p stroke corresponding to it, but you want to shift this character after, or this component after the first component. So there are multiple approaches how this can be used, because Meta font already has the shifted transformation, but we opted for a simpler XY shift, X shift and Y shift in the macro definition itself, where you can dynamically specify, okay, move it after the coordinate, X coordinate of 1F, which is basically the last point in the left glyph. And then you start it from there and also adjust the width so that the curves are joined smoothly. Now sometimes you define an entire glyph using different components, and we have encountered situations where you want to alter certain parts of the glyphs or move certain coordinates by a certain amount of, let's say certain amount. And here is an example of the character the. You can see the coordinate and the pen stroke defined. And let's say I want to move the point 1B, which is the second point starting from the left, even further left, and I uncomment that commented line dx1b by a -2 units, and it moves the specific coordinate to the left, and the curve or the shape is altered. Now this is taken care in the coordinate g, the macro itself. So if there is a dx defined for that particular point, then it takes into consideration, and when we do the pen stroke, it's already taken care. Now another example is sometimes you want to change the angle or width at specific points of an already defined shape. So in this case, I would like to increase the width of 1D, which is the right point, second point from the top, and 1H. So I can simply say width of 1D equal to width of 1H equal to width east plus 1T. So that's an already defined variable plus a T, a minor epsilon unit. I can also change the angle only by setting angle 1A equal to the angle on southwest, which is the first point. So these minor adjustments, even after the components are defined, when we actually define the glyph, the character is possible. Now another example I want to show is stacked conjuncts. These are double conjuncts. It's pronounced as uppa, as in kappa. So the same glyph of pa repeats itself, and that's fairly easy to do in Metaverse, because you take the glyph definition GLPA and put it in an image, save it. Then you have G2, again GLPA, but this time with a different prefix, because they both use the same coordinates and we want to distinguish between them. And then scale it down by say 60%. And set the current picture to the first path, add the second picture to it, shifting it further down and align it to the right side, which is obtained using the x part of the left lower right corner of the top glyph and with the upper right corner of the lower glyph. There are a couple of booleans that I didn't explain, which I will come to, especially the V conjunct. The reason is, if you compare these glyphs on the left and right, they are nearly the same, but the pa on the below, its stroke width is also proportionally reduced, which is not desirable. We would like the stroke width to remain similar with as the top one, and the only way we were able to achieve that is to magnify it a bit further by setting this boolean. So that in the glyph definition, if we say that okay, this boolean is set, we multiply it by a certain scale factor. Okay. Now another interesting part is when we have to join a curve with a straight line or a square. And if we just try to adjust those 2 points together, either the stem protrudes to the left or the curve protrudes and the curvature is not seamless there. What we could do is that we define a macro which uses simply the field draw, dynamically calculating the lower left, upper left, lower right and upper right, draws from those lower left to upper left, and then to the upper right, lower right, and then cycles. Sometimes we also want to reuse certain glyphs once they have defined, so that the character here is ta, the first one, and the third one right beneath it is basically pronounced as tr, and you want to attach the r vowel sign to let's say the half of ta. What we could do is that we use the sub path from Metafont, where you say okay, just draw the coordinates are already defined from bottom left to right, but you instruct Metafont okay, but draw it only from this point to until that point, and then you can attach the next component by adjusting the x and y coordinates and also setting the width accordingly. So these are all possible, and the curve is smooth, no disconnect between them with these adjustments. So it's quite flexible, but of course it comes with its own disadvantages as well. Okay. Now I want to go back to the vowel signs one more time, which has these 4 different formats, but we wanted to use a single macro definition, if at all possible, a uniform macro definition, and reuse this, and we have succeeded to a certain extent. For example, this syllable pronounced as pu, pa, with the u vowel sign attached beneath it. One of the challenges was that the below curve incises into the horizontal stem, and we would like to remove that overlapping part. Unfilled doesn't work because the resulting outline or the SVG is not proper, so that we could easily import it in FontForge or other vector graphics tools. We had to use the overlap removal, and thankfully from the Polish tech team, we metatype. There was a macro which returns the path where the overlap is removed, which is called the find outlines. So you take the path of the horizontal stem and the path of the circular vowel sign, and then you pass both paths into it, and then use fill draw finally to draw it, so that there is no overlap. All right. Now once we have the characters designed or defined using Metafont, compile each one using Makefile, of course, into a target directory. So all the SVG files are there with the specific glyph name that we want in the character set. We don't use the Unicode character font names or the Adobe glyph list names for different reasons. First one is that once the glyphs are drawn, which is not sufficient, unlike Latin characters, you need the complex text shaping support, which has to be enabled or built into the font using OpenType rules. And we use Adobe feature file to write this comprehensive script because we have nearly 1,000 characters, 900 plus for sure, and in Malayalam script itself, plus Latin characters and numbers would be nearly or more than 1,000 characters. So we use, we made use of FontForge to produce the final OpenType fonts, whether OTF, TTF, or the web fonts, WOF2 format in the past, and we wanted to use the same, but of course has to adapt it. And fortunately, Khalid Hosni has already developed an OpenType version of Punk font by Tonnuth called Punk Nova, and there was a build script that Khalid has developed, and I see that Linus Romer also has developed the MF2 outline, and I was evaluating it when he mentioned. But we went ahead with Khalid's script, but we had to add a lot more functionality. And we also wanted to make this configurable, so the font metadata and certain features like the adjusting the left bearing of characters or the right bearing had to be configurable. I was brainstorming with Linus earlier, and he mentioned that maybe a comment in the generated SVG file might benefit, which is a possible option. But what we have opted currently is to have a simpler INI format configuration file where you specify the metadata, such as the font family name, the version, copyright, information license, and the default ascent and descent values, which are important because when FontForge imports the glyphs or the SVG files into the glyph slot, you have to have a defined typically 1,000 pixels by 1,000 view box. And on the lower left, you could see other, you could specify other definitions, parameters such as where to find the SVG characters, the directory to pick these SVG files, and the Adobe feature file. And since we are not using the Unicode glyph names, we also need a way to specify the Unicode code point for this basic character set, which is again defined in a text file, a map file. It's simply the glyph name equal to the Unicode code point format. There is also an option to scale the glyphs automatically when FontForge imports it. Sometimes it's needed, sometimes it's not, because if the view box of all the characters are 1,000 by 1,000, you don't need to scale it, but otherwise you may need it. That can be set to true or false. And some characters which you don't design, such as space, need to be present in the font, otherwise you get a long string of characters in a sentence. So you need a way to specify the width of that character, which could be specified under the width. And as I mentioned, very often we have characters that needs to move closer to the right side of the preceding character. Kerning wouldn't work because by default this has to apply to all the preceding characters. So we want to set by default the left bearing itself, which can be set. Negative left bearing can be set for the specific glyph names. So on the left side you have the glyph name equal to then a pair of the left and the right bearing. Okay, I think I have covered the important topics. Now this is just a tip of the iceberg. As mentioned, we have 900 plus characters and a lot more challenges. A lot more detail is available in the preprint, so if anybody have any feedback or suggestions for improvement, I'm all ears. Okay, the entire code is open source and it's available in GitLab, including the Metafont, Metapost sources, Makefiles, shaping rules, Unicode mapping, it's all in there. And of course, we would like to acknowledge, first of all, the Metafont book, which gave a lot of insight into how to use this and quickly build aesthetically pleasing fonts. A lot of input and ideas we got from MetaType 1, and of course, the find outlines macro has been very useful. And in 1991, Jeroen Hellingman already developed a typeface, Malayalam typeface in Metafont, but I think it's a reformed script, not the comprehensive script, and we also referred to his documentation while learning it. And of course, Khaled Hosni for licensing his build script, open licensing, and allowing us to reuse parts of it. If you have any feedback, I would love to hear it, and with that, I'm open to questions.
Okay, thank you very much for your talk. Are there any questions? There is one.
I thought that would be a record.
Are you planning further to develop other index scripts?
We focus on Malayalam typeface primarily, but a lot of this is of course reusable in other Indic typeface. And yes, the immediate plan is to develop a font for Tamil, which is a close relative of Malayalam, but with a much larger speaking community. But it's much simpler because they don't have 900 complex characters. They have only very few limited sets. But yes, we plan, in the immediate future, we plan to develop a Tamil typeface also.
You mentioned that you looked into MetaType 1 to some degree. Have you considered using MetaType 1 directly instead of going through SVG files?
I wasn't sure that it outputs SVG files directly, so that's one of the reasons. I wasn't sure that MetaType 1 directly outputs SVG.
It doesn't.
Does it?
No, but you can basically directly generate the font outlines of it.
Okay, so I wasn't aware of that.
Okay, any more questions? If this is not the case. So thank you very much again for your talk.
Thank you.
So you guys do a great job. We are 5 minutes ahead of time, so that's everyone is waiting for coffee. So the final speaker before the coffee break is Victor Sagnier. We keep with fonts, but we go back to Latin fonts, and in this case, literally Latin fonts, because we go back in time to ancient times where fonts were quetched into walls, and so he will give a talk about this topic. Thank you.
So thank you for the introduction. I am very pleased to be here to give this talk to you, and that's why I first want to acknowledge the French Gutenberg Association for funding my participation here. It is a French-speaking user group for TER and TER-related tools, so they teach and promote the usage of TER in French and French-speaking countries in general. Yeah, I can try. Oh, that's fine. Okay. Okay, is it better? Okay, great. So I was just saying that the French-speaking user group funded my trip here, and I acknowledge them. If you want to know more about the user group, please take a look at the website. Okay, so first of all, what are rustic capitals? They are a script of the Latin alphabet that was used in the first centuries of our era, and the earliest examples we have date from the 1st century. So for example, in election posters in Pompeii or in inscription on walls. During the 4th and 5th century, the script got regularized, and we will use a manuscript from this time period as a reference for the rest of the book. And it faded away with time, so that in the 9th and 10th century it was only used for decoration, titles, and so on. Like now they would use sans serif bold typeface, they used rustic capitals. So the source we're going to use is the Vergilius Poeticanus Codex, which has fragments from Virgil's poetic works, and especially the Aeneid. So it might appear that it is quite difficult to read, but the Vatican actually provides high resolution scans, so we can scale up the scans and have everything we need to work with the font. Okay. So next, I will define the scope of the project. So about type revivals, Oloco and Patani published a book last year called Type Revivals, and in chapter 1 they define a spectrum of revivals from perfect recreation, when everything is reproduced, imperfection for imperfection, if there is a hole in the tiles that will reproduce it, and at the other extreme there is recreation, when you take a lot of freedom, you can change the shapes if you want to, add spacing and so on. So on this spectrum, I want to stay about here. That is, I'm going to regularize a bit the manuscript, because I don't want to do 20 times the letter A for all the variants that appear, and I want all the baseline to agree, all the heights to be similar, and so on. So there is a bit of regularization, but I won't do perfect canning and optical compensation and so on, at least for now. So this is quite a middle one here. Okay, so we can start writing some metafont code. The first thing I did was to take measurements of various features of the font, so heights, angles, and so on. It appeared to me that the most natural thing to do, given the measurements, was to divide the vertical space into 12 units, with 11 above the baseline for capitals, height, so you have some letters I9 unit and others I11 units. So letters L and F are a bit higher than the other ones. You also have 1 unit below the baseline for the tail of letter Q, for example. You'll see that in the examples. And finally, there is a crossbar height, where the two lobes of letter B join, where the crossbar of the letter E sits, for example. And so that's not exactly in the middle. That would be 4.5 units, but a little above that. And it's consistent with regular practices in type design, not to be perfectly centered, but a little higher. Okay, so next I design a few letters. I don't need extra macro, there is no repeating part in them. So all I need is a pen. So the pen in Metafont is defined by the thickness of the thickest and the thinnest strokes you can draw. So the thickest stroke is about a little more than 1 unit, and the thinnest one is about 1/3 of a unit. Then there is an angle. Rustic capitals are well known to be drawn with a pen about 30, 40 angles. And I just put 65, which is a complement to 90, because the way Metafont works. And I can pick up the pen and define the rustic pen to be this one. And I'm going to use it for all the remaining characters. You can see maybe that letters are a bit pixelated at the moment. It's because it's actually a 10-point font that's being scaled up, but it will be fixed in the paper, so we'll have higher resolution examples. Okay, so then there are a few macros I used so that everything is modular and everything is homogeneous and consistent. So for example, there is a draw serif macro. It is used in a draw I macro for letters I and L. The latter is used in a draw P macro, and the draw P macro is used in the letter R, for example, because an R is just a P with an extra leg, at least in this typeface. So one of the simplest macro is draw serif. It takes 3 arguments. The first 2 are the 2 ends between which you want to draw the serif, and then its width. So the first equation, it's a constraint to be satisfied. Unlike instant dot, for example, that was presented earlier, I don't assign coordinates to points. I write equations that are to be satisfied, and I write only linear equations, and everything is detailed in the metaphor book. So what it says is that the distance between the 2 points should be width, and the special instruction RT and LFT just take into account the size of the pen nib. So you have to add or remove half of the size of the pen nib in order to be exactly what you specify for the book. The next line says that the 2 y coordinates should be equal. So here we have an example of what I was talking about when I talked about standardization and regularization. I want them to be exactly at the same y coordinate. There is no noise or random adjustment to make. And finally, I can draw just a line between the 2 with a given initial and final angle to have this sort of wave effect. You can see at the top of letter T or at the bottom of letter E, for example. This is used in numerous places. I will give another macro just as an example, which is diagonal stroke 1. You find it the letter A, N, and also in letter M, for example. It is a little more involved because you have little spurs at both extremities of the diagonal stroke. So you have to create new points here, ZIL and ZJR, that are a little bit apart from the main strokes. Given some width and direction, I define in the main parameter file. And then to say that the 2 points should be at whatever distance times some vector with direction A. Whatever is actually a special keyword in Metafont when you don't want to specify a value, but just say a proportional relation, you use whatever. And finally, there is something to notice in the drawing part. You do not just join all the points, otherwise you will have something like a letter S with a very extreme curvature to pass through all points. So with tension instruction, the main stroke is actually a bit straight, a bit more straight. Okay, so then there are a few ligatures, as are kerning, but in Metafont you add kerning via a lig table. So between letter A and T, for example, because at the top of letter A you have nothing, and same at the bottom of letter T. So if you just put the 2 boxes right to each other, you will have too much of a gap. So you say you have -1 unit of horizontal space between them. And same for a few other letters. I'm not completely done with all the possible pairs I want to adjust, but you got a few examples here. Okay, so now what I will do is compare my work with 2 existing typefaces for rustic capitals. The first one is by Wilson, using Metafont also. It was designed in 2000, I think, so it was a long time ago, so long I wasn't even born. And the second one is Landers, not using Metafont as far as I know, but usual vector graphics tool. And so in all examples, the third one will be mine. Okay, so at the top you've got a fragment of the manuscript I was referring to, so locus inque. And in Wilson's typeface, you can see that you have varying boldness across the font. So the top of the letter are usually thinner than the bottom. And I suspect the motivation for doing so is because this is what you obtain when you rotate your pen while drawing, and you increase the rotation while you go down. So you get this kind of effect. I think it is what it was trying to reproduce. And in the second typeface of Landers, we can see that some letters like O, C, S, and letter R and D are a bit higher than normal capital and rustic capitals. This might be because we don't use the same reference, or just maybe had a different goal for this, but I prefer to keep it authentic. And last thing about Landers in this slide is that letters C, S, and O point a bit to the right, while letter U point a bit to the left. So in my opinion, it is a bit sloppy, but maybe it was the intention because it's an unwritten style. So it can excuse a lot of things. Okay. So next example is Lacremasque entities, still from the Aeneid. And here you can see a few differences. First of all, the upper lobe of letter R should be very small, at least in this time period. So I try to reproduce this. It's not ideal in terms of purely typographic criterion because it appears a bit bolder than the other letters, especially at a distance. But I want it to be authentic here. And so that's also the reason why there is no spur. I'm not fully satisfied with letter C yet. It should be a bit more curvy at the top, but I expect to change this in the following weeks. And for the final version that will be uploaded to CTAN, it will be corrected, hopefully. And so that's about it. Yeah, for the middle bar of letter E, I chose it not to use the serif macro because according to the manuscript, it should be almost straight and shorter. So it's just a regular stroke and not a serif with a wave-like behavior. Okay, so last example is Un de Genus Ducis from the same manuscript. And here there are a few things to notice. So first of all, I made so that all letters have the same baseline. Once again, letter G also have a different style in several of our typefaces. That's because there are actually just two variants we can find in original text. So I plan to design a variant as lowercase j because I don't use lowercase letters currently. I only use uppercase one. So I have 26 free characters to experiment with variants. Okay, I try to have letters are a bit cleaner. For example, the J in the typeface by Wilson, I think the line is a bit broken going inside. So I try to be a bit smoother and to add at the crossbar height, so at the same height of, for example, the bar of letter E here that you can see. Okay, so here is a full example of how text can be rendered with this typeface. So that's the beginning of the Aeneid, the epic poem I was talking about. And you can see, I hope, what I was talking about, like the letter R. It appears a bit too bold, in my opinion, so I might include a variant with a slightly bigger lobe. Even if it's not accurate, I think it will provide more satisfactory results, at least for the eye. And also you may notice a few kerning issues, and I will talk a bit about those in the conclusion, but I'm not sure I want to correct them. Okay, so what I plan to do in the near future is to experiment a bit more with a few characters, especially the letter C and U. U was, I can maybe show it back, actually one of the most difficult letters to design, and it is a bit surprising because usually it's letter S, and for this typeface, S was pretty straightforward, just giving the coordinates of a few point equations and doing it, and it was done. But for letter U, since you have an asymmetric shape with a little tail at the bottom, it is very hard, at least to me, to have a satisfactory result. So I think now it looks just fine. Okay, so next I will consider your suggestions, if you have any during the question time or maybe after during the coffee break or whatnot. And the plan is to submit the typeface as a CTAN package for everyone to use. So as it is created using Metafont, you can use with plain, later, and everything you want. And it will be obviously completely free. You can modify it, sell it, do whatever you want. So two other things I'm not sure I will attempt to do. The first one is to design new characters, because the Latin alphabet of antiquity is more limited than ours. We don't have two different letters for U and V or for I and J, and there is no letter W, for example. So those are not yet designed because I have no reference example, but I might get inspiration for letter M, for example, for the W. And maybe also digits. It could be nice. I don't plan to use this font in a context where you have numbers written in the Arabic numerals, but if someone wants to do that, I can provide them. And I am a bit hesitant about the last point. Should I add some optical compensation, some overshoot and undershoot, and more sensible canons, or should I keep the authenticity of unwritten font? I think I've already gotten quite far in the process when you compare to the manuscript. It is a bit more regular with uniform thickness and aligned baseline and top line and so on, even if there is no overshoot. So you can see that, for example, letter N looks like it's a bit lower than letter U and stuff like that. So I'm not sure about this one. And finally, one thing I will remember to you is that this is a meta font, so you can change all parameters if you want to, and just add new fonts for free. So one example I did was changing a few parameters only, just in 4 lines of code. I have a new font. So there is no serif angle. Serifs are actually completely flat, no spurs, the width is 0, and the crossbar height is a little bit higher, thickness is uniform. So I think that's it for line of code change, and you have a new modern looking font. But when you use this kind of parameters, here the canning issues are very visible, like in letter N and K, for example. So if you want to use it in a modern way, maybe kerning should be improved. And so that's it. Thank you for your invitation and for listening to me, and thank you again to the Gutenberg Association for funding my participation here. I hope I can come to the next ones too.
Okay, thank you for your talk, and I also thank Gutenberg to send you here. What's good spent money. And
yeah, the question was, I'm not sure if you're digitizing a handwritten thing and there's some variation with the letters, if you really can settle on a standard form, or if they would have like 2 or 3 variants of each letter, so having something like an N which is more smaller or wider, or a U for the beginning of the line and in the middle of the line. So maybe maybe you can switch back to the slide where you had this drawing. Yeah, that's like the first U at the beginning of the line has a different slant than the ones in the middle, and also the S is not always the same regularities. So I wonder if this calls for having like 2 or 3 variants of each letter in different fonts.
Okay, so there are 2 kinds of variants actually. One is in the shape itself, like for letter J was I was talking about, and for this I plan just to have 2 different input methods. If you want to have variants like purely done to randomness and for no particular reason, just different shape because of the copyist writing a lot of text, then what we can do is introduce ligatures. For example, SU is going to be typed differently than SA, for example, I don't plan to do that because I'm pretty happy with the shapes I got finally, which are kind of a middle ground of all examples I saw. And I also take inspiration from later, more carefully drawn shapes. So as I mentioned in the beginning, in the 9th and 10th century, it was used for decoration. So with different tools and much more time to draw them, and it was a bit more regular. So when I was not sure about a particular shape, I could take a look at.
I've got another thing. There was about 10 years ago, the Historical Museum of Basel undertook the attempt to republish the handwriting of Erasmus from Rotterdam as a form. Maybe you have seen it. It was published in 2016, and the file is no longer publicly available, but I can send it to you. And they had the same questions: how to deal with different running letters in the handwriting, and how the designer solved the problem was, hey, it works. You can use the letters and write new letters with it. So Erasmus 2016 is the name of this form, and I would think it would be fun to have new letters like an @ for an address or paragraph signs or whatever, but maybe under a different name, because there might be people who really like to use the original.
Okay, so two things. First, about this particular font, I'm not aware of, but I've seen other projects, for example, for Da Vinci's handwriting. So, and I think the question is what I've stated at the beginning, with the spectrum of possibilities. So if someone wants to have more variations, a more organic look, then yes, absolutely, it's possible with Metafont, and it's just a choice to be here. I wanted something a bit more regular and a bit modern. And about more characters like @ sign or, I don't know, digits from the 12th century, and before that we used Roman numerals. So for such modern things, I'm not sure it's necessary to have a different name, because you can just ignore them. So, for example, saying I will do a letter U and V's are a bit different in the near future, and you just have to type uppercase V always, all the time, if you don't want to see letter U. And actually, that's what's being done in the Latin-speaking community and Latin writing communities. Even books published today and so on. If they don't want to use letter U, they just use capital V everywhere. So you can do the same in the source code and just ignore everything else. I'm not sure it's necessary to have a different name.
Okay, are there any more questions? If not, thank you very much again for your talk. So, we are good in time, so I can just repeat the announcement by Ulrike. We will gather in the lobby for the banquet. We will leave sharp at 6:45, 18:45. We'll have a short walk to the underground station at Bonn Hauptbahnhof, take the tram to Heusallee, and walk to the hotel, to the Marriott Hotel. So it's everything described in the abstract booklet, but the key figures you need to know: be in good mood, but in time, be ready at 18:45 in the lobby. Yeah. But now is a coffee break, yeah, and we meet back and continue sharp at 4:30, 16:30.
Test. Where's Michael?
Okay, welcome back. So some years ago I visited a stage play called Shakespeare's Complete Work in 90 Minutes. And they did it, and every piece of him in a different style. It was really funny. I now introduce Ulrich Fied. I think most of you will know him. He has the task to give an overview of open type mass fonts. I'm pretty sure there are less open type mass fonts than pieces by Shakespeare, so 40 minutes is enough. Please enjoy his talk.
Okay, hello everyone. Welcome to the talk about mass fonts. Is this too loud? Is this okay? Or is it too much echo? Okay, so my talk is about a survey of open type mass fonts, which means I will looking at what is available, how complete the fonts are in terms of symbols and alphabets, and also how some of the design points, how they look like. I've put in a quick slide for introduction. So I started using TUG in 1990 when I was a student at university. By some coincidence, I got a student job when a professor asked for some help typesetting his lecture manuscripts, so I ended up spending many years typesetting theoretical physics. I produced something like 2,500 book pages in the end. There was also something that the publisher had the idea of running several volumes together, so 2 monster volumes of 1,000+ pages. But the main point was, I got to know a lot of different physics notations, and some of it was difficult to do back then in the 90s. I started with LaTeX 209, switched to LaTeX 2E at some point, but is still limited basically by what fonts you had at that time. Mostly it was like, on the one hand, you were missing some of the symbols or alphabets. On the other hand, there were also some limitations in the font setup, how you could switch them. So I started going to tech conferences, I think since '92, and already in '93 I got involved into discussions about mass fonts. I think that was the Aston University meeting, and some years later I worked on a prototype of 8-bit mass fonts, some font-ins, virtual font setup. Gave a talk at Eurotech 1908, but it was basically this never went anywhere, so it was basically a proof of concept that 8-bit mass fonts weren't so good. And many years later in 2008, when OpenType mass appeared, as it was at the Bachotech meeting, I said, okay, this is the thing to go. So basically OpenType mass has borrowed the concepts of TeX and extended them. So I've been following the development since then, and I will talk about what OpenType mass fonts are available. So basically the font technology, OpenType mass, was actually developed by Microsoft. They specified an extension of the OpenType format, a table which collects all the mass-specific information. It was conceptually an extension of all the stuff you had in TeX, or nearly all of that. I know Barbara had one specific point there. In 2008, there was already the first implementation in XeTech and XeLaTeX. In 2009, LuaTeX followed with Context and LuaLaTeX, and about 2010, both engines and the supporting micro packages and the fonts that were available and the font loaders, whatever, were available in Tech Live. So basically, at that time, it was ready for use. But at that time, you didn't have many fonts. So the first font that was introduced was Cambria Mars, that was developed on behalf of Microsoft, distributed as a system font on Windows with Word, and actually developed by a specialized font bureau, but never mind, it's distributed by Microsoft, and that's where it's associated. In 2008, there was Asana Mars, which was put, I think, by a professor at the Greek university who was using XeTech, put together with a font editor using some stuff you already had. By 2010, there was a first release of the Stix fonts 1.0, which were released as a set of 8-bit fonts, building blocks, which were very quickly reassembled in an OpenType Mars font. So this was named XITS, which is Stix backwards. Then it only, the Stix followed with their own implementation of an OpenType fonts only a few years later. So there was Stix 1.1 in 2013, and another revised version called Stix 2, because they changed some of the assumption in 2016. So by around 2010, when the technology was available, you only had 2 or 3 fonts. And this changed a lot. So there was a development of Latin Modern Mars by the Gust font team, the TechGIA fonts, which is actually 4 different fonts for Thermes, Pagella, Bonum, and Scholar. So essentially Times, Palatino, New Century Schoolbook, and what is Bookman. So all the 3 fonts they had, they also added Déjà Vu later, and also in that time period was the development of Lucida OpenType as a project, coordinated by TUG, with support from Bigelow and Holmes, from the original designer, with a group of volunteers working on the font assembly and testing. So by around 2015 or so, you already had something like 10 OpenType Mars fonts available, and if you 10 fonts and 12 if you count the variants, if the XITS and Stix 1 and Stix 2 as separate or not. But that's not the end of the development, of course. In the meantime, we have a lot more. So there was Libertinos Mars, also by Khaled Hosni, which was developed or derived from the Linux Libertine font. So basically a text font and a sans serif font was already available, and it was complemented by some Mars symbols. There's a Garamond Mars, I think that was some Chinese guy who developed it from EB Garamond. There was, Erewhon Mars. What is Erewhon? Erewhon is nowhere spelled backwards, and this alludes to Utopia. So, this was already a version derived from Adobe Utopia, and then as an Erewhon text font, and then complemented as an Erewhon Mars font, together with some packages, things that was from Gutenberg. They had Fourier Gut or whatever the package was called, and there was another package called Mars Design, which had some symbols to go with charters. So now we have this assembled as OpenType Mars fonts. We have Erewhon Mars, which is essentially Utopia. We have X Charter Mars, which is basically derived from Bitstream Charter. There's a package called KP fonts, where you might think about Kepler, but actually it comes from a developer who calls himself, or some organization which was called the Kepler Project, but it's not the Kepler font. It's This one is a family of fonts. The Roman is derived from URV Palladio, so also derived from a Palatino version, complemented by a sans serif and a monospace font to make it a full family. So that was already available as type 1, and now it's also packaged as OpenType. Then we have a couple of sans serif fonts. There's Neo-Hellenic Mass from a project of the Greek Font Society. There is Phyra-Mass or Phyra-Mass, I don't know how it's usually pronounced, from Phyra Songs. There are two more sans serif fonts. There's a version of Lato-Mass, which is by some student at Oxford, put on GitHub. It is available, you can download and use it, but it doesn't even have a README or a license, so it's not in a state that you can distribute or put on C10 or whatever. And yeah, it's a nice idea, but not really finished and production ready. And there's another project going under development to do a Noto Songs Mass. Well, actually, the Noto fonts is a project by Google to fill basically all the Unicode slots, and they have a whole bunch of Noto fonts, and there's a Noto Songs and a Noto Serif. There was already a Noto Songs Mass, which had all the symbols, but it was lacking the functionality of OpenType parameters. So there is a relatively recent project, I think the last release was in March, that is also on GitHub on the Noto Fonts project, which is to develop an OpenType mass font with a full functionality based on Noto. So there's something like several options on sans serif fonts. Then we have the new computer modern mass, which is also a project by another professor in Greece at a university, or actually they extended basically Latin modern in many ways. On the one hand, they extended the text font, they have some Greek and Coptic and whatever, and on the other hand, they filled all the symbols and not only the mass symbols, but also the technical symbols. So I think this ended up to be the most complete font at the time. Yeah. Then there was some projects by Daniel Philippot from France. He took the concrete mass font. Well, actually, I'm partly responsible for that myself. So originally, Don Knuth developed concrete Roman as a text font to go with the Euler mass font. And at some point during my studies, I said, okay, I can apply the same principle of basically a parameter variation on the computer modern sources to generate a full mass font. Then I have a heavier version of a font that I can use when I want to print it on a poster or on a slide, where normal computer modern would be too thin and would disappear. So that was the origin of this concrete mass font, and some people took it over and extended it, so there's now a version of concrete available. And they revived the Euler mass font. So there was originally a project to revise Euler that was actually a collaboration with Hermann Zapf in around 2010. Then the project was abandoned after Hermann Zapf died. And now they took over, okay, we use what is there, and in terms of adding this missing symbols, so this is also maintained by Daniel Philippot. So, what we have now, so by now we have something like more than 20 choices of mass fonts, more than 30 individual fonts if you count all the variants and if you count all the different weights. There are several fonts which have a bold version. There are some fonts which come with a light or with a regular and a book version. So this covers basically the traditional TeX fonts. You have Latin Modern, New Computer Modern, Concrete, and Euler, which is basically all derived from Metafont designs. There's coverage of the traditional PostScript fonts. You've got the TeXJaya fonts. You've got XITs and Stix, which is basically also based on a version of Times. You've got the KP fonts, which is derived from a Palatino version. The Asana font is also from PX fonts, which is also some kind of Palatino version. And some other free PostScript fonts, Libertinos, Garamond, Utopia, Charter, and Deja Vu. So, and yeah, we've also several choices of sans serif. We have Neo-Hellenic Mass, Fira, Lato, Noto. Well, Lato and Noto are sort of unfinished or unreleased, and also the KP fonts have a sans serif version. We have some fonts that come with multiple weights. I already mentioned that. They have New Computer Modern, which comes with regular and a book version. So the book version is a little bit heavier than the normal version that you know from Computer Modern or Latin Modern, which is basically designed for high quality printing, but not so good at small resolutions. And we have several fonts that come, the KP fonts is a family which also comes with, they even come with 4 versions. They have like light, regular, semi-bold, and bold. Then we have several fonts which have come with a bold version. XITs had one, Stix doesn't have one. Lucida has a demi-bold version. Erewhon and Charter have a bold version. And KP fonts also have bold versions. So, yeah, I've got some slides to quickly go through. So this is basically the same set of formulas with different typefaces. So this is Cambria. This is Stix 2. I skipped over the Stix 1. Oops, that was too quick. Back. Stix 2, that is Lucida. Libertinus. Garamond. Erewhon. Charter. KP Roman, KP Songs, Neo-Hellenic Mass. Well, it's a particular style, you like it or not. Fira Mass. This is what the Lato looks like. And this is the Noto version. Well, actually, it's supposed to be Noto songs, but actually the italic, bold and bold italic slots are actually Noto regular. It's some kind of strange setup how they have it. But I think some people already reported this as a bug or inconsistency. So we'll see what comes out of that. This is New Computer Modern. Well, on the first sight, you probably don't see any difference with Latin Modern or Computer Modern. By the way, this is just a sampling of some formulas typically for theoretical physics. So we have some electrical wave equations, the Schrödinger equation, the Dirac equation from relativistic quantum theory, and the Einstein field equation. So we have the typical style of the theoretical physics. We have bold italic for vectors. We have also bold nabla. And I also put the imaginary I in upright. The physicists say, okay, even the exponential E should be upright. So this is concrete. It comes with a bold version, but it's not that bold, actually. And that's Euler, which only has upright at the moment. Or actually, yeah, by design, it only has upright versions. So, yeah, that was basically the introduction of what fonts are available, so a sampling of the 20 fonts. Now, in the next few slides, I will look into the topic of how complete are these fonts. So I've looked at this separately in terms of how complete are the symbols and how complete are the alphabets. So a full-featured OpenType Unicode mass font would have something around 1270 symbols. This includes only counting the base symbols, so this includes the big delimiters, big operators, over, under accents, white accents, all the regular symbols, not counting the alphabets. So that's a lot of stuff, and this doesn't even include in the count the big sizes or the extension pieces. We only count the base slots. So there's basically one group of fonts which aim more or less for completion. They typically have something at least 1150 glyphs. And there's another group of fonts which has settled on providing a subset of something around 500 to 600 glyphs. And well, you may think, oh, if it's like only 500 symbols and out of 1200, it's way incomplete. On the other hand, if you think that a traditional TUG font had something like 5 or 6 families of fonts with 7 or 8-bit encodings, so like say 5 times 128, and that includes symbols and alphabets and extension pieces. So then 500 symbols is already as good as any TUG font had before. So here's the numbers. So that's a group of more or less complete fonts. I think the most complete one is New Computer Modern, Stix, or Stix 2, XITS is essentially the same coverage. Lato, Asana, Neo-Hellenic Mass, Noto, Cambria, they're all reasonably complete in this term. Lucida is a little bit behind, but way ahead of the second group, so it's like closer to here. Yeah, that is the one group. The other group is the one with 500 to 600 symbols. In this group, the TUG Jaya and Latin modern fonts have actually essentially the same count. So if you wanted to start defining something of a subset encoding, that would be a starting point, like the same number or same subset shared by 5 or 6 fonts. The other ones are only a little bit, but it's they're not exactly the same. There's no real agreement on a subset, but maybe that's something you could build on, say, okay, can we get whatever this and this and this symbol fixed in these fonts to get exactly the same coverage as those? So, yeah. That's for the symbols. Yep. Oh, I skipped too quickly. No. Symbols. That's the other part of the numbers. If you look at the bold fonts, they're a little bit behind in symbol coverage. So there's one group which has 450 to 500. If you think the other group is like 550 to 600, it's a little bit less, but also fairly complete. And then there's the fonts Erewhon and Charter, which have basically taken the principle. The only place where I ever need to have a bold font would be in a context of a heading if I switch everything to bold, and inside of my other text material then I have the font switches by terms of using mass alphabets for markups. So if I want to have a bold for a vector or tensor or whatever, then I use the font switch within the main font, and switching everything out to the bold font is only something I do in a heading context. And then they say, okay, if we only use this in headings, then we only need inline material. We won't do any displays in a heading context. And then they, okay, maybe we can get away with a very small subset of symbols. You could argue that is a little bit too less, and maybe it should cover at least the basic text symbols. So But yeah, that's an interesting thing. So, next one. In terms of mass alphabet, Unicode mass defines a whole bunch of alphabets. So you have the main fonts, regular, upright, italic, bold, bold italic, including Greek and Latin. You've got 4 versions of sans serif, but only 2 of them have Latin and Greek, and the other ones have Latin only. You've got 2 versions of script, regular and bold. You've got 2 versions of Fraktur, regular and bold. You've got a Blackboard bold font, which includes upper, lowercase, and numerals. And there's a typewriter font. I never know why it is there, how it came into Unicode, and that's the thing I care the least, whether a mass font has a typewriter font slot. So if something wanted to typeset computer code, they would be abusing a mass font for the wrong purpose. So yeah, I don't know why it is there, but it is there. And if you look into completeness, you have to look into that again. So yeah, basically font designers can choose what they want to include or not. And again, we have some fonts which are fairly complete, which essentially cover everything there is. So the small variation between 1170 and 1163 is basically in the range of miscellaneous symbols. Then others are a little bit less behind. So I think the most common thing that's missing is either a lowercase script alphabet or a lowercase Blackboard bold alphabet, and sometimes also missing the bold script or bold Frakturs. So it's a little bit hard to keep track of which font includes what and does not include. I tried to cover it in my paper in putting it up in a table, and submitted the preprint already relatively early. In the meantime, I found that I needed to update my paper again, so the version you find online is actually more up-to-date than the version you find in the booklet, because Daniel Philippot updated some fonts and filled some of the gaps. So the other point, next one. There's another group of fonts which is less complete in terms of the alphabets, because some of these fonts are sans serif designs which say, okay, if the base font is already sans serif, I leave all the sans serif slots empty because they would be just the same. And sometimes they also say, if I have a sans serif font, I leave out the typewriter, I don't need that. Or maybe it's something in the terms of concrete and Euler's. I don't know what would be the appropriate choice for sans serif or typewriter to put into this font, so I better leave this out, and then you can substitute something else for that. Euler is a special case because it's an upright design, so it leaves out the italic slots. This has the disadvantage that if you use something like the latest Unicode mass package, generically you would have to set up some kind of font substitutions or configure it to do mass style upright, and there's some discussion going on now whether Euler should actually just fill the italic slots with the upright glyphs just to make sure you don't get a missing glyph there, and then it would be easier to switch and to use. So again, some fonts are missing lowercase script and Blackboard bold, and some of the sans serif fonts also are missing like all the scripts and all the Fraktur, but you can find the details in the table in my paper. I think that's better to see than here. Bold fonts are again special case. In the past there was something like the 2 bold fonts which said we do a minimal design. They even went to the point, okay, I leave out all the bold, when the regular font switches to bold, ideally the bold should switch to extra bold or ultra bold, but if you normally don't have that, then the option is like either you leave out the bold slots, then you have problems with missing glyphs if you have some kind of forget to switch it. Or the other option is I put the same symbol in the regular and the bold slot, then I have filled the slots and it's, you don't get missing symbols. And nowadays, most of the bold fonts have actually gone this way. We just fill it with the same slots, even if it's not bolder than the regular bold. We provide it so it doesn't cause any problems with missing symbols. So again, most of the time when something is missing, it's lowercase script and lowercase blackboard. So that was the term of completeness. The other topic I was going to talk about is design choices. So when you design an open-type mask font or a Unicode mask font, you have to combine a serif font, a sans serif font, a script font, a Fraktur font, a blackboard bold, and even a typewriter. And you have to find what are good matches to use in your setup. So if you have a start with a comprehensive family, that you say, okay, I start with whatever computer modern, you've already a Roman and a sans serif and a typewriter, then or if Lucida or something like KP fonts, you have already a family, then it's more or less obvious, okay, I take the members of the family and assemble them in the font. But in other cases, I just start with a regular font. What should I put in the other thing? What is a good sans serif to go with my serif fonts? So you have to remember it's essentially meant for markup purposes, like if you say in physics, vectors are bold italic and tensors should be bold sans serif italic or something like that. They say, okay, on the one hand, your sans serif font should be clearly distinguishable. If you see one letter, you should be able to say, is it bold italic or bold sans serif italic? On the other hand, they probably shouldn't be too incompatible, so there could be some variation in weights and widths and stroke thickness, but it probably shouldn't be combine a very narrow font with a very wide font, so it should be somehow balanced. So I don't have many details about the sans serif at the moment. I talked about this at another time. I'm not that happy about the setup in the TUG fonts, for example. I think it might be better if the available serif fonts and the available sans serif fonts were matched in a different way. But yeah, it is at the moment, and it's hard to change at this point because the fonts have been established for so many years. So what I will be looking at in the next few slides is choices of script, Fraktur, and blackboard. So in terms of script or calligraphic, there are essentially two different designs. There's one more scripty, the other one is more like this formal script, very ornate thing. In Fraktur, there's basically most fonts have a similar design. There are just a few outliers. And for blackboard, you have basically serif or sans serif versions of the blackboard letters. So this is the sort of the calligraphic version of script. Well, maybe you could even subdivide the upper and the lower half into again, but this is actually in some cases a font provides both. There's like a script and an extra calligraphic available via a stylistic set. This is the one with this SS01, 03 or 4. This means like select stylistic set, SS number, something from the font. So that was the one slide. The other one is this formal script style. These are, actually I think the Lucida Bright that was newly designed when the Lucida OpenType was done. And in my personal opinion, this goes a little bit too much over the top. It's probably too wide to be usable in a mass context like that. It's much wider than everything else. I think in these slides I'm showing the original size, so some fonts have essentially the same design with a different width and spacing. In my paper I actually had to reduce some of the font samples by 95%, 90%, 85%, just to get them not to overflow the column width. Yeah. And the one outlier is Pagella, which has a very unique style. I don't think this is particularly suitable for use in math. Might be a nice script font, but not exactly good choice for the purpose. The Fraktur fonts are actually, most of them look pretty much the same. There's no big variation, a little bit difference in width and weight, and I think a whole bunch of fonts all use Euler Fraktur, Latin Modern, Concrete, Arrow 1, whatever. There's a lot of stuff that just inherits the same Fraktur font. A few outliers there. So the Neo-Hellenic math font has a very particular design. I think Lucida was originally called Lucida Black Letter, and KP fonts also has a very unusual design. So again, yeah, probably not necessarily what people expect in a math book if people are using Fraktur in that context at all. So I once saw a book from Einstein from the 1920s. At that time it was common to denote vectors by Fraktur letters, where you now would say it should be in a physics thing, bold italic, but yeah, usage has changed. That is the blackboard bold letters, so these all use the sans serif design. Actually, some are incomplete, where I don't show the lowercase or the numbers. Those are the ones that are incomplete. And that's the corresponding thing for which use a serif style. Interesting thing to note, for example, if you look, if I go back, Latin Modern has used a sans serif style, and New Computer Modern has gone back to a serif style. So when someone creates a fork or a new version of the project, they can choose to do things differently. I think Concrete uses the AMS letters, the blackboard letters from AMS fonts. Some of the fonts look a little bit like hollowed out, but not necessarily from the thing. So the Pagella doesn't look really like Palatino, and the Scholar, no, probably also not. Yeah. So I get to the conclusion. Yeah, open-type math technology has been around for 15 years now, starting 2008. So at Bachotech 2008 is when Jonathan Q showed what he had done in XTech, and then the Polish people from the Polish font team looked at it and said, okay, this technology seems interesting and seems possible to do. And okay, the year afterwards, LuaTech followed. Yeah, you could say to users, it provides advantages in just having more symbols available and yeah, more alphabets available. You nowadays can do things that weren't really supported in LaTeX in the 1990s. So if you wanted to do, yeah, maybe you could do bold italic via bold symbol, but if you wanted to have, okay, but I also want my lowercase Greek upright and whatever, then it gets difficult. So nowadays, most of the fonts provide everything. On the other hand, it's a lot more work for the font designers and a lot more things that could potentially go wrong and yeah, need to be tested and corrected or whatever. So By now, with all the recent additions, we have over 20 fonts to choose from. The coverage of symbols has grown and improved over time, so we are actually quite good there. You could say some fonts are still lacking at the technical level. I think that's something that Michael may be talking about in the next talk. It's basically CTEG originally followed the interpretation of traditional TEG engine where the width only denotes the subscript position and the width plus italic correction denotes the actual width and the superscript position of the font. And LuaTeX has basically decided to follow the OpenType spec as much as possible and prefers the interpretation of having the actual metrics there and avoiding the italic correction wherever possible, at least avoiding the use of italic correction for denoting the subscript position and instead putting some other information in the fonts. So some fonts have already been revised at that level. I think there was a new edition of Lucida early this year, and Daniel Philippot has also updated his fonts quite a bit. On the other hand, yeah, the Latin modern fonts or TechJaya fonts haven't been changed for many years, and it's probably unlikely that they could easily change if they were revised, because that would create all kinds of incompatibilities. So they would probably have to do something like Latin Modern 2 or something if they wanted to do a major revision there. Yeah, most of the fonts that I talked here are freely available. Like the only two non-free fonts I had here were the Lucida fonts, which are sold through the TUG website, and Cambria Mass, which comes as a system font on Windows, but I think nearly all the other fonts are freely available on C10, on TeX Live. One exceptions are this unfinished things. Like I said, this Lato Mass font is interesting, but it's something like, it doesn't even come with a license, so you couldn't put it in a distribution, and the Noto font is not finished. I think all the fonts can be used with a generic LaTeX Unicode mask package, but I think most fonts nowadays also come with a custom support package, which often takes case of all the specialties like supporting stylistic sets, this and that and that. So let's say, is OpenType mask ready for use? In principle, yes. Completeness depends on what you are using. So if you're using relatively basic stuff, you don't care if it's 1200 symbols or 500 symbols, it covers, as long as it covers the standard symbols that you used to have. Stability, of course, depends on how you're using it. If you want to reproduce the same thing in 5 years, you probably better archive your tree, your fonts, your packages to maybe even the engine versions to be able to reproduce exactly the same. If you just want to say, I want to reprocess a document and then I'm going to edit it anyway, it's probably ready to use. Or if you just, I publish a paper once and I never will go back to that, then it's okay to use. Support varies a lot. Some fonts are well supported, frequently updated. Some fonts haven't been updated for many years. In some cases, if you have a system font, you never know. Suddenly, a Windows update comes and you get a new version of the font. And sometimes, yeah, it takes a long time or it's difficult to report a bug, but sometimes it gets fixed. So I think I'm quite hopeful that, yeah, OpenType mask produces a technology that's worth using, that's worth trying. And yeah, we've got a lot of progress in the past 15 years, and or even 30 years if I look back to where I started with mass typesetting in the 90s. So, yeah, 5 minutes left for questions.
Okay, thanks a lot. So, questions? Yeah, Bob.
Not a question, but calligraphic and script should not be considered alternatives to one another. They're not. A number of authors use both with different definitions for what the symbols mean.
No. Well, the thing is, Unicode only has one set of slots, but LaTeX supports both. So this with the Unicode mask package, you can say, okay, I load this as a script, and there's that as a calligraphic with a stylistic set. It's a bit difficult to access it. Needs a little bit specialized setup. But yeah, you can use, well, I know it's not the same, but you can use it.
Actually, Unicode has accepted a variation selector, except nobody has made it usable.
Okay, I didn't know that.
There's also more comment than a question. When I made the math fonts chapter in that book, I used a sample like yours, different one. And one thing that I found was nearly every font trying to do math except Computer Modern, or New Computer Modern in that case, is lacking some symbols. And it is not the question of how many symbols the font has. By the end of the day, it is the question, does it contain the symbols that you use? And I just want to give this out as a warning, because of course, with Unicode, you have one big problem in general. None of the engines are really telling you that symbols are missing, or it's very, very easy to miss. And so it's all fixable, even on a single font, because you can substitute something, but everybody who's doing this should carefully look at the log to find missing symbol such and such.
Yeah.
Because otherwise you end up with papers that are, well, basically telling absolute rubbish.
Okay, yeah.
Do you have a question? It's interesting the comments on sans serif fonts, and you found a few. The one that you didn't mention, or one that is a conspicuous absentee to me, is there's no Arial one. And the reason I say that is because I write grants where it's a requirement to that's the only font you're allowed to use, and it's very surprising that nobody's addressed that. Do you know of anyone looking at Arial or Helvetica potentially, but sometimes even that's not allowed?
Arial.
Yes, Arial.
Yeah, well, Arial, Helvetica, well, basically I think the GUS team decided they only do mask fonts for the serif fonts, so they didn't do it for, what did they call it? Heroes. Helvetica, Arial, yeah, so. Well, actually, I'm not quite sure which sans serif font is in the KP fonts package. There's some, I didn't find an explanation where that one come. Maybe that is actually some Arial thing. Would have to investigate that, yeah.
Okay. Any urgent question left? Okay, one, that is the last one.
A non-technical question with a certain danger that you just say, I don't care. The blackboard bold fonts, as the name suggests, were designed for writing on a blackboard with chalk.
Yes, of course, with a double stroke.
Should we really use them for printed matter? So I think one of the few uses is when we write a book and want to illustrate how a blackboard looks like after a math professor has written on it with chalk.
Yeah.
Otherwise, I think we should just use ordinary boldface.
I think that's some sort of established notation for like the real numbers and the complex numbers, sort of this R and Q and whatever. So that is, you could say in some fields it's established notation for real numbers is the blackboard R. Whether or not you like it, it's just that maybe a mathematician could actually say, okay, if I write something about set theory or number theory, I put a bold R or something there, but yeah, in physics it's like a standard notation. Okay, I think we're out of time.
Okay, thanks a lot again. So the next speaker is Mikael Sundqvist, but while he's arriving, I was asked to remind you of this foldable city maps that also have the advantage that they have vouchers included, where you get discounts at some restaurants and bars. For example, especially here you get 10% with some voucher here from this foldable map that you are able to get at the reception. So the next speaker is Mikael Sundqvist. As far as I learned from the abstract, he worked with Hans Hagen, and while Ulrich gave a broad overview, they got into deep and dirty details of extending fonts for Mars, and he will show some of the choices they had to make.
Thank you. Okay, so we heard an excellent overview. So let's go into details. So first, why do I talk about this? So many of these open type fonts, they have some problems. These script and calligraphic alphabets were just mentioned. At one point during our work, we were actually using these selectors. But then we find out that, okay, one font is having the calligraphic and the script as an alternative, and other fonts the opposite, so to say. So it's a mess. That's a mess. Other things that are not really working are the metrics. As Ulrich also said, some fonts behave more like old tech fonts, and some fonts behave like Cambria. And he mentioned also that the engines handle them differently. So CTEC is more traditional, LuaTeX maybe more according to the specification, but that's also a problem. There is no real good standard. If you go to the Microsoft webpage of this open type, you will find some instructions, but it's lucky. It's not what I would call a standard. So it's a mess. So what I will present, well, we've been working for maybe 1.5 years now on mathematics in context and fonts and other stuff. So I will mention to you some conclusions that we made, some conclusions with open type math fonts. There will be pictures, there will not be code because there is not so much code to show actually. For the user, and that's part of the goal, for the user, they should just enter the math as they used to do. And things should just work. I think actually it does now. So I think, I say that there is a problem and so on, but I think that actually we have come to some kind of converging, nice way of interpreting these fonts that exist. There are, I mean, we have to do changes still, but I think that there is progress, so to say. I aim this at context users, since they can use this today in context. But I hope that the rest of you will not stop listening. Maybe you can get inspired. Maybe you can actually implement something for LuaTeX as well, or Lua LaTeX. I would be happy to see that. I'm a LaTeX user as well. That could be an option. Okay, context. So as I said, this is part of a bigger math project. And I've been working together with Hans. So I'm a bit sad that Arthur is not here because the caps are from Arthur, from different Bacotex. So I think that this picture is here. Well, I know why it's here. It's here because we complement each other pretty well. Hans is doing a coding, and I trust him completely with the coding. I'm reading. I'm a mathematician, by the way. I work as a mathematician, as a researcher, and as a teacher. So I've seen mathematics for a long time. I know more or less what I want, or what I should be. So I trust him on the coding, he trusts me on the judgment. We test, we try, and maybe the most important thing is that we have a lot of fun as well. So this tech lion is, by the way, going to be transferred to Arthur's son at some point. That's a promise. It's inherited. Okay, so let's look at, okay, so we will see now some samples. As I said, this is part of a bigger project, so maybe I will actually be able to show something new at the end, which is not really about the fonts, but maybe that will just be a few glimpses. Okay, so one of the things are bad bounding boxes. So this is Bonum, but the same is true, for example, in Garamond, which happens to be the font that our university tells our students and others to work with. So we should work with Garamond. They use Garamond math now. They are very happy that there is a math font. It looks very well, except that they have to hack a lot of things because things clash together, as you see to the left. So first, when we were starting to work, we used some goodie files where we were patching fonts runtime. So we were changing the metric character by character, so to say. And this is more or less what it looked like afterwards. So it's not clashing with the parentheses anymore. But there is also there is more to say about this. I will soon say more about that. This is just to show that the different fonts behave differently. I don't know how well you see the vertical lines and so on, but you can see that Bonum, for example, has a lot of italic correction. Latin Modern has a little. Stix does not have, yeah, well, maybe no, does not have, maybe a little concrete somewhere as well. Lucida has no italic correction, so and you see that the boxes are slightly different. So the fonts are different when they come. So what do we actually do? After that, we had sitten many hours, many days, looking character by character, how much should we add, how much should we do? We realized that we could do it like this. Instead of doing it character by character, we add the italic correction to the width of the character. So please do this. And if it sticks out to the right, we add something there as well. And for the italic correction we add also a bottom kern. So there are different type of kerns in OpenType math. One of them is corner kerns. So if we add italic correction, we can also add a negative kern so that things will look okay. So let's look again. This is Bonum. It sticks out a lot. It has a lot of italic correction when we look at the font. When we put, say, subscript and superscript on it, the left picture is before, how it looked before. It looks fine, just because, well, the 1 is controlled by the italic correction, but for the subscript, that's forgotten, so it's put without adding any italic correction. But what we do is that we have added, you see, maybe you see the orange boxes, I hope so, or at least a bit. We added that. The 1 comes out exactly as it came out before, but we also have a corner kern down right now, negative, the same amount as the italic correction, so the 0 also comes out as before. So it comes out as intended, and we have somehow gotten rid of the italic correction. This is Lucida, the F in Lucida. It doesn't have italic correction at all. I don't think actually Lucida has italic correction at all. This is the same example in Lucida. Before and after, it looks good in both cases. This font has corner kerns. So here we have the 0, it's already there. Okay, so you see we have not destroyed these examples even though the fonts are behaving differently. Okay, so I stress it once more. These italic corrections, they are transformed into corner kerns. We do the same with large operators, integrals and so on. And it seems that it works very well. And after this, italic correction is not relevant. It's not used anymore. So somehow, when we load the font, this is done. It doesn't take any time, I would say. And then the font seems to use pretty well in this aspect. As I said, there are different types of kerns. There are these staircase kerns. I don't know if you have seen this booklet by Microsoft. So there are staircase kerns. Not many fonts have them. It can look like this. This is Cambria, by the way. It can be very inconsistent. This is italic V and the upright V. So we more or less decided that, okay, we ditch this staircase kerns. It's not in many fonts and it doesn't really make a big difference. Okay, let me go on. accents. Oh yeah. So if you look in FontForge, these are screenshots from FontForge, the accents are typically sitting to the left of the origin, so to say. I guess that meant that they should go back and sit over the character in some way. But of course, that should be different for different characters. Moreover, they don't have any width. So it can look like this, top, from Stack Exchange, question. What we do is that we actually give them the width and they will not clash like this. Okay, the arrow is also a bit different because these are different fonts. The first one is PDF text and the other one is context. And also the primes actually look a bit different if you look carefully. So some things are changed from computer modern to Latin modern. It can look like this with accents. If you look at the 7, the anchor point, well, it happens to sit wrong, so to say. So that's another thing that we do. We go over alphabets, which are not really italic, and maybe modify so that the anchor points are sitting in the middle. I think it makes sense. It makes sense at least for this one. Yeah, we can have different widths of some accents. So they come in a certain size, a certain set of sizes, and then some of them have come as extensibles as well. That's not valid for the hat, but the hat is okay to scale a bit. You can switch this on or off, of course. So if you don't want scaling, then you don't get it. Okay, another thing with accents, you see there is a lot with accents. There is something called flattened accents. It's available in the fonts we looked, it's available in 2 fonts. Styx and Cambria come with them. So it means that if you have slightly taller letters, the hat, for example, is just squeezed a little bit, probably to avoid spread in lines. So it's these two. The amount where this flattened accent should sit, rather, it's controlled by some font parameter. I will come to that. All the other fonts, they also set this font parameter. But for example, Erevan does not have flattened accents, but it has this font parameter. The font parameter was a bit strangely set, and now it's the time to say that Daniel Flippo, he reacts very quickly when you send him a mail and say something about his fonts. You get usually a reply the same day or the next day or something like that, with a new version to test and so on. So I really appreciate his way of working with that. So we fake them. So what we can do is that we can, even if the font does not have the glyph, we can just scale it slightly to avoid too tall constructions. Okay, so let me skip this and go on to the primes. So that was just what we did with accents. Okay, primes, short thing, they look very different in different fonts. Some of them have a base character, often sitting high, and then they have some alternatives for superscript and superscripts and so on, and they can be differently big. Well, you see this one from Libertinus, it's extremely big. Erevan has three ones sitting on the baseline instead. You see, they sit in different places. So there is a mechanism, a tweak for that. We tweak it in the GUI files font by font, so this is something that tweak will stay. I mean, we don't know how to handle it otherwise. Yeah, they always go after superscripts, that's another thing. This is more a playing thing, I would say. So when you do square roots, fractions, you get rules. Rules are by construction rectangular. I don't know if you even see a difference between these two. Well, this is Latin modern now. So the fraction bar has round ends, and the bar, which is not really, I mean, well, the bar from the radical also have round ends. So we can take glyphs now from the fonts, get rid of these rules. For Antiqua, it looks very nice because it's very decorated. Okay, this can also be turned on or turned off, of course. If you don't like it, if you prefer rules, you can use rules. Okay. Spacing. Oh, did I? Okay. Maybe it's in the wrong end. There was maybe a slide missing. Let's see. We take this instead. Font parameters, that's one of the things. So, for example, these flattened accents, they were controlled by font parameters. There are a lot of font parameters. Top row, well, this is actually the same expression, the same formula, typeset with 3 different engines. The top one is PDF-TeX, the middle one is Lua-TeX, and the bottom one is Lua-Meta-TeX. And the difference, I don't know if that's visible here, but say if you look at the superscript on the H2, in Lua-TeX it sits further down than in PDF-TeX. It can be even more disturbing for other combinations of characters perhaps, but it's not the same as it is in computer modern, and some formulas maybe don't come out really good. So what we have done there is that we have tweaked font parameters. These are controlled by font parameters. So we have tried to imitate the parameters from computer modern in Latin modern. This is maybe also the place you see a set of gray lines here. So context has a lot of helpers, I would say. So this is there is a gray line going through the plus sign, that's the mouth axis. There is the first H2, the 2 sits on one line. That's one of these parameters, so we can see exactly where it usually ends up. The second one below, it's if you have a superscript and subscript. And the 3 sits on the corresponding top one. And the prime also has its own line. So that's actually something that here we extend OpenType. In OpenType, the prime doesn't have its own, but in context it has. In Lua-Meta-TeX it has. Okay, so we tweak them in Lua files, and I think usually now most of the mod actually comes out well. So this is also combined with other parameter sets, so to say. You cannot see it here, but this formula, it consists of several different types of math atoms. So we now have the possibility to use more types of math atoms. So the first one, the 3, is a digit. It's not an ord anymore. A is an ord. Plus is a binary. The square root is a radical. The integral is some big operator. And then if we continue, we have open and close and so on. The D is a differential D. So the spacing between the closing parentheses and the D, that's controlled by interatom spacing. So we don't have to do backslash comma or something like that. We do backslash DD, which is differential D. It comes out well in all situations, I would say. And then there is a fraction class and so on. So everything is now set up in a more complicated way, perhaps, but it's also more flexible. We have gotten rid of some parameters like script space. I talked about that last year, so let me just show. This is also taken from the Stack Exchange, I think. If you add subscripts, TeX is usually adding this script space of 0.5 points or something like that. So, and if you do it several times, it can be even worse. This is set up now. It's handled well. We add it when it should be added. Okay. I think that's enough for detail. If you want more details, please approach me. I would rather, how much time do I have left? 5 minutes, okay. So let me end by showing this mouth project is continuing. So we are now, or what we have been doing during the spring mostly, is we have been looking at paragraphs, line breaking and such things. So formulas are usually broken after binaries or order relations, but we can break them anywhere if we want, set penalties. We also have in displayed formulas are handled completely different. They are paragraphs by itself in context. So they are broken if you don't do anything manually, they are broken by penalties. So that means that in a displayed formula, you don't want to break after the equal sign, you want to break before it, so you have to switch these parameters a bit. Okay. Let me go on a bit. Multiple passes. Okay. So, as I said, we are looking at line breaks and building of paragraphs now this spring. So if you look at the first paragraph, we have a line break before an X. I think everybody here knows that to avoid that, you usually use a tie. We learned that in Barbara's talk. We can do a penalty. So we can have a penalty which is valid, which is only added before short math stuff, so to say. Short math stuff is typically an ordinary. So in the second example, we have added that penalty. You see now that the X sticks out a bit. Okay? The third paragraph is run with the same penalty set, but it also ran with multiple passes. So we can now go in and say that we want to run the paragraphs not maybe once or twice with this pre-tolerance and tolerance. We can run them as many times as we wish. So we can set that up. This is how it looks right now. This is experimenting, so this might look different at a different point. So we have one pre-tolerance 100, tolerance 200, so that's unchanged. Then we say that, okay, we have par passes with 2. We can have 2 additional passes here. And then we have conditions. So this is a bit complicated. Maybe after the next, we have threshold. It says, okay, so if we have an overfull H box of 0.025 points, then run again with this tolerance and with expansion. So we can also switch on expansion on the third or fourth run. This means that if we use this H set, it doesn't have to run on all the paragraphs. It can run only on the ones where it actually is a problem. So we have tested this, of course. It doesn't add, maybe the book, the math book I have, 300 pages, usually compiles in 10 seconds, maybe it's 10.5 or something. So it's almost no overhead. And you see, we also, in this last case, we had some emergency stretch. If it's really bad, if we want to avoid overfull H boxes, we have to do something. Okay, so if you want to see this, I can show you more. Let me skip this if it was only 5 minutes. This is penalties. We can set penalties. If we have a long formula, let me just say that, we can set penalties, extra penalties in the beginning and in the end of the formula. Then we can force it to be broken more in the middle. So we maybe don't get the 1 plus on one side and the long formula, but we get, yeah, as you see here, it's plus 23 plus 24 on the top one where it's not set, and on the next line it puts the 22 down as well. I don't say that this is a good example, but it's an example. Okay, final thing. Didier showed this dynamical paragraph program, which was, to me, very cool. We have tried to understand line breaking and so on. So we have something which is a bit similar, but it's of course not dynamic in the sense that you can see exactly. You have to compile to get new stuff, so to say. So this is a paragraph from the digital typography by Knut. You don't see that probably, but there is a lot of numbers here, which are the possible choices of breakpoints of this paragraph, where the algorithm actually say, okay, here we could have broken and so on. We can get this list. This is the list for the previous paragraph. So we can see exactly the demerits. We can see the class and so on from this one. Yeah, there is 1 minute left exactly. That's perfectly fine because there's only 1 slide left as well. So we can see this. If we want to understand, okay, so say that we had this paragraph, you see there is, at the end there is only 3 choices, 99, 100 and 101. You didn't see them very well, but this is 99, this is 100 and 101 is probably down there. Sorry. So what we can do then is that we can hack into it and say that, okay, we want to break at a certain point. So probably I set it to 101 because this is 100 now. And we can see now, okay, how does this paragraph look if we took that choice instead? And we can compare. And so far, I would say that the conclusion from this is that the choices that we have been living for now in many years were extremely good. I mean, with these parameters and so on. But still, we hope to be able to improve. Okay. This was profiling, but now I have no time. This is about reducing the line spread, if it's possible. If the lines, the guilty parts are far away from each other, we can reduce it. Also, no overhead, almost no overhead at least. Okay. Thank you.
Okay, thank you very much. Are there any questions? Don't see. And oh, there is one.
So, in the end, will you give out a catalog how to make good open-type math fonts?
So, a catalog of good fonts?
Yeah, so what to do to make a good...
Yeah, well, you get some... Okay, we will write an article on this as well, that will end up in Tugboat, with suggestions, so to say. Because I think that maybe that's one of the things that has been holding, say, LuaTech back a bit. That math is not really looking good always. And I'm not sure. There's another question or comment. Maybe it's more a comment.
I mean, I suppose, I guess, with my MathML hat on, I mean, we could probably take your context goodie files and get Marcel to make them work in LaTeX. But, I mean, how much effort or would it be license problems? I mean, the alternative is to fix the fonts.
Yes, exactly.
In the open type rather than fix them on the fly in Lua, which would then help in browsers.
The alternative is to fix the font indeed. We have looked at some, I mean, we worked a bit on Lucida. So we did a lot of changes to Lucida still. So we are part of the responsible for this new release. For other fonts, Bonum, we have now a companion Bonum font with a single alpha inside. Because the alpha and the A in Bonum, they look exactly the same. So it's difficult to use by that. But otherwise, I don't know. It feels like a bit different kind of a project, and starting to do a new Latin modern, for example, that feels like a big project, and I'm not sure that we are the ones doing that. But I would invite somebody who is into fonts to do it, and I would happily discuss, because I think we know these fonts by now quite a lot.
So, anyone else? Okay, thanks a lot.
Thank you.
So it's good to see that even though Hans isn't here, he is present in many of the talks here with his work. And I don't know if he's watching via the live stream, but if he is, greetings to him. The last talk this afternoon will be Tom Haider from Overleaf, and he will talk about the combination of TUG and Overleaf. He said it will be a rather short talk, and he expects a more lengthy discussion because he wants to is seeking for some discussion, and so enjoy this talk, and after that you are invited to give your comments.
So, hi everyone, I hope you can hear me. First thing first, I hope there will not be enough. Actually, there is plenty, so feel free to take them home. I don't need to have 35 or whatever ducks at home. I already have 35 ducks at home. So that's just first things first. And then for the talk, so just a bit for the motivation. we gave a talk about how Overleaf deploys TechLive on one of the online conferences, I think 3 years ago. And we are like, maybe there is next steps, and I will explain why I think there is next steps and why I think that it's important for us to get feedback from a lot of people here, and that's what I'm aiming at. And I will just start with the abstract because I think it says a lot. So we do make an annual deployment of TechLive. Actually, good news, we just got alpha version of 2023 yesterday. So we did the first round of testing. And we are wondering whether there is an opportunity for both Overleaf and the TechLive maintainers and LaTeX developers, which is a lot of people here in the end, to benefit from our deployments and related testings. So actually, we already have one bug fix going on from yesterday's testing. Today, Joseph and Javier basically just fixed one bug in Babel that nobody was aware of until now, I think. So yeah, and whatever, I just already mentioned that we gave a talk about it. And really my personal goal as a person here, both a LaTeX enthusiast and an Overleaf team member, is get more feedback. So that's what I hope we will manage. So just a quick outline, I will explain a bit about Overleaf and TechLive, just to give the right context, and not that context, I mean. Then crash course on how we deploy TechLive, and then a bit about the testing, and then I hope that we jump to the discussion. So, about TechLive, all you need, don't take me literally please on all you need to use LaTeX. That's TechLive for us, at least that's how we view it. So it's the binaries, packages, fonts, basically everything. So TechLive has an annual freeze where we say, okay, this is just the official thing, this is the DVD time and so on. But packages can be updated daily, as is just happening with Babel. And there is some websites where you can download TechLive, and C10, which is the place where the packages live and where you can get them from in the end, you know, whatnot. And the way how you upgrade your TechLive version and package version is just TL manager update all. Nothing new, I think. So about Overleaf, so we are a LaTeX editing platform. So you can edit documents in LaTeX, basically source code primarily. We use TechLive, so that's what we use. We just deployed the full TechLive. We do an annual deployment of TechLive in Q3 every year, so we are still in Q3, fortunately, because it almost seemed like we will not make it this time because of some commitments of the people that know how to do it. And we have about 2 million users every month. So about 2 million users open Overleaf every month. So there is a lot of people that use it. If we break it, it will be broken for a lot of people. So we have to be very careful. That's why I will talk about testing later. And for that reason, we do almost no mid-year updates. So we don't want to keep too many versions of TechLive. And we want to make sure that once we say this is the thing doesn't change for the users. Because they cannot see that we updated a package. They just see TechLive. And suddenly the document can break. And I bet you there is, every hour there is someone having a deadline in 1 hour that's working on Overleaf. Day and night, weekends, doesn't matter. Theses, whatever, right? Like grant proposals for 7-digit numbers and so on. So every hour there is someone that's doing something like that. So we have to be very careful. Okay, what we do. So crash course on how to deploy TechLive to millions of people. So we have everything in Docker. So the TechLive is just basically a Docker container or Docker image that you get a container, your compilation runs in the container, we get the output data out and we kill the container, that's it. So you have to prepare the initial image. Then at some moment, which was last week, this week, you do upgrade all the packages, and that's hopefully the last time you are doing it, because then you start testing. What we do is that we make sure it has all it needs. So R packages is a common thing that we add. So when a user says, I need this R package, we have a list where we say, oh, we need this R package. In the next TechLive, the user is getting the R package. So we have hundreds at the moment, I think. Fonts, so we make sure that it has the right fonts. So we are on Ubuntu and we install like dozens of packages, Ubuntu packages for fonts. just to make sure that there is as many fonts as possible. And we make sure that it has third-party tools, think ImageMagick or Inkscape. It's typical third-party tools that people use a lot in Overleaf. Then we do some optimization, so we remove duplicate fonts, which happens a lot. So you get the font from TechLive, you get the same font from the system or whatnot. So we do have some process to see how many duplicate fonts we have. I don't want to get to the detail, but it is an important step. We remove documentation, that's also an important step, because our Docker image is about 10 gigabytes. And if you create 10 gigabyte Docker container, for every hit of recompile button in Overleaf, it gets costly. So if you can remove a couple gigabytes by removing the documentation, that's great. And we precompile the fonts, which is step I don't want to get to detail, but it's basically mostly important for low tech. So if your first compilation on a new server should be fast, then you need precompiled fonts. And then you test, and test. That's the crucial part. You finish the testing, whatever that means, I will explain later. You create your documentation. So we have a blog post about every TechLive version where we mention the things that changed, things people should be careful about. And then you go live and you monitor, and of course, in 2 days you will get 10 reports. This document doesn't work in this version, and this is wrong, and this is wrong. And you check whether it's our fault or it's someone else's fault. Or it's not a fault and the people just have to use the older TechLive version because a package was removed, which happens, of course. So that's it. And now for the testing, so we have something which we call the Overleaf Gallery. It has about 10,000 templates at the moment. And we want the templates to use as current TechLive as possible. So we try running all the templates on the new TechLive image, and we get a list of things that fail. And then we go to the failed templates and we see why they fail. Because there is a reason, there must be some change between 22 and 23 that causes the thing to fail because it wasn't failing before. So we get a list of these things. We also do some benchmarking, so we check whether some type of documents gets super slower. That's the most interesting thing. So in general, it gets a bit slower each year, but we use GCP, and GCP upgrades the service gradually during the year, so overall we are not getting slower. It's just that if you compare 22 and 23, the same document, it's slower on 23 because there is more code in the kernel or whatnot, the packages get more complicated, the fonts get larger and so on. And for the manual testing, so we take these failing templates. This year it's about 500, which is unexpectedly large number, so we smell there will be something that's in a lot of documents that doesn't work well and nobody noticed before, but we don't know yet. I found 2 bugs already. I'm not sure how many of them are affected by these 2 bugs. And also, like, we have a couple user reported past issues, like you just mentioned. This thing doesn't work in TechLive 2022, but it's not a template, so we have a list of these small things that we can test manually. Oh yeah, we corrected this, that's good. And then we discuss it with authors and maintainers. That's quite a new thing. We didn't really do it properly before. We still don't do it properly, but at least we do it. So that's exactly what's happening now and what was happening last year. Just 2 examples. One was Roman numerals, unterminated Roman numerals, which caused some very weird bugs, and it froze the compilation, which means that it just timed out after 1 or 4 minutes, depending whether you are free or premium. And you get no error message at all, basically. So that was a problem. And there was some infinite loops also over unprotected font commands, I think, so that was another problem. So we caught both issues, and they got swiftly solved, so thanks people involved. It was mostly Joseph, actually. And now it's Joseph and Javier for the first bug we found this year, just a couple hours, and it's solved, which is awesome. And you are much faster than we are, so thanks for that. And then there is just some links in the presentation if you wanted to see how the conversation went. So that's the testing, and I think that this is sort of the phase where the most help mutually can be done. So I would like to stop here, and I just have an empty discussion board which we cannot fill in paper, but we can fill it in the video. So I please want to ask you to use the microphone at all times, because I can then watch the recording and I will hear what you said, because I have no idea. I mean, I have an idea, I will not remember. That's what I want to say. So thank you.
Okay, thank you.
A question. When you find error and you try to fix, do you talk to TechLive people, or do you try to contact individual package offers when you see the error?
Well, it depends. If it's a thing like the unterminated Roman numerals, I just talk to people at this Stack Exchange chat, because I was sure that people there know better than me what to do. Sometimes it's obviously a error in a package. In that case, we just file an issue. If the person is attentive enough, then you can make it in time, but it really depends. So it depends. I wouldn't talk to TechLive people unless it's clearly a TechLive issue. I would try to find the right people where to report the problem.
Okay, the discussion is open. Who wants to say something? Yeah.
Just a slight, you said you install TechLive and then you remove the documentation. Why don't you install it without the documentation in the first place? Or is that because you're starting from a document that someone else supplies? I didn't understand that.
Oh, well, that's a good question. I don't know. I just think that this was the safe option someone chose, which seems to work well. It's just a very small step, because like whatever you do at the beginning, it doesn't matter once you have the full thing. It's just somewhere on some place, and it's just pulled every time. So that's a technical detail, I think. For us, it's a technical detail. I know it maybe doesn't make sense, but I know that there were some issues that sometimes something was missing because it was wrongly put to the documentation part of TechLive. I don't know exactly.
I know you know this, but I mean, you're taking the TechLive and then running it on whatever number of templates you've got. So many of us have got that TechLive some months before that, but what we haven't got is the templates. I know there's license issues and all kinds of issues, but it would be useful to have the testing before, because obviously you've got a limited time frame now between now and when you're supposed to ship the thing, and I don't know whether you've got any thoughts about how to make the testing happen earlier.
Yeah, good point. We would like to, I would like to find a way how we can offer our infrastructure for testing other things than just our TechLive, because that's one thing, it's late in some sense. Like a lot of the things go to the kernel or to the packages much earlier, like we do it once a year. Some people really consider freeze, so they make the deploy in March, so it's like 1.5 years. There is like now updates to the package for 1.5 years for some people, and so on. The problem with running it on the templates is that this way we make sure that the templates are correct, and that's sort of the goal. We would have to be very careful whether we can use the templates in this way for anything else. And so if we had a lot of test documents, we definitely can very easily build an infrastructure that tests all the documents. That's like, I don't say it's easy to do in the sense of like, it's no work. It is work, but it's something we can do. But someone has to provide documents with the right licensing thing, or we would have to change somehow the ways of working. But we are a bit careful about this because it's not clear whether it's our data. If someone created a template and it uploaded to the overview gallery, we have to be careful, like who has wrote rights on the template.
I think we all understand that part, but nevertheless, I think there could be improvements. What about the possibility that you are actually, at the time TechLive is going into the test phase, make your container and do your first run of this. When you then contact people, developers, about bugs, and they get fixed so that they are inside the final one, you have to still redo your testing with the final one that is on press. But with a good likelihood that the bugs are all fixed, that you are otherwise fine then, which is always a problem because then there is this discrepancy And if you can move this step to the point where the first freeze happens, I think everybody would gain, and the pressure on the community is much less. I think this is another point that we have to sort of openly discuss. I mean, it's enormously important that you are not falling long time behind. It's also important that you do updates extremely carefully. You say 2 million users a month, yes. We have the same kind of problem. We have, I don't know, 10 million, 50 million users when we switch. They are not all changing at the same time. We also need a good test base. And the better the test base, the better for everybody. So I think we are in this sense on the same board. But the moment you are in the commercial world pushing out your new version and it would blow, you put an enormous lot of pressure on outside developers doing things for free, doing it extremely fast to get things fixed. Like Joseph did it while actually was supposed to listen to talks. I don't know which one. Okay. But if this is just not the talk, but somebody's daily life work, then you put pressure on him to do it in the middle of the night. Or, I mean, not physically, but...
Yeah, I know what you mean. Yeah.
So I think we have to find ways to, well, first of all, try to get the pressure out. This was my first suggestion. And the second is also to think about how to sort of put some sort of beneficials on both sides for all the developers as well. And so that your stuff is working very, very well and they have a lot of incentive with the stuff.
Yeah, agree. Just to make sure, just maybe a quick question from Frank. When is the first freeze exactly?
When is the first? Okay, this is done by the Tech Live team. They have a schedule and they say at this point we freeze and the testing start, and then there's about a month or so, or maybe 2 months of testing the frozen version. And if you can put your tests at this point,
you're suggesting to align both tests.
Yeah, you have to do it twice. You run your stuff when the freeze comes, you find possibly bugs that others do not find, they get fixed so that by the next time your second check is
yeah, well, yeah, I agree, thank you, this is an important point. I will talk about this with the company and maybe get to you back. This is important. Just a quick note, running the test is cheap. Like, it has zero cost. The cost is half an hour of a developer time, like literally. So that's the easy part. But yeah. So yeah, agreed.
I'm interested what manual testing means with the goal of asking what can be automated. I think you have gallery templates. Are these complete documents that can be processed completely, or have they filled up with some blind text? Is there the possibility to transform or migrate manual testing into automatic testing, not debugging, but just being able to say this works, this doesn't work? I think this would be an infrastructure which would be of great interest, not only for you at Interleaf, but also for kind of cooperation with people like the Tech Live distribution who has to run similar tests as well. Or actually people like me, I'm a Xindi, the maintainer, and they call me up and I have to do my regression tests before the Tech Live is produced. Yes?
Yeah, just a comment, as I mentioned, it is tricky how much we can open the tests to public. So that's one thing. The other thing is, yes, all templates in the gallery are complete documents in the sense of like they have to compile. So one of the requirements for a gallery template is that it compiles without errors. So yes, they do compile without errors. Actually, that's the 500 failing. They are maybe not failing of not producing a document. They are failing of producing an error. That's what we mean by failing. So So yes, that's what we do, and they are complete documents, and they always have to have a PDF version and everything. So this part is I think clear. But as I say, opening the testing facility is complicated, also infrastructurally, because like yes, we could do it automatically, but currently it's really just a developer opening a new virtual machine on one of our servers and running a script, which is automatic in the sense of you don't have to click something 10,000 times. But it is not automatic in the sense of someone can come and click a button on the website. That would be a completely different thing and completely different infrastructure, obviously. So that is that is something that's I think out of the scope of what we can realistically do, unfortunately.
One question there I mean, I see that for the template galleries, but you also mentioned that you do manual testing for user-reported past issues. And that sounds like something which really should be automated, especially to run these more often and for longer times. Are these generally issues which are already reported upstream in some coordinated way? And are there test cases there which are actually reduced enough not to contain private data?
Okay, so for what types of issues, it's not many. Like the user-reported past issues, it's single or double digit, probably mostly single digit, so that's not really significant. What we generally do on overleaf support, if someone reports an issue with a package and we believe it's an issue with the package that hasn't been solved in the latest version, we file a report. I have filed tens of reports this way to various packages just based on things that came to overleaf support. So we do that. Usually it's things that even don't have to do something with TechLive. It's things like your Ghost script needs this special option to work in this case. You should update your Ghost script. We update the Ghost script in the next version and we check whether it works correctly or not. It's mostly these more technical things outside of TechLive actually that happens this way and where we really need to manually test because we don't have any other way basically.
I understand that you don't want to deploy a current TechLive, even if I think it's really a pity, because I think many users would benefit if they could actually try stuff, really new stuff. But it would be at least nice if you internally could test with a current TechLive. Run them. If you can run them, it's cheap to run them, then it would be nice if you simply install internally a current TechLive and run the tests perhaps, and so that we catch also new errors and not months behind.
Yeah, and thanks. We have been thinking about it. So far we haven't found enough incentive to really consider how to do it technically, because the main problem is, so you either make it completely internal, in which case it's not that useful. In that case, it's much more useful to run the templates against something manually in January. I mean, manually in the sense of like in a batch script in January and get the results. For having a latest version, even very experimental, even after 5 warnings, it's experimental. Someone will use it for their thesis. And at one day, someone will push something to C10, and one day before the thesis deadline, the things will die. And the person will depend on the latest and not on the stable, and will be completely doomed. And I am very strongly tempted to say that as far as this is a concern, it will never happen. Because that's a concern we take very seriously. More seriously than the speed of development of TechLive.
So maybe adding to Ulrike's suggestion, I mean, it's a political decision whether or not you want to make a nightly TechLive version basically public to the users. That's one part of the story. I totally understand that you don't want it because it might break things for a lot of people. On the other hand, some people might want to have the choice, so this is a political thing that you need to decide. But what if you build a nightly TechLive for like a nightly build job and only run this internally? You said running all these templates is a thing that takes like half an hour or something?
Yeah, half an hour of dev time and then it runs for 1 day or something.
Okay, but still it's something that is doable, and even if you don't do it like daily, you could do it like once a week or something. Just running this internally in like a CI job, then you have like a more or less immediate feedback that you could also feedback to the Tech Live developers or package developers or whatsoever. Because you have like a nice set of benchmarks basically that would also be interesting for the community. On the other hand, like Joachim said, he has to run his regression tests and other people have to do that too. So this is, I think it's something that could be back and forth running and everybody could profit from that.
Yeah, to your first questions, I'm afraid there is legal implications I'm not willing to talk about here, about nightly builds against the gallery. For the second point, yes, one thing I would be considering is giving access to something like that, which is a whatever bi-weekly build, weekly build, to actual developers. So anyone who has a package on C10, for example, that would be a way I was thinking about. Whether it's a good approach, I don't know. It's just some thought somewhere where I was talking already to people over this meeting and was thinking like, we have to do something, like this doesn't make sense and we need to do something. So one idea was doing this, in which case like you at least have something available, but I don't know if it's useful, you know, it gets complicated.
But excuse me on this point, because I want to go into the same direction as him and Ulrike. If I understand you correctly, the intention is when you do this testing that you described, that by the end of the day, this version runs the overleaf galley templates without errors, and this is the point where you then at some point turn the switch and you say 23 is available, right?
Basically.
So basically, all your tests that you did say success. And this happens after some things have been fixed, or you decided this year this one is not working. So basically you have a starting point. So if you internally, and not daily, nightly, whatever, but say weekly, repeat this on the current Tech Live, just internally for you, it should always stay the same. If not, there would be an enormous benefit if the problem is found then, passed through upstream to the developers that are in some sense responsible, whether it's LaTeX team, other teams, whatever, and it is then fixed throughout the life cycle rather than at the next year.
Yeah, I agree. Yeah, I didn't mention, maybe just that's an important comment. So if a template fails and we cannot fix it, we just keep it on the older version. Actually, we have a funny situation. 300 templates that failed on 22 are not failing on 23 because something. I have no idea. I haven't checked the details. I have them somewhere. As I said, it's yesterday's thing. So this happens as well. So yeah, that's what we do in the end. And as I mentioned, like it's only last year that we actually did this sort of like live debugging of Tech Live between Overleaf and the community. So it's, for us, it's a new approach, because before we just said this template is failing and we document it in the blog post, and that's what we do. We really try to improve the process, and really try to get better version of Tech Live in Overleaf. If it means starting sooner, yes, fine, we can look into that and try to find the correct time at the capacity at the correct time to do that, because there is something involved, of course. If it means doing more testing than once in July or June or something, yes, that's something we will consider. So thanks for both these ideas. And yeah, so that's it, I think, from me.
Okay, so thank you very much for this talk. Thank you very much all the speakers of this afternoon. We have a 6:15, so I want to stop here because I don't want you to give you an excuse to attend the banquet in t-shirt and shorts. And if you do, yeah, but then that's your decision, not mine, and you can't blame me that I didn't give you enough time to change your clothes. So we start 6:45. Gerd will guide us to the underground station. He will care for the tickets. He will care for everything. You only have to care that you are ready at 6:45.
And people coming from other hotels, People coming from other hotels can actually go to the station Hauptbahnhof themselves and hope to find the train. I put all the info in the booklet, so you should know which train you need to, in which direction it goes.